Welcome to the course on Cloud Services and Security. In this course, we're going to take a detailed look at what are cloud services and the different modes of implementation of cloud services. Then we have to come to the recognition that in order for us to secure our use of cloud services, we first have to secure our own IT infrastructure. So we're going to take a pretty good look at how will we implement good, strong, and cohesive security for our own information systems. Once we are comfortable that our own internal information systems infrastructure is secure, then we can begin to prepare for using the cloud and remaining secure in the cloud. We'll look at how we will then prepare our internal information systems for how we can then migrate into the cloud and migrate securely. One of the core concepts that we deal with when migrating into the cloud is how to properly develop a cloud services agreement. What are the major features that we should include in this agreement? And if we don't have these inclusions in the agreement, perhaps we shouldn't proceed with cloud services. Now that we have a secure infrastructure, we have prepared ourselves for secure implementation of the cloud. We have a fairly detailed and comprehensive cloud services agreement. We will begin migrating into the cloud. And how should we migrate into the cloud and then stay secure with our use of these cloud services? Then we'll perform a wrap-up. That'll be a quick review of what we learned and several practice questions for us to look at, just to refresh our memories on the things we've learned. In this lesson on cloud services and security, we'll be taking a look at what cloud services actually consist of, and what are some of the architectural implementation modes or models. The National Institute of Standards and Technology has produced a special publication in this SP 800 series, and this one is numbered 145, and it defines cloud computing. It actually is a very good read. If you get the chance, you might want to download this particular document. That's Special Publication Series 800, and it's Special Publication number 145 in that series. In this document, they define cloud computing as being ubiquitous, which means it's easy access, it's ever-present, it's persistent. It's also convenient and on-demand network access. So this says we should have rapid and easy connectivity with this, typically very high-speed connectivity with high-capacity resources. This is this shared pool of configurable resources, and this would be storage, processing power, and connectivity, along with perhaps even some specialized applications that these cloud service providers provide. Another aspect of cloud services, they are rapidly provisioned. In other words, once I establish an account with a cloud service provider, I can go from needing 2 servers to 20 servers or 200 servers or even 2,000 servers with just a handful of mouse clicks. I should be able to do it largely on my own. I might have to negotiate, well, I need some higher level of account with the service provider, but fundamentally, once I have the right type of account, I should be able to provision my own special services on demand as I need them, and I should be able to accomplish this without too much interaction with the service provider. We have on-demand and self-service access to these cloud resources. We once again should be able to log into our account at the cloud service providers and simply enable features and resources that fit within the particular type of account that I might have enabled with the cloud service provider. In addition, we should have high speed, high capacity, high availability network access. I should be able to connect into this cloud services arena from virtually any location and using virtually any type of platform. And this would include Windows operating systems, Linux operating systems, Unix operating systems, and perhaps others, as well as workstations and servers and MacBooks and pad devices, even smartphones and other thin clients. As long as they can connect to the internet in general, we should have easy access, easy connectivity to these resources in the cloud services arena. We will typically be operating on virtual servers, so the infrastructure that we connect into is typically going to be virtualized. In other words, these are virtual machines. Now, in a well-organized virtualization environment, the virtual machines are actually operating on a cluster of host systems. The actual hardware that these virtual machines run on are a series of powerful computers that are clustered in an array, and the virtual machines simply migrate from one system to another in an automatic load-balanced environment. In other words, once we establish our virtual machines in this cluster of hardware on the host systems, the individual virtual machine, the guest machine, may actually reside on any one of those physical servers that are the host. And it's difficult for us to identify where they are unless we put specialized controls into place and require that they do not migrate. We have a very automatic, load-balanced, very dynamic computing environment, and this optimizes for the best possible performance on the resource pooling that these host systems in this cluster array form. Because of the virtualization on these systems, it's very easy for me to duplicate one of my existing baseline virtual machines and simply replicate it. So within a matter of a few minutes, I can go from one PC or virtual machine to 2 or 4 or 8 machines very, very quickly. And I can scale up and scale down as I need to, and I don't even need the cloud service provider to be involved for the most part. Once I establish my account with them at the proper level, from that point forward, I should be able to spin up or spin down virtual machines at my discretion within the constraints of my agreement with that cloud service provider. And once again, that cloud service provider will be monitoring and metering the amount of resources that I'm consuming. I pay them a monthly subscription fee, and then I might pay them perhaps on different resources that I demand, such as high bandwidth requirements, high RAM requirements, and things along these lines. Another area where I might have to pay extra for services in this cloud services agreement might be for specialized security. So if I have really rigid security concerns, very high level of security requirements, I might pay for extra isolation and segmentation, because many times I'm not the only virtual machine guest on this array of clustered servers. In other words, there are multiple tenants that are also running virtual machines on this clustered array of physical host servers. Now, these cloud services operate at different levels. They can provide us simply access to applications called software as a service, where the cloud service provider provides all the infrastructure, all the host platform, and also the software applications that I and my users in my corporation need access to. So the service provider is primarily providing me access to these applications. That's my concern. The rest of it seems to be under the hood for me, the user in this case. If I'm only trying to use software as a service, that's my primary focus. And the rest of these services, such as the underlying operating system, the desktop, if you will, the platform, and the infrastructure underneath, that's the networking component of it, and security services, I'm simply trying to gain access to specialized applications that the cloud service provider is providing for me. Now, the next level of service is called platform as a service. And this is where the cloud service provider might provide me access to desktop systems. And then I can deploy my applications onto these desktops that the service provider is providing me as the service. So now this would be where I'm running my own custom applications. Perhaps I've bought licenses for various applications. Maybe they help me run my business or my production line or something along these lines. But the cloud service provider provides me the desktops, if you will, to run my applications and the underlying infrastructure. With platform as a service, the infrastructure is still provided typically, but it's not exactly the objective that I had in mind. It's simply a requirement in order for them to satisfy my platform needs. Finally, infrastructure as a service is the lower of the three models here. Infrastructure provides me the raw services that a client might need in order to operate. And from here, I would deploy my desktop machines, perhaps as virtualized machines, on their infrastructure, on their servers, and I might have 200 or 2,000 or 20,000 workstation machines, 100 or more server machines, etc. And I install then the operating systems and the applications that my clients need access to. So once again, we have software as a service, we have platform as a service, and we have infrastructure as a service as the three primary cloud services. What you're going to see is there are several other ancillary services that a client might need. However, these are the top three services that we would primarily opt for when we are looking for cloud services from a service provider. Picking up where we left off, we're looking at what are cloud services, and we were analyzing the different models of cloud services: software as a service, platform as a service, and infrastructure as a service. We need to understand that software as a service, in this model of implementation, we're simply acquiring applications from the cloud service provider. And in order for them to provide us those applications under the hood, they also need to provide us the underlying platform and infrastructure so that our thin clients, our mobile clients, and whatever other types of clients we might have on our corporate infrastructure, or perhaps even roaming and remote accessing these services, they all need to be able to connect in and have these applications run in the cloud. Once again, these software applications are being provided by the service provider in software as a service. Now, we're implementing platform as a service as the desired goal for our cloud services. In this case, we're simply providing the ability for applications to be hosted on these platforms that we're acquiring from the cloud services. So in essence, we're leasing, if you will, desktops from the cloud services provider, and we're installing our own customized applications that we find is beneficial for us to utilize. In this case, our goal is to get a desktop from the cloud services provider. However, in order for them to provide that desktop or the platform, they also need to provide us the underlying infrastructure. So platform as a service relies on the underlying infrastructure also provided by the cloud services provider. And then finally, on the low end of this will be the infrastructure as a service. And this would be where they would provide us the virtual machine and the underlying infrastructure to satisfy that virtual machine. They would provide us the virtual networking and security components that live under the hood. In essence, they're providing us raw storage, raw computing power, and raw memory, along with raw connectivity services. And then we implement our desktops, such as servers and workstations, and then the applications that we need on those servers and workstations. This would be what the client would provide. So once again, we have software as a service that has an underlying dependency for the platform and the infrastructure being provided by the cloud service provider. In platform as a service, the cloud provider would provide those desktops as well as the underlying infrastructure as a service. And finally, if we're simply acquiring infrastructure as a service from the cloud services provider, they're providing us those raw materials, those raw resources, computing power, storage, RAM, and connectivity infrastructure. Now, these deployment models also can be privately owned, which would make this a private cloud. Now, these can be very expensive, so many organizations won't exactly have the financial resources or other administrative resources to assemble and administer their own cloud. And in those cases, then we move towards one of the leased services like a community cloud where there would be joint tenancy. This joint tenancy, by the way, will increase our risks as we operate with our valuable information assets and our intellectual property in this community cloud. Now, the community cloud gets this designation because there is some common thread that relates the various types of clients together on this particular community cloud. It might be that we're all in the same real estate community, or we might have similar security needs. There's some common thread for this community, and this would be like the marketing angle that the cloud services provider might have taken to aggregate their collection of clients. So there's some common thread that links the different tenants together. We have some commonality between us and amongst us, and this is what draws us to this particular cloud service provider. Once again, because these are joint tenant systems where multiple different clients or tenants are residing on this series of cloud servers, there once again is some increased concern and increased risk about the shared resources, as some other customer of this community cloud provider might try to access some of my information or might inadvertently gain access to some of my information. So we have to be sure our security services are sufficient to satisfy the demands in this joint tenant system. The next level down is what we call a public cloud. And the public cloud simply is a cloud service provider who, without too much regard, as long as you can pay the bill, this guy is in a position to sell you the cloud services that you need. And there is no commonality in the nature of the clients other than we all seem to need access to these resources that the cloud service provider provides. Once again, this is a multi-tenant or joint tenant system. And because we're sharing these hardware resources and virtualized resources with other unknown clients and customers, there is this increased risk, this possibility that my valuable information assets might be exposed and potentially compromised by some of these other tenants that might co-inhabit this same collection of physical hardware servers that host the virtual machines. Perhaps even a different dimension of the types of models the cloud services may be acquired in, or whether they are an internal cloud or external cloud service. Internal cloud typically means that one company owns all of the cloud resources, and in most cases this is a private cloud. In other words, the company builds the internal cloud for their own internal and private use. And this is probably the most secure implementation for cloud services. However, recognize that this also gets very expensive in hardware and maintenance and ongoing administrative costs. It takes a fair amount of skill and cost to keep this internal cloud up and running. However, it is the most secure of all the models. Now, the community cloud and the public cloud typically are going to be external clouds. And this would be where the third-party service provider is hosting these cloud services for any number of cloud tenants or clients. Once again, these would be joint tenancy and also with the increased risk. Now, it is possible to privately own an external cloud. We will lease rack space from some service provider, and then we can implement our own systems in some co-located remote location. Now, this is very often done for disaster recovery planning and prevention of these disasters. If I have critical business processes, I might not want to take the chance on keeping them all within my one facility. So I might build myself a private external cloud and host it on some cloud service provider's systems in some far remote location. For example, I might be in Oshkosh and I want to lease some rack space in Schenectady so that if something bad happens here in Oshkosh to my facility, some disaster, some flood, some earthquake that destroys my whole facility, I have all of my data and all of my applications co-located somewhere else. However, I still am able to regain access to these through the cloud services interfaces and networking. In most cases, external clouds are commercially owned and they're leased space with joint tenancy. However, keep in mind, even as a private cloud, I still might decide to locate some of my private cloud internally and some of my private cloud externally. To summarize the different types of cloud services that might be available or employed by your enterprise to satisfy your computing needs, we'll start with the private internal cloud. Once again, this is the most secure implementation of cloud services. The kicker, though, is you pay for it all. This is a high capital expense. You're investing hundreds of thousands of dollars in hardware and storage. The good news then is you own it and you are the only one allowed to use it. So it's for your own personal private use, and that's why it makes it so secure. The next one down is the private external cloud services model. And this is a little less secure than having your own internal hardware and software running your cloud services. So in the external model, it's less secure because you are leasing this computing space, whether it's the software as a service, the platform as a service, or the infrastructure as a service. You lease this processing power, this platform, etc. It's likely a multi-tenant situation where you have other clients using this same collection of resources. You're leasing it, and the notion is that you're going to be running on dedicated hardware, less expensive than if you bought the hardware outright. But the environment that you're in, the data center, if you will, that you're in, where you're leasing the space, is likely to have other tenants leasing computing systems and things along those lines. So while it's multi-tenant, in theory, they should not be running on your hardware. Your hardware should be dedicated. Usually this is fairly cost prohibitive for a company to run on this dedicated hardware and still have it private for them, but something that they're not owning. So a lot of times this isn't a very common implementation. Next, we're looking at the community internal cloud services. This is where you pay for it. This is capital expense. Again, tens of thousands, hundreds of thousands of dollars, perhaps even more in investment in this cloud infrastructure. While this is somewhat secure because you own it and you're managing it, you know it's your fingerprints on the systems, because it's community-based, you are actually sharing these cloud services and these resources with other symbiotic enterprises. Symbiotic in a sense that this is what makes them a member of your quote-unquote community. You have some business relationship, something in common that makes you somewhat more trusting of these and somewhat motivated to help these other enterprises. Once again, this is multi-tenant because you're sharing space on your cloud with other enterprises. So there is some exposure potentially to your resources in this cloud environment. The next one down is community external. This is where someone else is providing the cloud services. You are leasing space on their cloud environment. This is still somewhat trusted because of this symbiotic relationship that makes these businesses that are sharing these cloud services part of the community. It's less secure, but it's a lot less expensive, and somebody is trying to help you out because of the symbiotic relationship that you have with whoever it is providing these community cloud services. The next one on the list is the public internal cloud services. Now, this is not terribly common. This is where you become the cloud service provider. You're the one who's building this cloud services infrastructure, and then you are selling or leasing access to your cloud. And this is to anyone in the public who wants to pay you the money. We'll make you space. We'll give you desktops. We'll provide all the resources that you might need. Next one down is public external. This is probably the most common that we would be accessing, and that is where we are leasing services from some cloud service provider, such as Microsoft's Azure and Amazon Web Services that we looked at in preceding videos. This is one of the least secure deployments because of the multi-tenant situation. So this is probably the single most hazardous, but also the single most common deployment. And then finally, we have the different combinations of these different services to satisfy your business needs. You might build a smaller internal cloud for a few $100,000, and then you might also find that for some less sensitive information, you have an external community cloud that you do some work on, and you might even use some public external resources. So you might find different combinations of these various deployments, what you actually find you need to satisfy your computing requirements in the enterprise. As we continue looking at the different deployment models for cloud services, we were looking at private cloud, community cloud, and public cloud. Parallel to that, we also have the opportunity to make the cloud an internal cloud or an external cloud. As we start to satisfy our specific and very well-defined needs, we might come to the realization that we need a hybrid of these types of clouds, not just one form, but multiple forms. We might need access to a private cloud as well as access to a community cloud. And these resources might be wholly owned by the enterprise, making them an internal cloud. And we may also, parallel to that, have to lease space or resources from a cloud service provider, making it an external cloud. So as we begin to merge and mesh these different types of models together, we develop what we call a hybrid cloud. Here we're going to take a look at actually who owns the cloud resources and who manages them and where they're located and what type of environment might this be. So this is actually a pretty good summary, and this was pulled out of a document called Security Guidance for Cloud Computing. This is their third version on this, and this is from the Cloud Security Alliance. The URL for this particular document is down on the bottom of this slide, so you might want to go grab this document as well, because it provides a great overview as to cloud services and how they might operate, how you might identify an appropriate level of risk and the type of deployment mode, etc., that you might be interested in. First, we're going to look at the public cloud. As we said prior, the public cloud is typically owned by a third party. This is some business provider that we are leasing either software, platform, or infrastructure from. And once again, there are additional ancillary services that help to support these primary three. But these are primarily the ones we're talking about, and that's software as a service, platform as a service, and infrastructure as a service. So once again, public cloud is owned typically by the third-party service provider. This is some external entity. It's managed by that entity as well. It is not stored on our property, therefore it would be an off-premises type of location where these resources might be physically housed. Because it's a public cloud, this will almost certainly be a shared resource with multiple tenants. This increases our risk as a consumer or user of these services. So the public cloud is one of the least trusted operating environments. Now, the hybrid cloud would be a combination of public and private. And in the hybrid cloud, we might have our own private cloud for the resources we don't feel we're comfortable putting on someone else's servers, giving them access to these very sensitive, very valuable information assets. So we're going to hold those privately. But at the same time, we like the cost savings and we like the rapid growth and deployment that we have if we use a third-party service provider. So we might use both a combination of internal owned and external owned resources. And then we will have also a hybrid of the different management. We'll have to have our own internal administration for our resources, and we'll also be paying that third-party service provider for their administrative efforts to support the services that we are leasing from them. So in the hybrid, we have both organization-owned and organization-managed resources, as well as third-party owned and third-party managed resources. Because they're private and public resources, we may hold some of our information assets internal, and they would be on-premises, as well as off-premise information assets with the third-party service provider. And once again, this hybrid approach gives me the opportunity to have a trusted cloud environment where I have my most valuable, most sensitive resources that I wouldn't want to expose to others potentially. Services or the models identified here in the middle of this diagram, these are the private cloud and the community cloud resources. So private cloud, as we said, typically we own it all, we manage it all, it's on our own premises, and it allows this to be a very trusted computing environment. This is my safest cloud computing environment. The community cloud is perhaps something I build and provide access to because these are somehow symbiotic to my business. And in this example, I might be the one that hosts these resources, and I let others purchase them or lease them from me as kind of a favor to them. However, very often, these community cloud services are third-party owned and operated, in which case I'm one of the members of this community, this symbiotic relationship collection of businesses. So I'm just leasing space from this third-party provider. So in that case, it's kind of as bad as the public arena, where it's a third-party owned collection of resources, third-party managed. I hope they're doing a good job. It probably is going to be off-premises. In other words, it's not on my property within my walls. And I have a little more trust for this community environment, but it still is untrusted because they aren't my business. They are somehow symbiotic, and while that lends itself to some level of increased trust, it still is not the same level of trust that I have for my own internal employees. So we would still say that that community cloud has some increased level of trust, but still is not fully trusted. Now, moving forward, we're going to look at the benefits of using cloud services. In this case, our primary benefit of moving to cloud, especially if I'm leasing it, is the tremendous cost savings. Instead of my purchasing 100 new server class servers, the hardware and the operating systems, and having to provide the facility for the data center where these are going to be housed, the air conditioning, the redundant power, the administrative effort, and all the software that I have to buy, those costs are typically considered to be capital expenses, and they can be very, very high. We could be talking hundreds of thousands of dollars, if not millions of dollars, just to get a basic cloud infrastructure in place. But instead of my spending that major money and tying up all that capital right up front to buy this hardware, instead of doing that, I'm going to lease space on someone else's cloud. In other words, either the community cloud or the public cloud. In this case, I convert my cash outflow from capital expenses, big chunks of cash that I tie up right now, but then I own the assets. I'm going to convert that into operational expenses, where it's almost like a monthly fee that I'm going to pay, and it's a small fraction of that original capital expense. So I'm shifting from what they call CapEx or capital expenses into operational expenses, and this brings my month-by-month cost way down. Of course, I'm paying the other business, this cloud service provider, money to provide me these services. So in a way, I'm giving them extra money. I'm paying a higher price overall. However, I'm kind of leasing this space, and very often that's very cost effective. Another major benefit of using cloud service, very often if I were to buy all this hardware, all these capital expenses, own all these servers and all this storage and RAM and processing power and applications, I might not use this stuff 24/7. Which means that my utilization of these resources are way low. As a matter of fact, studies show that most servers only really operate at about 20% of their capacity. In other words, I'm only consuming 1/5 of the potential of the system. So a normal hardware server really only operates at a small portion of what it's capable of operating at. So instead of my laying out all that money and watching this time go by where I'm almost wasting these resources, why don't I just consume resources as needed from somebody else, and I pay them this small monthly fee? In addition, I don't have to allocate man hours to the administrative effort of managing this huge data center, if you will. Let's pay them the fees for administering this environment. The cloud environment also allows for fast and easy business implementation. So if I decide I need to shift gears and change into a new direction or start up some new division, it's very easy for me to spin up a collection of new servers and get that process online very quickly, rather than I have to build my own data center with new hardware and new software and new networking and new security and the whole 9 yards. So it's easy for me to spin up new business implementations. It's also for me to scale up these implementations or scale them down as needed very quickly. Scaling capacity adjustments are very quick and easy as well. If I'm deploying software and developing software, the platform as a service is very often my best choice. They provide a lot of the infrastructure that help me with my software development and deployment in my software development lifecycle. If I'm developing applications, we have a shortened software development lifecycle as well. Finally, one of the biggest reasons to go to cloud is because they take care of all of the redundancy and the fault tolerance and the disaster recovery. So if anything gets bumped off of line, the cloud services are very easily spun up in some other location. If my one data set and collection of applications, if that data center goes down, my applications and data set also reside on a secondary location, and all I need to do is shift my point of connection, and suddenly I have access to my resources and my applications once again. At this point, we've pretty well reviewed the traditional models for cloud services as the average consumer would view them. We're going to look at sort of a backwards view of cloud services. It's kind of like we reverse the roles. It is a form of cloud, so that's why we're adding it to this series of lessons. In this case, what we're looking at is distributed processing. This is where there is some large computing project that if we left it to a single computer, or even if it's a monster computer, it's still going to take decades to complete the project. What happens is we distribute that load to 1,000 or tens of thousands or perhaps even more computers. This project is managed by a central project control that will dole out pieces of the processing work to various clients. Now, those clients very often donate spare CPU processing time, and they install an application on their local computer and then reach up to the central control that's managing the project. The central control doles out a chunk of the processing work for that one node to perform, and then in the spare computing cycles on that machine. This would only happen when perhaps somebody goes to lunch, for example, or if the machine is idle for 10 minutes. That's when this background process would kick in and would simply run the processing that the application and the central project control doled out for that one machine. So now what we have is thousands of client workstations that in the background, when perhaps even the screensaver kicks off, and that's the one way that these are deployed, is that the screensaver is this actual distributed processing application for this kind of reverse cloud environment. So when the screensaver kicks in, the computer will start working on the data that the central project control is pushed down to the client workstation. It chugs through the processing, and it continues to do this processing until, of course, the user comes back and activates the system and says, I need my time back. And the application now goes back to sleep until the machine becomes idle once again. So in this case, the client workstation is actually providing the cloud services. These are ubiquitous, they're distributed all over the place, they're constantly available, and they simply link into this central project control that doles out their tasks. Now, there's a classic reference model for this called the Open Distributed Processing Project, defined by the International Telecommunications Union as their project or their reference model X.900. Now, these guys also wrote things like X.500 for directory services, X.400 for the original email standard. So they built this open distributed processing reference model and published it so that if you did have such a project, you might too reach out to the public and ask for their help, their volunteering of their unused processing time. Now, the International Organization for Standardization has also developed a standard, very similar reference model for this open distributed processing project, and they call theirs the ISO IEC 10746. So there are some standards on how this type of reverse cloud works. One of the foundations of this model is it performs what they call viewpoints modeling. They break the project up into several different facets. They call these viewpoints, and these viewpoints collectively assemble the entire project. But the project has to be broken up into many, many, many small pieces and distributed out to these many workstations that aren't real powerful processors necessarily. It's just the sheer volume of volunteers, the ongoing, perhaps even 24/7 background processing. When the machine isn't busy doing something else, work on this. So it takes great advantage of unused clock cycles on the thousands or millions of workstations that are out there that perhaps volunteer for this project or be assigned this project. Now, interestingly, UC Berkeley has a project that they manage called the Berkeley Open Infrastructure for Network Computing. BOINC is the name for it. The URL is here where you can actually go sign up and volunteer for this distributed processing where you become the cloud in essence. And the client is then the BOINC application or project that they're trying to plow through. Now here you see we're at the boinc.berkeley.edu website. First you choose the project that you want to work on. Then you'll download the BOINC software. That's your client software that links up into this central BOINC project management application or server. And this is based on the project that you've volunteered for. They then will push down the data sets that they want you to grind through and return the result sets back for. Let's say we want to go look at these projects. So here we click on View Projects, and as you scroll down, you see there are huge projects here relative to mathematics, physical science, and astrophysics. So all these heavy computing projects that might take decades to process all these numbers. We now are volunteering our systems to contribute to the development of new technologies and new revelations, recognizing new trends and patterns, things along these lines. Astronomy, cryptography, astrophysics, chemistry, epidemiology, cognitive sciences. One of the more popular ones is the SETI at home. This is the search for extraterrestrial intelligence. And this is where they aim their radio telescopes at various portions of the sky and collect radio data. The problem is, while they can record this information, they don't have the processing power or time to actually analyze the data and identify these patterns. So they're looking for you, the home user, to volunteer for this. When your screensaver kicks in because of computer inactivity, this is where we want BOINC to push down that data set and let your system start plowing through this radio frequency information and analyzing to see if you can identify patterns. These would be the aliens talking, or their television stations, or their radio stations propagating out into space. So as you can see, many different types of projects that you could volunteer for. Depends on your sense of community service and things along these lines, benefiting mankind. So feel free to volunteer for some of these. And as you see off on the right-hand side, they support many different platforms. This is an example of a reverse cloud type of environment. The workstation becomes the core of the resources, and the client is BOINC or some project that BOINC is sponsoring or supporting. So this is kind of an atypical special case of cloud implementation. Picking up where we left off at our look at what are cloud services, we're next going to look at if we were going to build our own internal cloud, what would that look like? What kind of hardware and software would we need to put into place? We're going to first build a cluster array of servers that are actually going to be the host systems, and then we're going to run a hypervisor on these clustered servers. That hypervisor will allow me then to support many virtual machines that will be the platform as a service that can be further extended up to software as a service. First, what we see are 3 servers. And we call these clusters and instance 1, instance 2, and instance 3 in that order. So these 3 pieces of hardware would be very beefy on RAM and CPU processing. And if you notice that large blue hard drive storage container, they all have shared storage, which means they all are looking at the same collection of files simultaneously. Now that storage, that's where all the virtual machines will operate. So the virtual machines will live on this shared storage. It's very high performance, it's fault tolerant, it has regular backups and redundancy, only it is dedicated to this cluster array, these 3 computers in this particular diagram. You'll also notice that just above these 3 servers, there is a network connection. And that network connection is for what we call the heartbeat. Now that is communications between these 3 cluster server members in this diagram, and they are continuously sharing their stateful information about the activities, the clients, the loads, the session states, if you will, for each of the client connections that they're currently supporting. So at any instance, all 3 systems know what the other 2 systems are doing. exactly what they're accomplishing, what sessions they have, what connections, what stateful applications they're running, and actually what the state of those applications are. So that if any one of these servers were to shut down suddenly, let's say a power supply failure, the other two servers would automatically know what that one server was working on, and they would equally distribute the load from that first server and settle it into their own workload, sharing that continued connectivity for those clients' stateful sessions. So in this case, if any one system fails, the other two systems pick up all their tasks, all their connections, all their sessions, and continue on as if nothing ever happened. Now, of course, the performance will degrade some, because instead of having 3 systems to load balance across, I now only have 2 systems that I'm load balancing across. But other than that minor degradation in performance, the users probably are not aware of this failure that just occurred on one of the cluster members. To them, that's a non-event. Now, the client connection into this cluster array is from the lower half of this diagram. And the clients would access the clustered array by using a shared cluster IP address. While each of these 3 systems would have their own discrete and unique IP address. And in this diagram, the server on the left is going to be addressed at 172.16.10.1. The one in the middle is 172.16.10.2. And the one on the far right is 172.16.10.3. Those are their each unique and individual unicast IP addresses. However, because they are presented to the clients as a single system, the client only knows that there's one machine out there. He doesn't have to know or care that there are 2 or 3 or 10 different systems in a cluster. We offer up to the client the cluster IP address. And in this case, in the diagram, the cluster IP address that all the clients would use to access this cluster array is 172.16.10.100. Now, when any client accesses this cluster array targeting that 172.16.10.100, he thinks he's getting access to a single device. However, the array, those 3 systems running the hypervisor instance 1, 2, and 3, will compare notes, identify who should accept this new inbound connection because of load distribution and other rules. Then that particular one box will host and support that client's connection and session. Meanwhile, across the heartbeat, that's that upper network, that one system is now also sharing the state of those connections, those inbound sessions, with the other 2 machines. So that at any point in time, if any machine dies, all other machines can recognize what client connections have to be handled, and they do load balancing across the remaining members of the cluster array and share that workspace. So that's the way the clustered servers that run the hypervisor, those are the host hardware systems, actual physical boxes that are actually going to run the clustered application as the hypervisor. And that's the platform that we can now spin up many, many, many virtual machines on this cluster array. So as we see, the clustered servers provide a high degree of hardware fault tolerance. That would be both in the servers themselves, the CPU, the RAM, the network interface cards, all of those components, as well as that shared storage is also high performance fault tolerant. Then we run the hypervisor instance across that clustered array. Now, all 3 systems recognize that they are participating in this virtual host environment, and that allows us to easily duplicate virtual machines at our will. With just a few moments to copy a new host image, duplicate it, and then boot it up on this virtual environment. So the virtualization hypervisor is the clustered application, and it supports our spinning up many, many virtual machines, the guest systems on this clustered array. As any one system gets more heavily overloaded with processing and RAM demands, another aspect of this heartbeat is not only do I keep information about the connections I'm supporting and the state of their application session, I also share with the other servers in the cluster my performance data. If my CPU is hitting 85% utilization, and I see one of the other members of the cluster is only at 35% utilization, I'm going to spin off one or more of my virtual guest systems onto that other machine and let him take some of my load. My load will drop and his load will increase, and overall we will balance. This is the optimum performance for running many, many high-demand applications and systems all at the same time. So this is this live migration of virtual machines. The client never even realizes that his virtual machine was migrated off of server instance 1, for example, over onto server 2. It's completely invisible to him, and the changeover is very quick. Now, interestingly, the administrator for these 3 systems may also not even be aware where any particular instance of a virtual machine is running. To him, he doesn't exactly care as long as the systems remain running. We don't have to keep track of what particular piece of hardware is currently hosting what session or what virtual machine for clients. The hypervisor will automatically maintain that stateful information across the heartbeat and will then share and load balance that distribution of client load so that we can optimize the performance of this cluster array, and that performance then is translated or represented out to the client in their use of these systems. As we continue our series on cloud services, we're looking at building our own internal cloud. Now, in the preceding video, we looked at the hardware aspects of how would you build your cloud services infrastructure. This look is a little more detailed, looking at the virtualization aspect that runs on that hardware cluster array that we saw in the preceding video. What we're looking at down at the very bottom is the bare metal hardware and firmware. Now, this would be our servers, our actual physical hardware. There might be 2 or 10 or perhaps even more hardware systems that are clustered together and operating as if they were one shared pool of resources. And those resources, once again, are computing resources, the actual CPU, the RAM, the networking infrastructure and connectivity for the systems, and then, of course, the applications that are running across this cluster of these hardware servers. So it's CPU, RAM, storage, and applications, and then the networking infrastructure that is used to connect these pieces of hardware together. Each of these discrete servers that are operating in this cluster array will have their own independent operating system. Now, that's a piece of software that lives on top of the bare metal hardware. But then we would install on that the host operating system. Now, in some cases, one of the products that we're going to look into for virtualization is called VMware. They have their own specialized implementation of their host operating system called ESXi Server. So VMware runs their own Linux distribution of the operating system. But once we get that operating system installed, the ESXi Server also installs what they call their hypervisor. This is the actual application that runs on the host operating system that supports the multiple virtual machines operating systems that run on this one hardware system. That's the VMware version of virtualization and virtual servers. In the Windows world, we would simply purchase and install a Windows Server operating system. Now, on top of that operating system, once again, is the hypervisor application that virtualizes the hardware for the guest operating systems that are actually going to run on this piece of hardware. When you look at that purple bar down at the bottom, that could represent 10 different computers running 10 discrete implementations or instances of the same operating system. So one operating system per piece of hardware. And then, of course, we cluster them so that they all appear to operate as a single physical mass of computing power. And then we run that hypervisor application on top of that platform of clustered systems. On top of that, we then would deploy the virtual machines. On this virtual server, these guest operating systems could be of any nature that you choose. If you are paying for software as a service, the cloud service provider will probably be responsible for those guest operating systems. If you're running platform as a service, you may specify to that cloud service provider that you need this distribution of Linux or that version of Windows so that the applications you deploy in your platform as a service can operate properly on the proper platforms. So in that case, you would specify what OS you're looking for, and they would then provide those platforms for you to deploy your applications into. And finally, if you're only acquiring infrastructure as a service, then the cloud services provider would provide the bare metal hardware, the host operating system, and the hypervisor, and you would be responsible for the guest operating system and the applications. Continuing on with cloud services and security, we're looking at how to build your own private or internal cloud. Here we're taking a look at the analysis of the different vendors that can provide you the appropriate software for the cloud services support. For the most part, we're dealing with virtualization. We need virtual hosts, in which case we would buy whatever hardware we care to choose, whatever brand it might be, whether it's Dell or IBM or one of the others, and we'd build them in a cluster array as we described in earlier lessons. Next, we'd have to choose which hypervisor would we want to base our virtual machines on that are actually the internal cloud that we're looking to build. The virtual machines will be sitting on this hypervisor. The leader in the industry has been VMware. The second company that is coming up strong in this industry as well is Microsoft with their Hyper-V hypervisor. So these are your two primary platforms for virtualization. As you see down in the lower left-hand corner from this Gartner's report on virtualization, there are several other players. However, for the most part, they lag in vision and the ability to execute on the development and continuing support and growth of this hypervisor platform. So once again, if you're building your own internal cloud, you'll be probably looking at the use of VMware as your hypervisor or Microsoft's Hyper-V for your hypervisor. If you're looking to use the community cloud or the public cloud, where you're actually going to be leasing services from some other cloud service provider, some external source, then we have, once again, primarily two leaders in the industry. The first one and the most advanced would be the Amazon Web Services, again, according to Gartner's 2014 report. So Amazon Web Services is a cloud service provider with the most advanced capabilities and the advanced vision on what the future of cloud services is to bring to the marketplace. And then, of course, the second player, as we see from this diagram from Gartner, is Microsoft once again, with Azure, the name of their cloud services provider. These are your two primary cloud services providers for the public or the community cloud services. Now, again, the commercial example will be Amazon Web Services, the clear leader. Now, Amazon will provide you free 12 months of cloud services, of course, with limitations. The goal here is if you move into this free 12-month period, number one, you'll probably begin to outgrow the offering for the free services and you'll pay for extra services. And then the second angle on this is if you don't outgrow what they provide you free for the first 12 months, after that 12-month period, you'll have gotten established and used to this availability of cloud services. You'll start to have grown into this environment, and the next thing you know, they've got you hooked for life. And you'll be paying Amazon or one of their competitors for quite a long time. They also have free training videos and, of course, a lot of documentation. So why don't you say we shell out to the browser and we'll take a quick look at the Amazon Web Services website. So here we see amazonwebservices.amazon.com. We can create a free account. This will get us established for that 12-month period. All sorts of free benefits here. They call this their free tier. So if you're interested, you can click on this. But let's take a look at what else they're talking about. They have database services from Amazon Database Services. They have code development and deployment. This would be for your platform as a service. Then they also, for security purposes, have key management services. Now, this is something we'll be talking about later as we get looking at living in the cloud. You'll, of course, want to be encrypting a lot of content that goes up into the cloud. And one of the issues that we have to maintain is the protection of all of the keys that are used for the encryption of this information. We have to be sure that we can recover our own data. They're providing us this assistance with this very critical component of cloud use. We have different divisions or departments as Amazon sees them, and also ancillary services, as we see over here, identity management and access control and key storage. These are some of those ancillary services that we see coming up to support the software as a service, the platform as a service, and the infrastructure as a service. Down here, they have tools to help us with the implementation and management of our cloud services, communications with our mobile devices. This is commonly referred to as the Bring Your Own Device, BYOD, division of your computer and network management infrastructure today. Let's scroll back up to the top here and let's do a quick look at the free tier. Some details on it. We can sign up after creating. You can use any of the 18 products that we see here for the cloud services, the free tier. We can look at the various featured products here, different support levels, the storage capabilities, the support services, things along these lines, key management services as we described earlier. So a rich and full collection of tools that you might be able to access with your free Amazon Web Services. Let's switch over now to the other product, the Microsoft Azure. As you can see, they provide a great deal of connectivity with especially Microsoft services like their SQL databases and Active Directory. Here, with the Azure services, they provide the integration of your own Active Directory. This is another of the core components of securing your cloud services. You want a separate Active Directory for your communications and connectivity with your cloud services. Microsoft provides us these additional capabilities and services, again, using their hypervisor, their SQL database, their web server, their Active Directory, etc., etc. Here's some of the extra features as they tout them. If you're a MSDN subscriber, this is Microsoft's Developer Network. You can start up with this BizSpark program. This would be for small businesses trying to get them a little more connected and a little more presentable for the internet use. And then finally, if you're a student or a school and you want to teach web services as either a client or the instructor side of it, they provide extra capabilities and free services, if not free, heavily discounted. So once again, as we scroll up to the top here, we can look at their ability to run your free 1-month trial. So this would be how you would start your process of developing your free trial on your commercial web services for Microsoft Azure. Again, the second major leader in this commercial cloud web services provider. This chapter is looking at securing the infrastructure. One of the first things we have to recognize about our plan to move our valuable information assets and other intellectual property into a cloud structure is that if we intend for that information to remain secure in the cloud, we must first have a secure internal infrastructure. If we can't protect our valuable information assets on our own private network, how can we extend that notion of security to keeping our information assets secure in the cloud? So the first thing we have to do is be sure that our own internal infrastructure is properly secured and well managed. We're going to look at these topics relative to securing our internal infrastructure. These collectively help us establish this foundation of security internally. And if we have this internal structure that's secure, then we might be able to securely move information assets into a cloud and keep them secure. But if we aren't secure with our own internal infrastructure, then the breaches will be occurring from our internal LAN, and it doesn't matter what we do with our information assets in the cloud. If we can't keep our LAN secure, then the information will be leaked from the LAN, and our security on the cloud is not even a requirement. So first, let's get ourselves squared away so that our internal infrastructure is nice and secure. Now, in the first bullet here, framework for governance, we're going to look at how we develop this documented collection of policies and procedures and baselines and standards and guidelines that will establish the rules, if you will, on how we're going to operate prudently as a business. This would include policies and procedures that describe how we will protect our valuable information assets, the different programs that will help us implement and maintain security over time. This is in essence our agreement between the enterprise and the employees on how we're going to behave as a company. We're going to look at that first. Then one of our critical programs to establish a prudently managed business and a business that we might be able to maintain securely, we're going to have to perform risk management. Now this starts with a risk assessment, that is the development of knowledge and awareness of all the bad things that can happen to our business and our enterprise that might impose or introduce losses. Then we're going to try to avoid those bad things. We're going to look at how can we manage those and step away from that if we can possibly avoid those losses, prevent them from occurring if we can. Our next phase of risk management will be if we can't avoid the risk, let's try to mitigate or reduce the impact when that bad thing does happen. And this is done by having properly trained people and resources and things along these lines. But we'll look at risk assessment and risk management to try and avoid and minimize those losses when bad things do happen. Next, we're going to look at the overall security program. Now, this is how we would implement those policies and procedures in actual form. What are the steps we have to take, the activities, if you will, that we're going to perform in the enterprise to help us protect ourselves from those bad things that could happen to us? We're going to look at data protection. We're going to look at confidentiality, integrity, and availability of our valuable information assets. What does that mean? And what types of tools might we use to protect those three core components, confidentiality, integrity, and availability? We often call this the CIA triad. So if I refer to C and I and A, that's what I'm talking about. We're going to look at how to protect our systems and our data. So that would be the implementation of these components. And primarily here we're looking at system fault tolerance, system stability, system hardening, and the way we use these systems that hold our data to protect our data. So we're going to be looking at fault tolerance and redundancy, things along those lines. We're going to look at security awareness training. First, we establish this framework of governance, then we recognize what bad things could happen to us, and then we start to think about what preventive controls and mitigating controls we might implement. We're going to implement this overall security program. If we don't teach our people what our rules are, what our policies are, what our procedures are, and what our technologies are that will help us protect these valuable information assets, then we've wasted our time. This step 6 tells us how do we actually teach our people about all the components that we're going to implement to establish this framework for governance and the foundation of security for our valuable information assets. This security awareness training would also include safety training. Now, with user provisioning, we're talking about the creation of user accounts and the removal of user accounts, but more so the provisioning of privilege for those users. And we're going to implement these privileges following the principle of least privilege based on need to know. In other words, if a user doesn't need access to information because it's not what they do, we're not going to give them access to that information. And if they do need access to information, we're going to give that access at the bare minimum level of privilege they require to do their work and not more. We don't want to give them any more privilege than is required for them to do their jobs. If we grant more privilege than that bare minimum, we are giving them too much authority, too much privilege, and we're exposing ourselves to more risk. So we want to minimize that risk by reducing this following that principle of least privilege. Now that we have the framework of governances in place, we understand the risks, we have trained our users, we have provisioned our users in a secure manner, they should at this point know what things they are allowed to do and what things they are not allowed to do. Bullet number 8 addresses our management's monitoring of those users and then enforcement of our policies and our rules and our controls. Sometimes our users will inadvertently make a mistake and will do something they're not supposed to. If we aren't monitoring, we won't recognize when those things happen. And if we do recognize when they've made a mistake, then we go to that user and we teach them, okay, you made a mistake here, you got to stop doing that, this is the way we do it. However, what if they have malicious intent? What if our users might be trying to take advantage of the enterprise and might be willfully trying to manipulate information to gain more access, to perform in an unauthorized manner? So this is an authorized user with privilege who is misusing their privilege levels. And then in the third scenario, we're talking about outsiders that might be trying to break in and take advantage and steal or manipulate our information assets. So once again, if we aren't paying attention by carefully monitoring these valuable information assets, recognizing when something bad is happening, and then taking remedial action to enforce our policies and our controls, we aren't prudently managing our enterprise. In some legal senses, we are actually negligent and we open ourselves up to additional litigation. So we want to carefully monitor all of the activities on our enterprise that's in the physical world and also on our network information assets. And then we also have to enforce and remediate anytime we find any sort of violation, incident, or breach. When we do identify some sort of mistake, some sort of violation, some sort of incident, or some sort of breach, how will we respond? Step 9 is a plan, a team, a collection of resources that are geared towards when these bad things do happen, how can we quickly and intelligently respond so that we can minimize the losses? Our first goal would be to prevent these losses. But if that fails, and it does from time to time, if we can't prevent, then of course the next thing is we want to respond as quickly and as efficiently as possible so that we can minimize those losses. Picking up where we left off at securing the infrastructure, we're going to start by taking a look at how to establish the framework for governance. Now, this framework is a set of documents that are formalized. They're written by our senior management. They define what they want these documents to say. These are a collection of documents called policies and procedures, standards, baselines, and guidelines that pretty much outline how we will operate the enterprise. These are the boundaries and the controls. They set the corporate culture, if you will. This is how we will establish our prudent management of the enterprise. The considerations that go into these collections of documents start with management's recognition of the inherent risks for the particular business and its location, and then the industry that the business is in. For example, an enterprise that is developing military weapons has a much different risk profile than a business that makes donuts, for example. So as you can recognize, the industry will greatly have influence on the nature of the risks that the enterprise will be faced with. In addition to that, the individual business in that industry will have its own collection of inherent risks. It might have to do with physical location. If perhaps you're on a fault line, you might have an increased risk of earthquake. If you're in the southeastern United States or Hawaii, you might have the threat of hurricane. Central United States, you might have the risk of tornado. There are 4 categories of risks that need to be addressed, and that would be the natural threats, man-made threats, things like sabotage and theft and vandalism, riots, and even political actions are man-made. Then we have technical threats, such as problems with our hardware, hard drive failure or power supply failure, things along those lines. And then the fourth is supply system threats. Electricity, heating, ventilation, and air conditioning, water, sewer, these types of things. Business would look at these types of threats that are specific to their location and implementation. And then, of course, the industry that they're in will also have impact on the threats that influence the risks. So management will consider these things and then will build policies that help us prevent those bad things from happening. We will try to reduce the impact or mitigate the impact of these bad things when they do happen. The second item is management has a responsibility to manage the enterprise and to maximize profit. We have to behave in a normal, reasonable manner to avoid litigation, to avoid injuries, to avoid litigation through lawsuit. We don't want to steal somebody else's technology. We don't want to violate any laws, things along these lines. So that would be prudent and fiduciary management responsibilities. These are other drivers that will be conveyed through these documents. The individuals that make up senior management will have their mentality for their style of governance, and they will also have a certain level of ethical standards and their vision on ethics. These should also be apparent in these policies and procedures, guidelines, baselines, and standards, because these are the controls that management wants to impose for how we're going to manage the business moving forward. Some businesses are impacted by laws and regulations. If you handle medical information in any way, shape, or form, you are subject to HIPAA laws. If you deal with credit cards for payment, you are now subject to payment card industry data security standards. If you're a publicly held company, you have to abide by Sarbanes-Oxley. If you're a financial institution, you have Gramm-Leach-Bliley Act that will affect the way you must operate. So many businesses are influenced by laws and regulations. So these laws and regulations must be conveyed within these standards. These laws and regulations are pretty much an atomic function, which means that you are either in compliance with the law or you have broken the law. You either have complied or you have not complied, and there's not a whole lot of room for negotiation. Now, these policy documents should be based on accepted frameworks. Very often there are international standards. There are national recommendations. There are vendors' lists of recommended procedures and best practices. When you are preparing these documents, you'll base these documents on these very well accepted national and international and vendor recommended procedures and best practices. We want to include all the things they say we need to include, and we want to base our specifics on what they say should be the specifics for baselines and standards, things along those lines. Senior management is going to want to operate the business as efficiently as possible. Now, this kind of falls into this fiduciary responsibility we talked about earlier. Operational efficiency is a little more of a specific objective because one of our goals is to maximize profits by avoiding losses. We want to be as efficient as we possibly can with our practices and our procedures, so these would have a heavy influence on the documents that make up this framework for governance. This framework for governance will be developed and written by usually subordinates of senior management based on the drivers that senior management identifies. And then, as I said before, management will formally sign off on these as the accepted and current policies and procedures. Now, that makes them, in essence, this agreement between senior management and the employees. So if we're going to have these rules that we're going to lay down on the employees, and we're going to enforce these rules and maybe even punish the employees for violation of these rules, and I say punish, at a strict sense it might even be grounds for termination. But if we are going to try to enforce these rules, what it means is we have to educate the workers as to what these rules are. So this is that security awareness training. This must be completed for all employees, and it must be completed at least once a year as a reminder, as a refresher for all employees. Each employee, as they get this training, should sign off that we've received this training, we understand what the rules and requirements are, and we agree to abide by all these rules and requirements. We should have a signature on file for every employee, and ideally, we want a fresh signature every year for every employee to validate the fact that we are prudently performing this security awareness training on an annual basis. This very often will define a legal standing between the enterprise and the workers. If there is any sort of violation that causes some sort of remediation, like we had to fire that employee because this was so severe an infraction, or this was actually a violation of some law that we are subject to, this becomes more of a legal document and might be actually used in court to justify and validate management's position in its remediation of this particular worker's activities. Through that training, we use the documents to define expectations of performance and behavior of the workers. This establishes the expectation for the ongoing operations of the enterprise so that we can help assure the operations will continue and will continue efficiently and prudently so that we're managing our business as we should. Continuing on with our lessons on securing the infrastructure, we're looking at the policy examples for the framework of governance. This list is a collection of different types of policies that might be implemented. First, we have the overall information security policy for the enterprise. This collection of documents would really be the body of work that establish the agreement that we have for the operational efficiency of the enterprise. Many of these following documents are subsets of this overarching information security policy. A summary of the rules that apply to the specific users will aggregate out of that enterprise information security policy and aggregate them into an acceptable use policy. So these would be the bulk of the specific policies that affect the employees. We have this summary, if you will, of expectations for the employees. These are the core things such as acceptable use of the computer, acceptable use of the email system, acceptable use of the browser and the internet, acceptable use of other resources in the enterprise. These are the primary rules that affect all the employees, the workers, if you will. We typically will present this document in the annual security awareness training, and we'll have the employees sign off that they have read and understand all these policies and that they agree to abide by all these policies. That's the real meat of what you're going to teach your employees when you perform this security awareness training. Now, again, that's a subset of the enterprise information security policy because the overarching information security policy will also include many details that will address the architecture of the information systems, the organizational chart, responsibilities that senior management has, etc., etc. So there are many things that don't affect the individual user, and those things would be left out of this acceptable use policy. These are the ones that target the individual employees. Another subset of the enterprise information security policy is the hiring and termination policy and procedure. Now, this would be the collection of documents that target the human resources and will define how we will perform our pre-employment background checks, our interview process, our approval process for onboarding a new employee, the process for provisioning user accounts and other privileges, not just on the network, but privileges relative to relationships with vendors and with customers. So that would be the hiring portion of this. Now, the termination part of this will define two different situations: the willful termination and the unexpected termination, where an enterprise might actually have to fire someone on the spot. In both cases, we'll want to perform what we call an exit interview, and we're going to try and get all of our assets back from the employee. We're going to review with them why they're being terminated to try and head off potential litigation. We're going to review with them any persistent agreements, things along these lines. We'll be looking at that in more detail later on. That's the hiring and termination policy and procedure, targeting human resources in the way we bring people on the company and the way we terminate them at time of departure. Next is the data classification policy and procedure. Now, this is kind of a subset of our risk assessment and risk management, but this specifically targets our information assets. This is actually a relatively new facet of the enterprise information systems. So that's why it is highlighted or brought out as a specific topic, because for many organizations, they aren't doing this yet, and they need to be doing this. So this is the way to prioritize which information assets are most valuable, get them properly categorized and labeled with the appropriate protective measures in place. And then, of course, we have to support that with proper technologies and training for all the users to recognize the sensitivity of these valuable information assets and then understand the rules that we have imposed to protect those valuable information assets at an appropriate level of security. Now, the next bullet down is risk management. This includes risk assessment and risk management, and this is the overall vision on all the bad things we can figure out that could do us harm, and we want to prevent those bad things if possible. And then with the recognition that we can't be perfect, Mother Nature still will drop a hurricane on us or an earthquake or something along these lines that we can't prevent. In some cases, these bad things will happen. And then our secondary goal is let's recognize the event as quickly as possible, get appropriate level of response, and minimize our losses, minimize the impact when the bad thing does happen. So that's risk management. And that's a formally documented assignment. We'll perform it on an annual basis, and we will develop a team and procedures on how we keep this risk management and risk assessment activity alive and viable. Next one down is incident response. Incident response is when the bad thing does happen, these are the people that are going to take these specific actions to help us minimize those losses. With incident response, we make the assumption the bad thing has happened, and we have plans in place and resources and trained people so that we can reduce those losses when the bad thing does happen. Now, the long-term vision of keeping the enterprise operational is the business continuity plan. These are the processes and activities and the vision that we have relative to ensuring that the company never goes out of business. That's business continuity. For the foreseeable future, as many generations in the future as we can identify, as we can plan on, as we can foresee, we can assure that the business will not fail. That's business continuity. And then the immediate response to some disaster being the type of incident that could put us out of business. That's the difference between disaster and incident. We will have a disaster recovery plan to avoid going out of business when some unforeseen or unavoidable disaster does occur. These are a core component of the prudent management of an enterprise. The last bullet here, we see the sanctions policy. Now, this is very often required if you are subject to any laws and regulations. Sanctions policy will say that if an employee or a user violates any of the policies or breaks any laws, these are the things that we will do to remediate that problem. Typically some sort of penalty or punishment that goes along with the violation. It could be 3 strikes and you're out. It could be you now have to go resit the security awareness training. It could be the potential for civil litigation, and it could also be the potential for criminal litigation if the action of the employee broke a law. So we have to have this formally documented in our collection of policies, what we are obligated to do as a business if and when one of our employees violates one of our policies or violates one of the laws that our company is subject to. So once again, these collection of policies establish this framework for governance. Now, there are another collection of documents that go along with this framework of governance, and these would be specific contractual type agreements between the company and the employee. A confidentiality agreement will persist and remain in force even after the employee is terminated from the company. They still might not be allowed to talk about any of the internal secrets or activities or procedures for a period of 2 years or 5 years or 10 years, depending on what lawyers have decided or what might be applicable for the state or the laws that the company is subject to. Another type of agreement deals with the ownership of any inventions or materials created while the worker was employed by the business. That the employee does not have any ownership of these assets because they were working for the enterprise, they were being paid by the enterprise, they developed this invention or document or procedure using the resources of the enterprise, and that they have no ownership, that the enterprise retains full ownership of whatever assets the individual may have created or developed during their time of employment. So these are a couple of examples of the types of contractual agreements that would be supplemental to the policies to establish this framework for governance. Moving forward with our lessons on securing the infrastructure, we're going to look at risk management. Risk management is a fairly large project that many enterprises still have yet to accomplish. However, in almost all cases, if an enterprise is subject to laws or regulations, this process is a requirement. This process is also a requirement if the enterprise is serious about prudently managing the enterprise. If an enterprise hasn't performed risk management, they aren't really prudently managing the business. So this is one of those things that every business should perform. The problem is it's kind of a lengthy process. It is estimated this whole process will take approximately 3 years to complete to where it's actually viable and they actually are proactively managing risk. Typically, it's about a year or two with the first implementation and then another year or two until you actually get it managed to where you're really riding on your own plan and proactively addressing the risks that are inherent in the enterprise. Risk management has 2 core components. The first half of risk management is the risk assessment. Now, the risk assessment is the development of awareness and knowledge of all the bad things that could happen to the enterprise. To some extent, this is predicting the future, so it's a difficult challenge for an enterprise. There are 4 primary threats: Mother Nature, hurricanes, tornadoes, earthquakes, snowstorms, ice storms, things along these lines that could introduce losses for the enterprise, whether it's a destruction of the facility, whether it impedes productivity, like an ice storm, the employees can't get to the business. The secondary threat would be man-made. This would be an employee sabotaging or stealing assets, some outsider breaking in and stealing things. The third threat is a technical threat, and technical threats are where we have failures to our technology. And this would be a server that fails, or a hard drive that crashes, or a connection to the internet that fails. If our technology fails, then our access to our information assets fail, and we violate that availability issue of confidentiality, integrity, and availability. And finally, supply system would be your 4th family of threats. If you don't get good, clean electricity to your data center may fail. So you need a constant supply and it has to be clean. Another supply system threat would be heating, ventilation, and air conditioning, water and sewer. If you use natural gas to heat your facility or run your production line systems, things along these lines. The 4th type of threat is supply system. During this risk assessment, we look at all of these threats and we figure out which of these could negatively impact the enterprise and how severely. So we have to quantify this risk relative to these threats. Now, the good news is, to some extent, we're going to have to predict the future. So we're going to rely on statistics and actuaries from our insurance companies and things along these lines, research and figure out how often does a tornado strike here. And when it strikes, how severe is it on average? Based on these statistics, we might develop a projection of the bad things that might happen to us. And if they do happen to us, how impactful are they? We first start to look at preventive controls, and we simply brainstorm this list of what type of control would it be, and then we run some sort of cost justification for that particular control. For each and every threat that we can identify to our enterprise, we need to identify preventive controls and also recovery controls. If the bad thing does happen because we couldn't stop it, how would we respond and minimize those losses in the face of this incident or disaster? This is the second portion of this risk assessment, identifying the preventive and recovery type of controls to mitigate those losses and getting it documented. This is considered the performance of due diligence. Due diligence is a legal term that says we were prudently managing our enterprise by understanding all the bad things that could happen. The second half of risk management is the actual portion of taking action. This would be the implementation of specific types of controls to help prevent the disaster or incident from happening. And if the disaster or incident does happen, how do we mitigate it? How do we reduce its impact to avoid and minimize those losses? And this action, the implementation of these controls, is what we would call due care. Do care is the follow-up to due diligence. Once we understand the bad things that could happen to us, do care is what actions will we take, did we take, are we taking to avoid those losses and reduce those losses when the bad thing does happen. Collectively, these form the superset called risk management. Now, this is a project that should be a component of every company's business operating procedures. It should be part of their corporate culture. It should be very well documented in their policies and procedures, written and then approved by senior management. Welcome back to our lesson on securing the infrastructure. We are continuing with our lessons on risk management and risk assessment. In this lesson, we're going to look at risk assessment. What exactly are we accomplishing here? And procedurally, how would we perform this risk assessment? We first have to recognize that the risk assessment is nothing more than talk and paper. It is simply developing knowledge and awareness of the bad things that can happen, the documentation of these things. Then we perform this threat analysis to identify where are we vulnerable to these threats. And we follow up then with a brainstormed list of what could we do to possibly prevent these things and what can we do to respond to and recover quickly if these bad things happen. So our first step in the risk assessment is to take an inventory of all of our valuable information assets. The question is, what do we have that we need to protect? So the first thing is put together this list of everything we can imagine that we own that could be valuable. When we talk about what is an information asset, let's say a Word document that contains Bobo's secret brownie recipe. And so this is a Word document that lives on a hard drive. That file is a valuable information asset. And the hard drive that file lives on is also a valuable information asset. That hard drive without a computer around it doesn't help us much, so the computer that spins up that hard drive is a valuable information asset. And the rack that server lives in is a valuable information asset. The data center that holds the rack, the building that holds the data center. So all of these things should go on our list of assets. Second item on the list then is to identify a value for each of those assets. Now that I have my list completed, I'm going to go down the list and I'm going to figure out how valuable is this particular asset to me. If it is something that will impact my $1 million a day production line from running, some server that drives my production line, maybe we say $3,000 is its quantifiable cost. But when we consider that this machine drives my $1 million a day production line, and if this machine fails, my production fails, then this machine becomes a $1 million a day asset. Again, we begin to recognize how significant each of these assets really is to the enterprise. And we assign this value. Now that value has to be a dollar value. It has to be quantifiable. So we assign this value, and now that we have a dollar value assigned for each asset, we now can identify the priorities. So now I sort this list of assets based on its value. And the items with the highest value will be my top priorities when it comes to protecting them, as well as the recovery of that asset if the bad thing does happen to it. So preventive controls and then response and recovery controls are the two phases that we're going to look at later on. But first, we have to get them prioritized. We're going to look at what vulnerabilities are inherent in that asset. Then we're going to look at the bad things that could affect that asset. So inherent vulnerabilities, that's something that we kind of own, and we have direct control over the vulnerabilities because that's inherent in the asset that we own. So if the vulnerability is it's software and it has software flaws, what we might do to reduce those vulnerabilities is update the software with the most current patches. Now, threats typically are external things, not something we own that could hurt us. The threat might be a virus infects my email system and takes down my email and I can't communicate, or it starts corrupting files on my hard drives. So the threat is typically something that we kind of see as outside our assets. It's not something that we own, and it could impact us in a bad way. So when threat meets vulnerability, this is when risk is created. If I have a vulnerability but there's no threat to that vulnerability, then there's no risk. If there's a threat but I'm not vulnerable to that threat, then there's no risk. But when I have a vulnerability and there is a related threat, risk has been created. Now, with risk being present, the next phase is we have to quantify that risk. And to quantify the risk, we look at the likelihood that this bad thing could happen, this threat will impact us, and if this threat does happen and impact us, how big is the impact? How much is this going to hurt? Will it cost us $10 or will it cost us $10 million or will it cost us $10 billion? So we have to quantify this risk. And this again helps us identify the severity of these bad things that could happen. And now we can start to look at preventive controls to avoid that risk and hopefully not ever let this bad thing happen. But if we can't avoid the risk 100%, we have to look at if the bad thing does happen, how quickly can we respond? What should our response be? We might have to have hardware and software and people and skills in place to respond and help to mitigate those losses. And if the bad thing does happen, we eventually have the objective to roll back to a state of normal operations. That would be recovery. How will we move from we're damaged by the impact of this bad thing? How do we get our operations back to a state of normal? So I have three types of controls. Preventive controls, trying to avoid the loss. Response controls, if the bad thing happens, what do I do to minimize those losses? And recovery controls, if the bad thing happens, how do I stop those losses and get back to a state of normal? That's recovery. That's our next phase of the development of knowledge and awareness of the bad things that can happen and our planning to try and avoid these things and recover from these as quickly as possible. And then finally, when we get this risk assessment done, we're going to present this risk assessment to management, communicate the information that we have pulled together to management, and hopefully management will start to approve some of these proposed controls. Let us more prudently manage these risks. Picking up where we left off on securing the infrastructure, we had just completed the risk assessment, and now we're going to present that assessment to management. Management will start to approve some of our proposed controls, and we'll implement those controls to actually manage the risk. So the first phase is the risk assessment, the development of knowledge and awareness of the bad things that could impact the enterprise and cause us losses, along with a collection of the proposed countermeasures or controls that will help us prevent the bad thing from happening. And if we can't prevent it, then a response plan on what will we do immediately after the event occurs to avoid or reduce the losses. And finally, the recovery controls. How will we get back to a state of normal operations? These are all part of the risk assessment. Now we present that to senior management. So in the first phase of the due care phase of the overall risk management project, management approves the specific controls that we will now be tasked to implement. Again, our controls will be administrative controls. These are policies and procedures that will control the behavior of our employees and how they'll handle the situation. We'll also have physical controls, locked doors, security guards, physical access to the enterprise, things along these lines. And then finally, the list of controls will include technical controls, things like access privileges implemented on files and folders, things like encryption for data in store and data in transit. So we have administrative controls, physical controls, and technical controls that are on our list of proposed controls. And once again, management will approve one or more of these types of controls to help us prevent bad things from happening. And if they do happen, these controls will help us respond quickly to minimize losses and then recover back to a state of normal to get to a maximized state of efficiency and profitability. Management will then, based on their tolerance for risk, and of course, these controls have to be paid for. They all have their cost. There's a budgetary concern. These are two of the primary drivers that management will use to identify which controls he wants to approve. along with several other pressures. Perhaps he has an opinion that we aren't due for a hurricane here for the next 10 years, so I'm not going to do anything relative to this threat of hurricane. Based on his vision and his judgment and other types of pressures, he will make his choices. Now, he'll be trying to mitigate the risk, which is reduce the risk. He'll be trying to transfer the risk to some other entity, like an insurance company. Basically, we pay insurance companies, transferring our risk to them. Another way to transfer the risk is simply outsource a particular hazardous or dangerous part of your production. If part of your production deals with the development of poisonous chemicals or gases, if we don't want to face the risks of those toxins in our environment, maybe we simply buy that material from someone else and we don't have to produce it ourselves. So this would be another way that we might transfer the risk, is by outsourcing this. Now, avoiding the risk says if the process is too dangerous, we simply stop doing that thing. Maybe we just decide we're going to drop that product line. We're not going to sell that thing anymore. We're going to avoid that risk. So senior management will choose controls that mitigate the risk, transfer the risk, or avoid the risk. And they'll do that enough until management can accept all the remaining risk. So those are the 4 things that management will do with risk. They'll mitigate it, which means reduce it. They'll transfer it to somebody else. They'll avoid the risk by stop doing that dangerous thing. Everything else that they can't mitigate, transfer, and avoid, they have to accept. So they'll choose controls out of mitigate, transfer, and avoid until the amount of risk is enough that management can accept it. Those controls that they're approving will come out of the category of administrative, physical controls, and technical controls. And the goal of these controls is to prevent the bad thing from happening, to deter it, which means convince the bad guy not to do the bad thing. If we can deter them, then we've prevented the bad thing from happening. But if we can't deter them, they'll continue on with the attack, or the bad thing will happen. Our goal then would be to slow it down, to delay it. Because if we delay something, it gives us a greater opportunity to more quickly detect it. The sooner we can detect it, the better our assessment and response can be. So if I can identify it very early on and identify it properly in the assessment phase, then I can apply a more balanced and appropriate level of response. Response is trying to reduce the losses because the bad thing is happening, reduce those losses, and eventually stop the losses and move to a state of normal operations. That would be recovery. So our goal with these controls is to prevent, deter, delay, detect, assess, respond, and eventually recover back to a state of normal. So now management has approved these. We are integrating these approved controls into our enterprise. They become part of our normal operating procedures, our corporate culture, our standard of operations. It is who we are today. So we have all these controls now paid for, implemented, and the next phase is we have to train our users on what these new controls are. If they don't know about this new encryption tool we have, they're going to still send their data unencrypted. So I need this technology to be implemented by the users. This might mean I need to write new procedures, and I need to run some security awareness training and say, this is our new policy. You're going to be encrypting all this stuff, and here's the tool you use to encrypt it. And if you don't encrypt it, here are the punishments, etc., etc. So the users now need to know what these new controls are and how to use them. Now that we're living on these controls, the next phase is we have to be sure that the controls are being used. We have to monitor these controls and the user's use of these controls. We have to be sure that the controls are properly maintained. I also have to be sure that my rule base is appropriate and it properly addresses all the security concerns that we have, all the requirements for allows and all the appropriate and specific denies. So I have to maintain these controls over time and improve them. Once again, we have to monitor these controls to make sure that they're all being properly utilized, that they're being properly maintained, and that we continuously refine them and make them more and more effective over time. Now that we have this control being properly monitored, I need to maintain metrics on how effective these controls are. We used to have 10 breaches per month. Today, with this new control, we only have 1 breach per month. Next month it's 2. Next month it's 4. Something is not working right with this control. We have to review the control and further refine it. There might be some supplemental control we have to add to this, or maybe we have to make adjustments to this control. So over time, we have to evaluate the control for effectiveness, and this is done by maintaining ongoing metrics on the effectiveness of these controls. As we implement these controls, this becomes part of our normal enterprise security posture. This is due care, and the ongoing maintenance of these controls is due diligence. So due diligence is knowledge and awareness up front. Then we implement due care. That is the actual implementation of controls and the change, the transition into this new state of normal for our security environment for the enterprise. And then due diligence continues on with the diligent maintenance and monitoring for effectiveness and refinement for effectiveness over time. So this becomes our risk management project. As we continue with our lessons in cloud services and security, we're looking at the security program. Now, the security program are the processes and activities intended to secure the enterprise. These are the things we're going to be doing on a daily basis to implement the defined security practices defined in our administrative policies. This will be the implementation of the collection of administrative, physical, and technical controls. We'll have defined specific roles and responsibilities that go along with those roles, and then the resources that are allocated to support the activities defined by those roles and responsibilities. The security program will include the ongoing security awareness training for each and every user at time of onboarding and at least once a year as a refresher. We'll, of course, always be documenting the attendance to this security awareness training. This is our refresher, if you will, for all the users on what they're supposed to be doing and getting their agreement that they understand this and that they will abide by these rules that have been defined during this security awareness training. The security program also includes then the required monitoring and auditing to help us identify and detect these violations of policy and our security program. If we're not monitoring and auditing, then we are negligent in our prudent management of the enterprise. Monitoring is the ongoing review of routine activities. This is a byproduct very often of the logging services that are implemented on each system by default. And then parallel to that, we'll have very specific and well-targeted auditing. Typically, the things we would audit are users that are most highly privileged. In other words, they have access to more sensitive information, or they are authorized to use tools that might expose us to a higher level of risk. Things like laptop computers, cell phones that we've provided to them from the company, things along these lines. Anybody that has a high level of privilege, we should be auditing them more specifically to detect anomalies, violations, breaches, and then as quickly as possible, alert the response team to try to mitigate the losses due to this anomaly or breach. We'll investigate, we'll assess, and then we'll apply an appropriate level of response. So there's this component of enforcement and response, a byproduct of the detection and alerting, which is in turn a byproduct of the monitoring and auditing that goes on. Something that we'll have to do to make sure our countermeasures are appropriate are the continued monitoring of their effectiveness. We'll be logging various metrics on how effective are the countermeasures we have in place. If they're not performing as we had hoped, or if we've perhaps neglected the use of this particular control, and suddenly we find breaches or other anomalies related to this particular area of control, then we'll want to refine that control. We might find we need to add some more rules to the firewall base, some more rules to the intrusion detection and prevention systems. So we'll be continually evaluating how effective are the security controls And the only way we'll know how effective they are over time is by recording metrics on their effectiveness. Perhaps that would be the number of anomalies that we might identify over the course of a month, from month to month. And then finally, a response to those metrics is the review and refinement of our policies and procedures and our other controls. This collectively will be the security program as a whole. The next phase of securing the infrastructure deals with the protection of data. And here we're going to focus on the protection of the confidentiality, integrity, and availability of our valuable information assets. So let's define what these terms are. First, the confidentiality of information means that we will keep our secrets secret. The information that we have is sensitive, proprietary, and if it gets revealed to others, we will lose value. We will lose assets. So we want to keep this information internal and secret. That's confidentiality. Now, integrity deals with the accuracy and completeness of the information. In other words, accuracy says it reflects reality. Completeness says if there are 200 records that match my query, I get to see all 200 records. In other words, some information is not hidden from me. And finally, consistency of information deals with the probability that we'll have multiple copies of the same information at different physical locations for easy access and for redundancy and for availability purposes. If I have multiple copies of the data, they all must say the same thing. If the manager can only access the copy of the database that's in Oshkosh, and it shows that we have 100 widgets in stock, he'll make a decision based on that information. But if there's another copy of this database in Schenectady that was recently updated and it shows that we have 10,000 widgets, then the business decision maker would probably make a different decision on whether or not to purchase more widgets. So the information, the multiple copies of the information, must be consistent. Collectively, accuracy, completeness, and consistency of data means that we have a high level of integrity in our data. And ultimately, the goal is to be able to trust our data, to know that it comes from a safe and secure and trustworthy source, and that information can be believed. That's integrity. Finally, the third security goal is availability. And that says that when someone needs to access the information, and very often the notion is in order to make a business decision, that we have access to that information. The network allows me to connect up to the information, that the application can properly mount the data source, and that the data can be presented in an intelligible manner, that it has been corrupted or knocked offline by some hardware failure, virus corruption, etc., etc. So these are our three primary goals when it comes to the protection of data: confidentiality, integrity, and availability of our valuable information assets. As we continue on with our lessons on securing the infrastructure, we're looking at data protection, and we just reviewed confidentiality, integrity, and availability in the preceding lesson. Now, in this lesson, we're going to figure out what type of controls would we implement in order to provide the protections we just described. In order to provide protection for confidentiality, some of the controls we'll implement will be permissions on our files and folders on our valuable information assets on the network. Most network operating systems will provide the capability of providing permissions at the share on the folder and then specifically on the discrete files within the folders that are shared to the network. So we'll have access permissions that we can implement at those two levels, on the file system and in the network operating system. If we decide that Bobo should have read and write access to a particular collection of files, we would implement permissions to allow that. But if we then decide also that Lulu is not authorized to review any of these files, either read or write, then we would provide a no access for Lulu on these folders and perhaps files discretely. So we would implement these permissions following the principle of least privilege. So at the bare minimum level of privilege, this would be the way we would grant these permissions. This is also a component of the provisioning of user accounts. Now, the next piece here on confidentiality is encryption. If I encrypt a file, then only those that would have the proper decryption key would be able to access the information intelligently. Now, they might be able to see the encrypted file in storage. They'd see the file name, but they wouldn't be able to open up that file and review any of the information that's contained within the file. In addition to this, we might use encryption as we send the file in transit over a network connection. And a bad guy might be monitoring that network connection using a network sniffer or some other tool along these lines. And if we encrypt the entire channel, then the bad guy only sees ciphertext going by. And once again, while he can tell that there is data being transmitted, he doesn't have the ability to intelligently understand what that message is that's being transmitted. So we would use encryption to provide confidentiality services. Another tool we can implement to help implement confidentiality are data loss prevention tools. Now, these are a collection of tools that we would implement on the corporate network that help us to identify our sensitive information, perhaps based on keywords or storage locations, the source or the destination or both. Using these types of network DLP tools and maybe even some endpoint DLP tools, we can restrict the flow of information and not allow some of our confidential information leak outside of our protected network environment. This might even include specific security zones internal on the corporate network, not only at the periphery of our network where we go from our private network to the public internet. We might have DLP solutions at those endpoints there. We may also have different segments of our network that are higher level of privilege, and we might hold more sensitive data on these segments, and I'll use DLP tools to restrict information to just those segments, not let them leak out through the routers and firewalls that we might use to segregate these segments. And then finally, we'll use physical controls as well to protect the confidentiality of information. Basically, this says that if a bad guy can't get into the room where the sensitive information is, then the bad guy can't gain access to the sensitive information. In other words, we protect the confidentiality and help keep the secrets secret. So these are the collection of security tools that we would use to protect confidentiality. Now, integrity is a little more complex. We have two different facets of integrity, and the first one deals with protecting the integrity of the information. Basically, this says that if the bad guy can't get to the books, then the bad guy can't cook the books. In other words, if we can keep him isolated from the information, he doesn't have the opportunity to alter the information. So this is integrity protection. Now, the contrast to that is integrity verification at time of use. So this is another facet of integrity. And basically, this says that at some point we created the information, and the information is known to be good. And at that point in time, I will generate what's called a hash value or a message digest for the information. This becomes the fingerprint for the known good information. Then the information will be either stored or transmitted to some other location. But at some point in time later on, when we are about to use this information to make a business decision or to move forward with some other project, whatever, at time of use, I will rerun the hash function and generate a new hash value, or I'll rerun the message digest. Now, these terms are kind of synonymous, but basically I'll regenerate a new fingerprint for this message, the information that we're about to rely upon. I'll compare the new fingerprint with the old fingerprint. And if any one binary bit in this data has been changed from the time it was known to be good at time of creation and the time of use now, if any single binary bit has been altered, these two fingerprints will be different, and I'll know that the information has been changed or altered, and I will not trust it. So to verify the integrity of information, we'll use hashing functions or message digests. And these are pretty much synonymous terms. And again, I'll take a fingerprint at the time of creation when it's known good, and a fingerprint at the time I'm going to use the information, compare the two. If they're identical, I can trust the information, move forward with confidence. We've verified the integrity. If the fingerprints are different, don't trust this information. It has been altered. Now, rolling back to integrity protection, We'll use the same types of access controls and encryption and physical controls that we use to protect confidentiality. We use those same types of controls to protect the integrity of the information. Once again, if we can keep the bad guy away from the information, then he can't intelligently modify the information. We put permissions on the files and folders so that across the network, the bad guy can't open up the files, possibly alter them to his benefit, and then save them again. If we put access permissions down where he has no access, we have protected the integrity. If we make the files read-only, perhaps a user needs to be able to access the information to make a decision, but they're not authorized to alter the information, then we share the information in a read-only fashion, assigning read-only permissions. So this would be access permissions at the principle of least privilege. If a bad guy sees encrypted data flowing across the network, he might know that this important message is communicating the wire, but he can't understand the message, so he can't intelligently modify the message to his benefit. So encryption is another tool used to protect the integrity of information. The bad guy might inadvertently flip a couple bits, hoping to make the message say that we owe him $10,000 instead of $10. However, if he flips a couple bits randomly in the ciphertext, he's more likely going to corrupt the file than alter it appropriately for his benefit. And finally, once again, if we can keep the books behind locked doors and the bad guy can't get through those locked doors, then the bad guy can't inappropriately modify the integrity of the data. So we have integrity protection techniques and integrity verification techniques. Finally, we have availability, and that's the ability of the users to access the information at the time that they need to access the information. And the way we improve availability to help to ensure that it remains high, in other words, always available, we'll use fault-tolerant techniques and redundancy techniques. Fault-tolerant says a component can fail, yet I still have access to my information. Redundancy says we have at least 2 of the required components, whether it's 2 copies of the data, 2 connections to the internet, 2 servers that are providing access to the information, etc. We have at least 2 and maybe more of these systems or these paths or these technologies or copies of the data, etc. Fault tolerance and redundancy of our connectivity, our systems, that's the computers that support the applications and support the data store, and then finally fault tolerant and redundancy of the data elements themselves. Now, cloud services are designed to be highly available. So they have all this fault tolerance and redundancy built in. If we're building it, it's one of the things we have to build in. So cloud services kind of by definition say highly available with fault tolerance and redundancy built in and all the appropriate types of fault tolerance and redundancy. Stepping away from the larger superset of cloud services, we'll look at the hardware clusters where we aggregate multiple servers in a cluster array. And this is where these servers literally will communicate with one another, recognizing that they are members participating in this cluster. They share information about the connections that they're supporting, the sessions that they're supporting at every moment. And if any one server fails, the others recognize his absence and will also then load balance the load that that first cluster is supporting. The end user doesn't even know that the server he's been connected to and maintaining a session on has gone away. He simply gets transferred automatically behind the scenes to another member of the cluster array, and that server will pick up his session where it was before. To the end user, this is all invisible. So cluster servers are redundancy of the server hardware and the applications, the services that are being provided by the cluster. The next one, redundant array of independent disks. This is a collection of hard disk drives that are organized in a manner to provide either fault tolerance or redundancy or both. And there are different RAID types. RAID 0 is a stripe set, highest performing of all. RAID 1 is a mirror set. This is most redundant and fault tolerant of all. And then we have a stripe set with parity, a RAID 5, which is fault tolerant and high performance. So we have different RAID arrays for our disk assemblies to help us keep the data that these disk drives are storing available through fault tolerance and or redundancy or both. Parallel to the RAID arrays, we typically will make backup copies of our data sets. Now, backups are usually a batch job, periodically spawned off extra copies of the data. That way, if something happens to our data set, let's say multiple disks fail simultaneously and I lose all my data, or we get a virus infection that starts corrupting or deleting files, our backup copy will be our go-to tool. And this would be a copy of our data from, let's say, 4 hours ago or up to 24 hours ago, and I can restore that backup and have access to 100% of the data that the backup set holds. Now, you will lose some data with the backups because they are a batch file or a batch process. Typically, I'll run the backup on a nightly basis in the worst case, where it's once every 24 hours. But if I have high demands, where I might lose too much data, if I lose 24 hours worth of data, then I'll do backups every 4 hours, for example, or every 1 hour, for example. And that way I'll reduce the amount of data that I lose. If I have a failure, the maximum I might lose 1 hour worth of data, and that's enough that I can survive that, and my technologies will support the workload of generating those backups on that hourly basis. The combination of RAID arrays and backups will help keep my data available through fault tolerance and redundancy. And then finally, the last one is one of the best plans we can implement, but it's also perhaps one of the more expensive. And this is co-location of your data, your applications, and perhaps even your cluster services. Cloud services kind of aggregate all these together. So what co-location is about is I will have perhaps multiple servers. I'll have a set of servers in Oshkosh and a set of servers in Schenectady. Now I'll implement the same applications in Oshkosh and in Schenectady. And then in real time, as I update my data, as I create new data, as I purge old unneeded data, the information that I'm changing, those changes will be transmitted to the other location to keep both copies approximately real-time current. So that if any information fails or if any systems fail in Oshkosh, I simply roll all my services and all my requests over to Schenectady. And I have access to 100% of my services, 100% of my applications, and 100% of my data remains available. So co-location is a top-notch approach to providing this high availability. Now, once again, I want to point out that the goal of cloud services is to provide all of these other features: clusters, RAID arrays, backups, co-location, and even more to ensure the high availability of your valuable information assets. Continuing with our lessons in securing the infrastructure and the protection of data, next we're going to look at the different types or aspects of our environment that need to be secured. First, we're going to look at physical security. We have the need to keep the bad guys out of our environment so they don't steal things, break things, sabotage things, inappropriately alter our data. And in order to keep the bad guys away from these sensitive and valuable assets, we need physical security. Things like locked doors, security guards, guard dogs, and other forms of access controls. Transponder-based card access, things along these lines. We'll generally have locks on our data center to help keep the bad guy away from our most valuable and most sensitive information assets. We also have the need to implement security for our network. For network security, it starts with what we call the AAA services: authentication, authorization, and auditing. Authentication services are designed to validate a claim of identity by some user that we should trust. So we would create user accounts for our network, for example, for the user Bobo. So Bobo will go to his computer, he'll go to log in, he'll type in his username and his password. Now his username is his claim of identity, the first part of authentication. The subject will claim an identity. And then the user will also provide some sort of information to try and validate to us, to convince the authentication service that he actually is who he claims to be. This would be like the password. So Bobo claims to be Bobo, and he offers up Bobo's password The authentication service in the back end validates that claim and says, yes, you are Bobo. I trust from now on that you are Bobo. So for that session, Bobo is issued what we call an access token. His identity is now validated by the authentication service. Now, this service is typically performed by directory services on the corporate network, and in implementation, we're talking about Microsoft's Active Directory. So for network authentication, we're talking about Active Directory authentication, the user logging on. Now, the next A in this AAA is authorization. Now that we know who Bobo is, these are the things Bobo is allowed to do and the things Bobo is not allowed to do. This is Bobo's level of authorization. Authorization is typically implemented on the network through permissions. Typically, there are share permissions and there are file permissions, and this is how we can allow Bobo access to the things he needs access to only at the bare minimum level for him to do the work he needs to do. That's called principle of least privilege. And then finally, we might deny Bobo access to other aspects of the corporate network, things he is not authorized for, and we would give him a no access on those. So this is Bobo's authorization. Now that we know who he is, authorization is the collection of things he is allowed to do. The third A is auditing. Historically, it started as accounting because it actually was about a way to bill the clients. And then we want to know what that guy did, and it became either accountability or auditing. So that was the third A, keeping track of what the guy is doing. Now that he's authenticated and there's a collection of things he's authorized to do, let's keep track of what the guy actually did or tried to do, and that's the auditing part. Now, other aspects of network security deal with preventive controls like the firewall, or detective and preventive controls like the intrusion detection system or intrusion prevention system. So these are other examples of how we might implement network security. Next, we have system security. This is protecting the computers and the infrastructure components. And the biggest part of protecting these infrastructure systems deal with the patching of the firmware and the operating systems, along with patching the applications that these systems are running. So these never-ending software updates, this patching, is something that we should implement on every system. This becomes a whole new facet of the corporate network that historically we would patch systems when we got around to it. When it was kind of slow, we'd do a little bit of patching here and there. However, today, due to laws and regulations that we have to comply with, very often we have to complete the patching within 7 days of the release of the patch, and that patching has to be verified at 100% of the systems within the scope of compliance. Patching has become a whole new facet of our corporate network. Next, we have antivirus software to protect these systems from malware. We have configuration controls. There should be a specified and well-documented configuration for each system on the corporate network, including infrastructure systems and servers and even workstations. We should have policies and procedures in place that say the only time the configuration of any of these systems can change is when it is an approved change going through a formal approval process. And then those changes become updates on the configuration documentation for that device. This is the new setting for that device, and so now it becomes part of the standard for that device. We should be auditing those configurations, verifying that the device is configured the way our documentation says it is supposed to be configured. And it too requires auditing. And then finally on this list here, we see we need a list of approved applications. All too often users are too eager to download some new software because it's got some new slick gadget or they want to update their iPhone or their iPad. Users should not be allowed to install applications. We should have an approved applications list. Applications can only be installed by administration or approved for installation by administration following the approved applications list. If a user feels they need another piece of software in their computer, they should make a request. And only through the formalized approval of that request should they be able to install those applications, which, by the way, is part of the configuration control. Next, we have application security, and this is if you're writing your own software. The developers should be trained to use secure coding. There should be a formal code review specifically looking at not just the functionality of the code, does the code actually work, but has it been written securely? This should go along with a collection of design standards, a methodology, if you will, on how we will write our applications in a secure and functional manner. Application security if you're developing your own software. Next, we have user security. How do we secure the users and the user's activity on the network? First, we have administrative control policies and the acceptable use policy. You may do this, you may not do that on our corporate network. Of course, these policies are just paper and ink until we teach the users this is what you must do. And we get their agreement in training that they understand the policies, they will abide by the policies, and we get it formalized at least on an annual basis that the users understand and agree to behaving this way on our corporate network. Now, from an administrative standpoint, the appropriate provisioning of users' privilege levels is an important component. And once again, this should be a highly formalized, approved process. Anytime a user feels they need access to something else on the network, they make a request to their manager. Their manager should fill out a provisioning request form. That should cycle through a formal approval process, and only when it is formally approved should that change request go to network admins so that they would actually implement that provisioning request for that user to grant that additional privilege or perhaps change some privilege level, things along these lines. This is how we will control a user's activities and actions on the network, is through strict provisioning controls. Now, in addition to that, we can't just trust that they're going to behave themselves. We have to monitor their activities and enforce any controls we have in place, which means we have to remediate anytime there's a violation or a breach. So if the users are misbehaving on the network, they have to be reprimanded for that misuse of the network. Now, one of your most powerful users is the administrator. The administrators have a higher level of privilege. They have the ability to actually change these privilege levels. And so because these are trusted users with a high level of access, these guys can go anywhere and can do anything. They can reconfigure systems. They can provision extra privileges, permissions on files and folders. They can grant access. They could deny access. So these guys kind of are in control of the network. With this level of authority should come additional heightened monitoring and auditing and more strict, more severe penalties if there's any violations or breaches of policy. So this is how we would implement data protection controls on our network and the various facets of the environment that need to be protected. Continuing on with our lessons on securing the infrastructure, specifically data protection, let's get a definition of what it is we're trying to protect. Sensitive data. So what is sensitive data? Well, it starts with our business intellectual property, and that would include anything that we would hold highly valuable that would be important for the business to retain as its own property. So we might need to protect the confidentiality and the integrity of that information, as well as keeping the information available at time of need for some business decision maker to make some important business decision. One of the types of intellectual property is the patent. The patent is a piece of intellectual property that documents the specific idea that is unique, and it has to provide some benefit. So if we have any patents, we need to protect those patents. As we get the patent applied for and granted, that information becomes public knowledge. However, it is still our intellectual property, and so we have to protect it as such. We have to be monitoring the marketplace to see if anyone is using our intellectual property, our patented content, and if they're making any financial gain from this patent, then in essence, that is our financial gain. So the patent protects our financial benefits of this unique idea for some specified period of time. Next would be a trade secret. Trade secret is our certain special know-how on how we do something, some special procedure, some special formula. Many of this information is developed in our research and development department, and so our R&D data very often becomes our trade secret. It gives us competitive advantage in the marketplace. And so these are trade secrets, and the integrity of that information must be protected. Next, we have copyrighted material, and this is the written word, the expression of an idea. In the strict sense, we should register the copyrighted material with the Copyright Office. Then, once again, we have to monitor the marketplace and be sure that no one else is benefiting financially from our copyrighted material, our intellectual property. If they are benefiting financially, that benefit should be ours. And again, this is probably where we would file some sort of litigation against that entity that is getting this money for our intellectual property. Now, the business's financial data is also considered intellectual property. Our financial data would be our bank account information, where we're transferring money, where we're spending money. This might give our competition some ideas as to our strengths and our weaknesses and our intentions in the marketplace. So we want to keep our financial data confidential as well. We might even consider that our payroll information is confidential financial data. We certainly wouldn't want all of our employees knowing what everybody else in the company is making financially. One of the regulations, and this is an industry regulation, not a law, is the Payment Card Industry Data Security Standard, PCI DSS. This is an area where if we use credit cards in our business, where perhaps we sell product to customers and they pay by credit card, their credit card data must be protected in a certain and highly specified manner, and that is the PCI DSS standard. And if we're using credit cards to keep our business going, then we'll need to protect that credit card data from our customers following PCI DSS. So this is an area of compliance where we have to protect this sensitive data, and that would be our customers' personally identifiable information and their credit card information. Another area of business intellectual property is the marketing plans that the business has for the future. How are we going to sell our product? If we decide we're going to use Fluffy the Snowman as our logo, we certainly wouldn't want our competitor to know about it, and then they beat us to the punch and they put out a commercial using Fluffy the Snowman, and the next thing you know, when our commercial comes out, we're simply copying them. So they'll continue to steal our thunder and look like the leader in the industry when really all they're doing is they're stealing our data. We certainly don't want our competition to know what type of market we're pursuing, how we're pursuing that market, specifics of our products to target that particular market, and things along these lines. Marketing plans, again, are considered very valuable when it comes to business intellectual property. Boy, our competition would love to get their hands on our customer database. If they could get every one of our customers, they would send an email to every one of them and say, we know you're buying this product from company ABC. Well, we're company XYZ, and we have a better product, and we sell it for $10 a month cheaper, for example. So they can directly target now our customer database and see if they can steal all of our trusted and valuable customers away from us. Our customer database is one of our sensitive areas and something we have to protect. Our vendor list, our suppliers. What makes our widgets so much tastier than the competition's widget? Well, it's where we buy our widget juice from. This supplier information is valuable information because if our competition can find out where we get our materials that somehow are always better than theirs, they'll start buying from our suppliers. So again, this is very often considered to be business intellectual property. Now, more specifically, let's look at personally identifiable information as the sensitive data. Very often, this PII, personally identifiable information, is defined as required to be protected by laws and regulations. In other words, very often when we have to protect this data, it's because the laws say we have to. So this becomes kind of an important collection of types of data that we have to protect. We have to be sure we protect the confidentiality specifically, and of course we want it to be high integrity. And for our business use, of course, we need it to be available. So once again, the C, the I, and the A of these valuable information assets. So what is PII? Well, it is a combination of several things. First, it starts with we need a name. Who is this person? Otherwise, there's no personal in the personally part of personally identifiable information. So a name associated with any of the following: a name and an address and a telephone number, a name and a birthday, a name and a driver's license number, a name and a social security number, passport number, any sort of professional certificates and licenses. Banking information is an important part. If we have a name and a bank account, we might actually be able to steal all the finances in that particular account. PCI DSS says we must protect credit card information. So there's a law specifically targeting that type of information. All these pieces of information, the PII, could be used to break into that person's financial accounts, to create new accounts under that person's name and steal their money using this type of fraud where we pretend to be them and we've been able to provide enough information about them that we've convinced the bank to give us a credit card under their name. We go spend all we want, and this guy whose name we stole, ultimately he won't have to pay the bill, but he'll be billed for it. And then through a great deal of aggravation and pain, he'll eventually get these charges reversed. But it's an awful lot of aggravation and cost associated with getting out of the identity theft arena. Now, if we get talking about medical information, HIPAA is a law that requires the protection of this medical information. That's Healthcare Information Accountability and Portability Act. This would have to be protected by law. If we have a name and any medical information, medical record numbers, or any health plan information, HIPAA says this must be protected. If this gets exposed, this is a breach and has to be reported. So all of these types of information now collectively form this PII, and it is our job as holders of this information to protect this to the best of our ability. Any exposure of this information, most states have laws that say we have to report this. We have to report to the people who got violated. We also have to provide them assistance with protecting their identities from identity theft. This, together with the business intellectual property, forms the body of sensitive data. As we continue with our lessons in cloud services and security, we're looking at securing the infrastructure and the protection of our data assets. Part of our framework of governance for our enterprise would include the requirement for data classification. So there would be a collection of policies and procedures relative to the mandate to classify all data, provide a level of sensitivity, and then define protective measures for information at that level of sensitivity. This is our data classification policy. Now, in order to accomplish this, we would have to first identify what our classification levels are. So we'll pick 4 or 5 different levels. Typically 3 levels is too few, and more than 5 is too many, and it leads to ambiguity. Now, in the government world, they use terms like top secret, secret, confidential, sensitive but unclassified, and unclassified. If you notice, that's 5 labels. In the commercial world, we can use any labels we want. 1, 2, 3, 4, 5, red, orange, yellow, green, blue, whatever we care to. We can use confidential, sensitive, internal, and public. There is no rigid requirement. You just have to choose something that makes sense to you, that you can live with over time. We have to publish this in our policies. We have to teach our users what these labels mean, and then they have to protect that information following the protective controls implemented for those different levels. So pick some labels that make sense to you that you can live with over time. That's the first step. Then we have to define what is the criteria for this level of sensitivity. Criteria would be typically how much value is lost if this information gets breached. It's C, I, or A. That's the confidentiality, integrity, or availability of the asset. If that is compromised, how much money do we lose? So if your secret brownie recipe sneaks out, will it cost you $100 or $1 million? That would have an impact on the sensitivity level of that particular information asset. So we will align different dollar levels, if you will, to each classification level. And this becomes your criteria for classifying that particular information asset at that particular classification level. Next, identify the protection requirements for information at that level. We might say that we will only ever store this information in an encrypted manner, that this particular information asset cannot be sent to anyone outside the company. No vendors, no customers, no competition. Don't make it public. So we might have all these different rules on the protections required for each classification. Then in our policies, we will dictate all data must be classified and labeled so that the sensitivity level of the information asset is apparent to anybody who accesses that information asset. So we will label it. If it's removable media, it has to be a label written on the material itself, whether it's a backup tape or a CD-ROM or a USB thumb drive. It has to have a label that says this device holds confidential information. That way, anybody who comes across this particular USB thumb drive, for example, knows how they have to protect that asset. Now, in addition, all the documents that have that level of sensitivity must also, in the header of the document or the footer of the document, or perhaps even on a watermark that goes across the back of the document in big red letters, we might have the word confidential. We need to label the data files, and then wherever those data files are stored, that hardware has to be labeled when someone is utilizing this particular device. Maybe it's a laptop or a thumb drive or a printed copy, that they are clearly aware of the sensitivity of the information stored on this media, whatever this media is. And then finally, we have to assign different roles and responsibilities for the ongoing implementation of this data classification policy. Ultimately, the data owner is responsible for implementing the data classification policy in his division, and he will push that responsibility down to managers, who will push it down to the custodians and the users. The custodians will implement the technologies that do the protection, and the users then must also support those protection levels. If a user has read-only access, we shouldn't allow the user to make a copy of the file and then send that copy to himself in an email, for example, or print it out and carry a copy home so that he can give it to his wife or somebody else. So there should be administrative controls and technical controls and even physical controls in place to enforce these protections required for each of these data levels. So the process of data classification would be, first, take an inventory of all of your data assets. These are the data elements themselves, the files and folders and databases that are your data elements. Then we have to assign a value to each of these data elements. This dollar value will directly equate to the classification of that data element, and then we need to label that appropriately. After we get the information properly evaluated and classified and labeled, next we have to implement the protective technologies, the encryption, the VPNs, the permissions, the data loss prevention technologies at the periphery of our network. The administrative controls, the policies and procedures have to be documented. Then we have to teach the users what the rules are and how to use the technologies that help us protect the data elements at the proper level. Finally, unless we're monitoring the use of these data elements and ensuring that they are being handled properly, we're negligent if we're not monitoring. So we have to monitor. And then, of course, anytime we can identify any breaches, violations, or anomalies even, we need to go investigate and enforce these rules and protections. If we're not monitoring and enforcing, once again, we are negligent. We can't let that happen. In this lesson, we're going to look at securing the infrastructure, specifically the AAA services. Those would be authentication, authorization, and either accounting, accountability, or auditing. The first A deals with strong authentication. Now, once again, authentication deals with verifying that a user who is trying to gain access to one or more of your valuable resources is actually who they claim to be. So authentication deals with a claim of identity and then a follow-up from the authentication service to verify that that claim is substantiated, that we now trust that the user is who they claim to be. Typically, this is done through something the user knows, something the user has, or something the user is physically. And that would be something they know would be a PIN or a password or a passphrase. Something they have would be something like an access token or a smart card or a digital certificate. And something they are is an attribute of a biological component, a fingerprint, a retina scan, an iris scan, a voice print, things along these lines. Each one of these left to themselves is relatively easy to compromise. But when I put multiple factors together, such as you have a smart card and you have a personal identification number that you know, That's something you have and something you know. Boom, multi-factor authentication. This greatly strengthens the authentication component. So multi-factor authentication will improve authentication. This would be, again, where I require perhaps a fingerprint and a password in order to get authenticated. Now, another component of strengthening authentication would be mutual authentication. In the examples I've been describing so far, the subject is authenticating himself to the servers. So the user is being authenticated and the servers trust that the user is who he says he is. However, more and more on today's corporate networks, and specifically as we move towards the cloud, how certain are we as users that we're actually attached to the correct server or systems in the cloud? With this in mind, we should be strongly authenticating the servers that we're reaching out to and connecting with. So this is called mutual authentication. When the client authenticates the server and the server also authenticates the client, now we have mutually authenticated each other. The client knows he's connected to the right network and accessing the right information and sharing his secrets and information with the right set of systems. And the server now trusts that the client who claimed to be Bobo, for example, actually is Bobo. And now that we know that he's Bobo, these are the collection of privileges that Bobo has on information resources. So mutual authentication is another way that we can strengthen authentication. Next is called authorization. Now that we know who you are, Bobo, these are the things you are authorized to do. So this authorization should follow a very strict and formalized approval procedure. In other words, a manager for a worker should make a request for authorization, and that request should then cycle through at least the data manager and at least the security officer for the enterprise. And only when all the appropriate signatures are in place should that authorization be submitted to the network admin department for them to actually implement the privileges. Remember, the network administrators are like the custodians for the network, and they do the implementation of provisioning, and authorization is a provisioning process. And those permissions should always be granted following the principle of least privilege. That is the bare minimum level of privilege that is required for the worker to do his assigned work. We also need to be concerned about avoiding granting too much privilege because this allows for conflicts of interest. Suppose we hired a worker and we wanted that worker to be the accounts payable person, the ordering person, and the inventory control person. While we might have that in our minds, that we need this work done and we think this one person can do that workload, that's a fine thing. However, that is too much authority. That allows for too much privilege and could allow for a conflict of interest. In other words, this person might order 20 widgets. Remember, they're ordering and accounts payable. They might write the check to pay for the 20 widgets, but because they're also in charge of inventory control, they might alter the integrity of the information, and they might say that they actually paid that $1,000 for 10 widgets. When the delivery shows up, they might grab 10 of those widgets and throw them in the trunk of their car so they can sell them on eBay over the weekend. With one person doing this, they have way too much authority to do it all by themselves, to steal this money from the company. This type of fraud could continue for years and years, even decades, and it would be difficult for management to catch it. So what we need to do is we need to break this up into multiple roles. In other words, multiple people are assigned these tasks. Don't give one person too much privilege, otherwise they could commit this fraud and not be caught for a long period of time. If we break it up into multiple people, now these people would have to go into what we call collusion, and in this collusion, they would be able to commit the fraud. However, by forcing them into this multiple people are required, we reduce the likelihood of the fraud being committed in the first place. It's not likely a lot of people are going to come together and decide, hey, let's steal some money from the company. We've already diminished the likelihood of this occurring. And secondarily, if they do go into collusion and start to commit this fraud, because there are two of them, it lends itself greatly to them tripping up. They make a mistake, they get greedy, they get into an argument, someone feels guilty and confesses. It increases the chances very highly that we will detect the fraud early on and minimize our losses. So don't allow too much privilege. The last bullet here deals with removing privilege when no longer needed. Suppose we hired Bobo and his job is to help us in the loading dock and in the shipping department. So he has access to the customer database that we ship all of our products out to. Now he doesn't know the details of the orders. He just knows that this box has to go to this address because that's the customer. He's getting the privilege that he needs to do his job. However, when we move him to the production line, he'll need new privileges to operate on the production line. We have to remember that we have to trim off his old unneeded privileges when he changes jobs. Anytime he promotes or he transfers, anytime we grant additional privilege, we should consider what privileges does he no longer need, and we need to trim those privileges off. Otherwise, we get something called authorization creep, where the user aggregates all these privileges, many of them unnecessary, over time. This violates, of course, the principle of least privilege, so we need to be sure we're trimming those off. Now remember, these privileges should be granted balancing security with their appropriate need for access. We don't want to make everyone an admin and give them full control over everything. We grant them only the bare minimum they need to do their work. Now the last A on this list is auditing, tracking what does the user do. We need a log of activity, and that's the audit trail or the accountability of the user's actions. We will keep track of what the user does and what they try to do, and this paints a picture of the user's activities across our network. So these are the AAA services, another component of securing the infrastructure and data protection. Continuing on with our lessons in cloud services and security, we're now looking at system and data management, and we're going to look in this lesson at hardening the systems. How do we take a server, if you will, to make it more difficult for the bad guy to break into it and steal our information assets? And this is called system hardening. One of the concepts in system hardening is if we have a server that's on our network and it's holding sensitive information assets, we only want to run 1 or 2 services on that system. The more services you're running, the more exposed that system is to compromise. Each of those server services have open ports, and they're running software. Well, these open ports are holes where the bad guy can enter into that system, and the additional software that each of those services run provides additional opportunities for the bad guy to find vulnerabilities in that software and launch exploits which would compromise that software. So generally speaking, if I have a system that I need to harden, and here we're talking largely about the servers, I typically will only run 1 or 2 server-type services on these boxes. For example, if this box is a domain controller, I want to keep him as a domain controller alone, and I don't want to add any more services. And I say that. There is one other service that I probably will run on my domain controller to support my Active Directory, and that would be a domain name system server, a DNS server. And so these would be the 2 services that I would run on this domain controller. You wouldn't want to make it a file server. You wouldn't want to make it an FTP server or a web server as well. You don't want to run too many things on this one box because each one of those services, again, will have to open up ports so that those services can listen for unsolicited inbound requests for service. And in addition, each of those services are pieces of software that are typically highly vulnerable and open up opportunities for the bad guy to throw exploits at it and compromise those applications. So a minimum number of services on each server. That's number 1 when it comes to system hardening. Second thing is, I'm going to patch that server all the time. I'm going to update its firmware, its operating system, and the applications that it is running all the time. I'm going to be checking perhaps even on a daily basis for new updates. And as soon as I get the update, I'm going to test it, and then I'm going to deploy it on that box. So I'll need to keep this box very well updated with patches. Next, I'm going to disable and turn off and perhaps even uninstall, remove unneeded services and software from the computer. If this box is going to be a file server, I don't need software to run DHCP. I don't need Notepad, and I don't need other applications like Paint. So once again, figure out what this box is supposed to do. Any software that isn't essential for that box to do that one or two things, those two services we talked about before, delete that software or uninstall it from the box. And then, of course, disable all unnecessary services. If you can do without it, turn it off. There has to be a balance between security and functionality. You can't go too far with it, and how far should you go is dependent on the sensitivity level of the information assets that this box will at some point host or process. Next, we want to reduce the number of user accounts on the box. Knock it down to a bare minimum. You probably will need 2 or 3 administrative accounts, and you might need 1 or 2 standard user accounts. Whatever they are, be sure you really need it on the box. And if you don't need it on the box, remove it from the box. And if you do need it on the box, you provision it following the principle of least privilege. When a bad guy throws an exploit at a piece of software and is successfully able to compromise that software, gaining access to the access token for the user who launched the software, that means that the bad guy now has the same privilege level as the user who launched the application that the bad guy broke into. What I need to do is run those services, those applications, at the level of lowest privilege possible to run those services. Because when the bad guy breaks in, that's the level of privilege he has accomplished on this box. And we want to keep that as low as possible. Make him fight his way into this box. Every time he has to bump into something, it's my opportunity to detect him and stop his access of this box. So the minimum number of user accounts, and those accounts should be assigned the least possible privilege. Finally, we want to install and enable the host-based firewall. Now, many contemporary operating systems include a local firewall. And I also then want to configure and implement the appropriate rule base for that firewall. In other words, I want the default deny rule for all inbounds, and then I'll only enable or open holes for the services that I require, and I will keep that list as strict and as narrow as possible. Don't let anybody else in other than those specifically looking for the services I'm running. All other ports should be denied. I'll build additional rules such as an ingress filter and an egress filter, and any specific blacklists, any place that I wouldn't want to allow a connection to come in from. Now, the blacklist generally will have parallel with it a default deny, but we have some very specific denies even on ports that I have open. Let's say I'm running a DNS service for my Active Directory inside on my private network. I have to allow the ports for my users to access that Active Directory, but if the request comes from the public internet, in that case, I don't want to allow this request. So I might build some specific denies even for the services I have running if I can figure out places that those requests should never originate from. This would be the implementation of the host-based firewall and the firewall rule. Continuing on with our lesson on system hardening, next we're going to look at the need to install and update regularly antivirus and other anti-malware software. This software should be signature-based, in other words, easily detect previously seen viruses and malware, and it should also have an anomaly detection capability. In other words, it recognizes aberrant behavior and structure in software that we have either downloaded or are trying to use on the computer. So we need to have this installed, and we need to be regularly updating this antivirus software. In addition, we would probably want to install and enable a host-based intrusion protection system, and this means that we are now looking on the local box for aberrant behavior by applications. And if it does see anything that's unusual, this HIPS system, host-based intrusion protection system, would quarantine the aberrant software. Now, some of this HIPS software from some of the vendors will actually have a fingerprint for many, we're talking millions of known executables, and they've tested these executables, and they are known to be good and safe. So these would be approved applications by this antivirus software. If the application you're launching doesn't fit the fingerprint for one of those approved applications, the HIPS system would literally quarantine this software, send a copy of this software to the vendor, assuming you've blessed this. Then the vendor, within 24 hours, typically will return a response back to you, and now it becomes part of their standard database that this software is safe or not safe for use and denied. These systems actually learn what each and every executable is that you might operate on your computer and give it a thumbs up or a thumbs down. So that would be a host-based intrusion protection system. And we also need to be performing updates on these HIPS systems because there also is a signature-based component to these as well. So we need those updates. Every time somebody submits a new application, something that we haven't seen before, it's labeled as suspicious, it's temporarily quarantined, and then later when you get the approval back from the vendor, then you're able to run it. Or perhaps the software would remain in quarantine if it's found to be malicious in nature. Now, the next item on the list is starting to get to a pretty serious state of system hardening. This would be where we have a great deal of value in the information assets on this box. We would only do it where we have a high risk. We would actually literally remove the administrative tool set and utilities from the box. Now, the reason for this is if the box is in a position of exposure, perhaps it's in the DMZ, we might make the assumption that the bad guy sooner or later is going to break into this box. Now, if the bad guy does break into the box, again, we hope that we've got him contained down to a low level of privilege. And the next piece is then I don't want to give him the tools he needs to further break in deeper by escalating privilege and breaking out of the containment that I have him in with his initial exploitation. For my administrative convenience, I very often will store those tools and utilities on a CD-ROM or a USB thumb drive to make them available when I need to go administer the box, me being the legitimate user for the box. I'll store these administrative tools and utilities somewhere else and then connect those tools and utilities to the box when I have to administer the box. But get them off the box up front to make it more difficult for the bad guy to deepen his penetration if he is lucky enough to get broken into the box. Next, we're going to perform vulnerability scans and configuration scans on these boxes. This means that using some vulnerability scanning tool like Metasploit or Qualys, we will target these boxes and let the scanning tools identify any vulnerabilities they can identify from an external perspective. Now, with that external perspective, these scans, this is what the bad guy sees, and so we're looking for the vulnerabilities that the bad guy might be able to locate. If we can identify these vulnerabilities, then proactively I might be able to start knocking them down, take them away, patch, remove that service, close that port. Whatever the problem is, I'll identify the things that I can do to remove or reduce the vulnerability of the server. And the configuration scans will identify any alteration to the configuration. One of the things a bad guy will do when he successfully breaks into a box is he will reconfigure some components of the server to ease his entry and exit, his exfiltration path, if you will. I will document what the configuration of the box should be, and then I'll run scans against the box and verify that is what the configuration actually is. Any discrepancies need to be identified and investigated. It could be some accidental misconfiguration, or it could be a willful attempt at exploiting the box. Both require investigation and remediation. So vulnerability scans and configuration scans targeting this box to verify that it is as hardened and as secure as I hope it is. Next, we are going to take copies of every event that occurs on this server. We are going to journal all logs in real time to some remote, secure logging server. We need this log archive. Now, if you're subject to any laws or regulations, if there's any compliance requirements here, almost all of them will require that you don't trust the logs on the local box, that immediately, in real time, as soon as the event occurs, spit out a copy of that event to a second and secure remote logging server. Now, that logging server should be reviewing those logs in real time. It's a fine thing to have a record of when the bad guy broke in and how he broke in, but wouldn't it be better if we could spot it the moment he's breaking in and then we can stop him before he's able to steal something? So if we're not monitoring these logs, then it's nothing better than a track to help chase him down after he's gotten away with the crown jewels. First, we need to spin these logs off to get them secure to a logging server. In addition to that, we need to be looking at these logs in real time, correlating these events, and hopefully identifying the attack. Now, if you have a lot of systems that are being logged and monitored in real time, that's way too much information for any human to sit there and watch 24 hours a day. Typically, we need an automated solution, and that's where we use these security information and event management systems, the SIM system. Now, the SIM system is designed to be able to parse these logs from any type of infrastructure device. All these logs come in, and the SIM system can understand what the log is telling it. In addition, the SIM system will then correlate events using a very complex collection of rules and algorithms to correlate the events and identify even very low and slow and sophisticated types of advanced persistent threats. So the SIM system is a very valuable tool if you have to protect yourself at this high level, specifically related to legal and regulatory compliance. Now, they're expensive. They're difficult to configure properly and to interpret properly. However, if you can get to that level, boy, is that a good place to be. So, again, we need the secure logging server, a remote archive for all logs, and we should be reviewing these logs in real time if possible. In this lesson of securing the infrastructure, we're looking at configuration control, part of our system and data management section. Configuration control deals with every system in your enterprise. We're talking about servers and workstations and infrastructure devices like routers and switches and load balancers, firewalls. In addition to that, a new area is what we call the bring your own device, BYOD, because more and more we're seeing thin clients like pad devices and even perhaps cell phones that are operating as part of your information systems. So we have to now document each and every one of those devices. We need to know what operating system, what service pack level, what specific IP address, subnet mask, default gateway, DNS servers. We need to know what the firewall settings are like. We need to know what the routing rules are, things along these lines. This should be an approved configuration document for each of these devices, something that we can go back to and look at and compare the actual configuration from time to time with the documented configuration. And we should identify any deviations in the documented list versus what the actual configuration is. This would identify then some sort of misconfiguration, whether that's an accidental misconfiguration or a willful attempt at a breach. So your configuration control is a huge part of your security structure. If you don't know how your devices are configured or should be configured, you'll never know when a bad guy has broken in and has modified the configuration to enhance his position and ease his theft of your valuable information assets. Once we have documentation for each and every system, and we get an approval that it's a reasonably secure, appropriately secure configuration for that device, we need to then only make changes through a formal, rigid change approval process. And that comes down through a change approval policy and specific procedures. Now, the change approval process would be someone decides they want a new rule in the firewall because they've got some new service they're offering, or they need access and the firewall's currently blocking it, so they make a request. Now, that request should go through their immediate manager. That manager should approve that request and then forward that request up at least to 2 other people and maybe others who it might affect. It should at least go to the data owner for the division that is affected by this change, and also through the security department, so that the security department can look for things like conflicts of interest, too much authority, things along these lines. The approval process should include an explanation of why this change should be made, the security ramifications of if we make this change, it opens up a new potential vulnerability. Then we should look at what can we do to mitigate the vulnerabilities, investigate these carefully, document any additional changes that might be necessary. If everybody is satisfied that the increased risk is worth the benefits that we're going to gain from this configuration change, only then should this change be made. That approved list should then go to the administrative department, the custodians for the enterprise, and they should implement the change. Users should never make their own configuration changes, unless, of course, that's part of the policy and procedure. The administrator who's about to make the change should review the information carefully, should validate that it is something that can be done. He should make the change and document carefully the changes, because now this becomes part of the new configuration settings for the device. So that piece of information and documentation has to be accomplished. And then he should submit this completed change request back to management for verification. Someone should double check to make sure that the custodian did what the document said and didn't do anything in addition. They might also test the vulnerabilities associated with this configuration change. Periodically, we should audit the configuration of devices and verify that they match exactly what their documented configurations should be. And any deviations should be investigated. We should remediate the cause of the conflict, the fact that it's not in compliance with stated configuration documentation. Why did that happen? We must investigate each of these configurations that don't match the documented configuration because, again, of the risk of potentially a breach. Continuing with our lessons on securing the infrastructure, next we're going to look at security awareness training. Now, this is something that should be accomplished for every worker. If it's a new employee, before they are allowed to touch our information systems, they should go through security awareness training. How can you expect them to abide by the rules until you teach them what the rules are? So every worker must attend this training. It should be documented. We should get signatures and dates, perhaps even each year, from each employee that they've attended this training. So every new employee, and at least once a year, we should go through this routine standard security awareness training for every employee. Now, there is one other time where we might want to implement this security awareness training, and that would be any time we have any significant changes to the enterprise. If we buy a division, if we sell a division, if we merge with another company, if we have any significant turnover at the C level and we've got new policies and procedures, for example, anytime there might be significant changes to this IT environment, we might need to rerun the security awareness training. In addition to this, if any user has any heightened level of privilege, they might need additional supplemental security awareness training. For example, if we have administrators on the Windows systems, or we have administrators that operate as root in the Linux or Unix systems, these are highly privileged users, and they need additional training because they have access to many additional things. They need to be taught about the rules of if you're trying to accomplish this for good cause, it's part of your job, and you're not able to do this, then you have to make an additional request for additional privilege in order to make this change. So as the custodians of our IT environment, they must be more trained. They must have a more regimented vision on their actions on the network and the corporate information systems. So we have to be very careful that they understand what they're doing. We're going to teach them not just about policy, but about the technologies that they're implementing, their ability to identify and detect any sort of anomalies on the network. Other users that have a heightened level of privilege are those that perhaps carry a laptop computer. Laptops are a special area of vulnerability. Because many users are issued laptops, they're highly portable, they can be carried around. They also are very often lost or stolen. The major part of the loss is the data that lives on that laptop. We have to teach these laptop users the very severe importance of choosing strong passwords, of protecting the secrecy of those passwords over time. When it's time to choose a new password, make it very different from your last password. Don't reuse this password for anything else. Another part of it deals with encryption. We typically want to have whole disk encryption or at least have a large encrypted volume on the hard drive, which is where all the valuable information assets would live. So if you need to carry a laptop around, we're going to strongly encrypt all of the information that this laptop is going to carry. We also have to point out to these laptop users that they very often will find themselves using the wireless component of the laptop and connecting on to hotspots or other access points that we don't know anything about, highly untrusted wireless networks. And the fact that all communications that they trigger from the use of their laptop should be highly encrypted. This would be Wi-Fi Protected Access version 2, may also be called Robust Secure Network. Laptop users, if they're using wireless, should always use the strongest possible security. In addition, as a laptop user, they're carrying this box around and they plunk down at any location they feel like and they fire it up. Who's standing behind them looking over their shoulder? This is called shoulder surfing. They might be revealing our deepest, darkest secrets to the public by not paying any attention to who's standing behind them. So laptop users bring many, many different facets of risk to the use of our information assets. In our corporate network, we'll very often implement a wireless component. So these wireless users also are heightened security risks because of the connectless mechanisms that they attach to our network. We have to strongly authenticate these users. How can we tell it really is Bobo, an authorized and legitimate user, or a bad guy out in the parking lot who's pretending to be Bobo? So we have to strongly authenticate these users. And again, we need to teach them about the requirements for heightened security for the wireless use, the risks that are inherent with wireless use, and the ways they can defend us and them from those risks. So wireless users are also users that carry an extra level of privilege and increase our risk. The same with telecommuters. Telecommuters connect in over a VPN typically. We should always require that any telecommuters that connect to our corporate enterprise over the internet will only telecommute through the corporate virtual private network or VPN. This is an encrypted channel that starts at the telecommuter's computer at home, and the encryption stops only after it gets into our corporate network. Teach the user about the vulnerability that he presents by using this computer from his house. This means his computer, if it gets infected, might convey that infection to the corporate network. We have to teach these users the vulnerabilities they bring to the table, and then we have to teach them how to defend themselves and defend us from these increased vulnerabilities. Another level of privileged user is that collection of users that has access to highly sensitive data, our deepest, darkest secrets. Even on the corporate network, even if they're not remote, if they can touch this highly sensitive data, they also are highly privileged users. We should teach them more about passwords and encryption and the heightened risk that they bring, and then, of course, the many techniques and technologies we have available to help mitigate that risk. Another form of training that should be required, in addition to the every worker and the supplemental training, if someone misconfigures a system in violation of our policies, etc., then they should go for remedial training. This is kind of a minor penalty. They are taken out of their workplace and they're forced to sit for retraining because obviously they didn't pick up on it the first time. And also, this refreshes in their minds all the great things they're supposed to be doing to help us defend ourselves against compromise. So this is our security awareness training, part of our standard component of securing the infrastructure. Continuing on with our lessons in security awareness training, we need to ensure that this training includes safety training. It's not said often enough that human safety is our top priority when it comes to any incident or event in the enterprise. First comes safety, and then we start to protect the enterprise. So our safety training would include things like fire training, perhaps assigned roles and responsibilities relative to the fire drill, CPR training. If there are defibrillators available in the environment, then defibrillator training. Things along the lines of the use of a fire extinguisher, when to abandon the fire extinguisher and call for help. Safety is top priority. And then we can start to dive into these are the expected behaviors and practices and procedures we expect you to abide by in the enterprise. Those would be our policies and our procedures. Now, if you recall from earlier lessons, policies and procedures include all the laws and regulations that apply to our business operations. So these laws and regulations should be 100% represented within our policies and procedures. The applicable policies would include the acceptable use policy. Remember that our policies will address many topics, and not all of them boil down to the discrete user. A lot of these will be management's behavior, routine analysis like risk assessment and risk management practices that occur on an annual basis, and the development of our disaster recovery plan. Well, these aren't really components that affect every user. What we do is we boil out of all these policies and procedures the elements that directly relate to the discrete user, and that becomes our acceptable use policy, this subset, this summary, if you will, of the policies that affect the users. So that's one of our core components. That's the major document that we teach the users relative to our policies. Parallel to that, most laws and regulations will also require that we teach them about the sanctions, the penalties that they will suffer if they violate our policies. Especially if we're subject to laws and regulations, there might be very specific and very severe penalties for violation of these policies. It could even include criminal prosecution. So we are obligated to teach our users, you must abide by these rules. Otherwise, in theory, you could go to jail for this behavior. We would then relay all the requirements relative to HIPAA compliance, PCI compliance, Sarbanes-Oxley, Gramm-Leach-Bliley, Basel, FSMA, all the other laws and regulations that an enterprise might be subject to, because it's our users that are the ones that are hands-on with all the data, and those are the ones that very often will be the ones causing the violation of these laws and regulations. It might boil down to these are the ones that then are criminally prosecuted. Now that doesn't happen often, but it is a potential because these are laws and industry-based regulations. Next, we'll teach the users about all of the technologies we have implemented to support our security structure in the enterprise. If they don't know how to establish the VPN from the client side, you can't expect them to use the VPN. So we have to teach them about these things. We have to teach the users how to use the encrypted volume on a USB thumb drive, how to ensure that your data transfer is over an SSL tunnel or an IPsec VPN, for example. We need to teach the users the proper use of the technologies that support our policies and procedures. We also need to teach them of the monitoring that the enterprise is required to perform and the reporting of the findings of that monitoring. In other words, the users, while at work and while using enterprise-owned resources like computers and internet connectivity and other resources along these lines, there should be no expectation of privacy. These are business tools, and the information that they are inputting and accessing, this is business information, and there is no personal use of these components. So we have to monitor everything on the enterprise network, and the user should have no expectation of privacy. Now, all that said, different states and perhaps even different counties may have different laws and visions on what is personal information and what is private, and how far the enterprise might be able to go while monitoring and avoiding the violation of privacy. So always relative to this monitoring and the expectation of privacy of the users, We need to evaluate the local laws and have our local legal department advise us how far we can go with our monitoring. Next, we need to explain to our users about enforcement and sanctions. As I described earlier, many laws and regulations will require punitive response for breach of the laws or regulations. And because some of these are laws, as we said before, there might even be criminal prosecution. So we have to teach our users that we are required to enforce, and we might be required to punish, and perhaps even severely, if there are violations. Now, in addition to that, we also need to teach our users that they are expected to help us monitor, to be observant, to detect, and perhaps even enforce policy if they see others violating policy. A classic example is if we have a card swipe in order to access the building. If one person swipes and 3 people walk in, we only have the one person on record being in the building. The other 2 people should have swiped their cards so that we have an audit trail of everyone in the building. Now, here's where the user comes into play. The guy who swiped his card and opened the door, he should not allow others to walk through that door without their swiping their own badges and being logged as present in the building at that point in time. So I have the expectation of all users helping us with the monitoring, detection, and enforcement of our policies. So it goes further than just management will do these things. We expect the employees to do these things as well. In addition to all these, we will have assigned roles and responsibilities for various aspects of our security posture. Many of our users will be assigned roles on our incident response team, our fire drill team. With the fire incident, we'll have a sweeper that checks to make sure rooms are empty and windows are closed and doors are closed. We will also have someone who is responsible for the heating, ventilation, and air conditioning. The fire department will almost certainly want that ventilation system disabled until we're certain all people are out of the building. And then the fire department will probably want that heating, ventilation, and air conditioning to be turned back on to try and help clear the smoke out of the building. At first, when the fire alarm goes off, all doors closed, all rooms empty, ventilation system shut down. As soon as the fire company shows up and we're certain all people are out, they're going to want us to open the windows, to turn on the ventilation, and help dissipate that smoke so that they can penetrate the building safely and help to put out the fire. You'll want somebody to take roll and be sure everyone is present. And if they're not present, we need to locate them as quickly as possible to make sure that they didn't get trapped in the building somehow. We'll have people in the building that are steering the people away from the fire and toward the safe exits. There might be many roles assigned relative to the supporting of policies and procedures. And it is during the training that these users with the assigned roles will be educated about the nature of these roles and responsibilities. Our next lesson on securing the infrastructure deals with user provisioning. Now, user provisioning is the creation of user accounts and the removal of user accounts and the allocation of privilege or permissions for those specific users. So user account provisioning should be strictly guided by policy and procedures. There should be a very rigid and formal provisioning approval form. Now, once again, the manager for a user should be the one who initiates the request for additional privilege. That manager should justify why the additional privilege is required and should also include what permissions we might be able to remove from that user. See, very often as a user transfers from one department to another, he'll need additional privilege, but at the same time, there are privileges that we can remove, and we want to get those privileges taken away because we are bound to follow the principle of least privilege so that we don't allow a user too much information or too much access. During this user provisioning, if this is a new employee, we should, before we ever provision the user account, perform a pre-hire background check. So we should verify the resume, prior jobs, references, verify the skill set, perhaps by testing the candidate for employment. We should also verify their education. It is found that the vast majority of resumes will include completely inaccurate information. People will exaggerate their skills, their experience, their education, and all this stuff should be verified. Anytime you find discrepancies, you might ask a few questions, but it might be an indication this person isn't exactly trustworthy, and they're not all they present themselves to be. Now, a further component of the background checks deals with the actual individual character themselves. Prior convictions, the use of drugs, and perhaps even a credit check will identify character flaws. It might be an indication of someone who might be willing to do something a little less than ethical to try and dig themselves out of a hole. So we'll want to consider the possibility of going as far as the credit check. The convictions and drug screening, if there are any infractions relative to a criminal action or the use or sale of drugs on premises, if we didn't do these background checks, we might be identified as being negligent for not knowing we hired a convict, that we hired a drug user. We almost have to do these background checks prior to hiring the person and before we ever provision the user account. As we've said before, we always want to grant privilege following the principle of least privilege and need to know. Now, again, this should be part of the manager's request for additional permissions for the user, but it should be verified by someone from the security department signing off on this user provisioning approval form. We also should always consider what permissions can we remove from this user when we grant new privilege, and the provisioning request should also define any special monitoring and auditing requirements because of heightened levels of privilege. Now, the security department should identify and detect any omissions in this regard and should make these suggestions or perhaps even requirements as part of the approval process. But managers should eventually start to figure out that this is all part of the approval form. They should be the ones who are identifying the increased privilege and the need for increased auditing and monitoring. If the user has a heightened level of privilege, we might require multi-factor authentication. Now, once again, authentication is based on 3 different criteria. It could be based on something we know, like passwords or personal identification numbers or even passphrases. It could be based on something we have that is issued by the enterprise, like a token device or a smart card or a memory card to gain access, something you have, or it could be something you know, a biological attribute that we use as a biometric in order to authenticate users. Well, multi-factor authentication says we're using at least 2 of these different forms of authentication to strongly authenticate this user before we grant them access to any of our resources. The provisioning request form should also identify any needs for remote access. Recognize that anyone who comes in by wireless connections, by the old dial-up, we don't see much of that anymore, or by VPN, these are remote access users. These are telecommuters perhaps, or people using our wireless network. We can't physically locate them. We don't know where they are. They say they're Bobo, who lives right down the street, but they might be a bad guy trying to break into the network. So we need extra security precautions relative to any remote access users. And once again, that would be our old dial-up users, the Wi-Fi users, or any telecommuters that would reach into our corporate network over a virtual private network across the internet over a VPN. These are all remote access users, and they increase our security concerns greatly. So we have to impose stronger security, stronger authentication, stronger encryption, greater training so that the users are aware of their increased risk, etc., etc. The user provisioning form should also identify this is a laptop user. They've been issued a cell phone, perhaps. These are 2 other areas of exposure for the enterprise where they might be carrying highly sensitive information on these very easily lost or stolen mobile and portable devices. They, once again, increase our risk, and therefore they need extra training, and we need to further strengthen the security around that user account because we can't be sure it really is that user. It might be a bad guy who just stole the laptop and he's trying to steal more from us by reaching into the corporate network. We might also need to implement digital certificates for strong authentication and strong security. Now, digital certificates are a really strong security component, but they're kind of expensive. In some cases where the access is so highly privileged, with access to so sensitive information, the extra cost of the use of these digital certificates might be warranted. So we might need to issue these fairly costly digital certificates to help us secure these privileged users and these privileged resources. Once again, if we have a great deal of privilege, our concern is that we will have unauthorized access, that someone will steal a laptop and, not being Bobo, try to log in as Bobo, and then try to steal whatever Bobo has access to. So this would be an unauthorized user and unauthorized access. Now, we also have the concern that if we have a highly privileged user that is able to access highly sensitive information, they may actually misuse their authorized privilege to steal from us. So once again, the auditing will help us identify this misuse and perhaps this unauthorized access of these privileged users. Our security department will be responsible for identifying too much privilege issued to any particular user. An example used in one of the earlier lectures remains intact here. It still is viable. If we had a user that is responsible for purchasing, accounts payable, and inventory control, this is too much privilege, too much authority. And while it might be convenient from our management perspective, if we dump all those tasks on one person, Lulu, that gives Lulu too much authority. Lulu can now purchase things, pay for them, and then cook the books in inventory and steal some of the stuff she bought on the company's ticket and then sell that back on eBay or at the flea market over the weekend. It's too much authority, and this type of fraud could go on for years and years, and we'd never know it. So we need to break up that authority using separation of duties. Don't give anyone that many tasks, that much authority. We'll have multiple people performing this work. Then they're forced into a state of collusion, which, number one, is kind of risky and difficult to establish. Number two, increases the likelihood that we would detect the fraud in this state of collusion. Another technique we can use to knock down this high level of privilege is dual control. One user alone should not be allowed the authority to retrieve encryption keys. That should require 2 or 3 or even 4 of my top people come into agreement that yes, we really need, for good cause, to recover this encryption key, and then they work together to recover the key, and then they can expose the encrypted content as necessary. But one person having that much authority, that's too much authority. They could go bad on us, and we would never know that they are violating our security controls. So break it up and require multiple people implement that very sensitive function, such as key recovery. Another technique we have is job rotation. Don't let any one person stay in a job forever. Maybe once a year we have someone else sit in and do their work. They would recognize the anomalies of someone cooking the books, and now we can detect that fraud without going for decades perhaps and let this person commit fraud on the enterprise. Another technique is on a quarterly basis, send the books out and have an outside auditor inspect them, look them over and make sure the numbers all tally correctly, that there's nothing fishy, that our internal accountant isn't cooking our books. And then another technique to force this job rotation is mandatory vacations. If you force the person to take 2 weeks off when their vacation is due, then we have to roll someone into that job, and that person would identify anomalies in the processes that the prior person was performing. So these are some of the core aspects of secure user provisioning. As we continue with our lessons on securing the infrastructure, next we're going to look at monitoring, auditing, the response from detecting anomalies in that monitoring and auditing, and then enforcement responses. We should routinely be monitoring our environment. This is looking at the logs, such as both successful and failed logins, and we should also be performing spot checking, more targeted auditing. So monitoring is that general ongoing 24/7 and automatic recording of events that all infrastructure systems should be configured to do. But then auditing would be more that highly targeted spot checking that we would implement on our highly privileged users, or perhaps we've identified some sort of anomalies and we want a closer look. So we're now going to target this particular user or that particular resource that seems to be getting hammered on in an inappropriate manner. We have the obligation as an enterprise to know what's happening in our information systems. If we don't, number one, we'll never see the losses. We'll never see the bad guy who's stealing our stuff, and we'll never be anything less than negligent. So this means we have to know what's going on. If we are monitoring and auditing and we spot some anomalies, this means we can respond faster and minimize the losses that might be occurring. Whether it's a misconfiguration that's causing the loss, whether it's a hard drive that's failing, or whether it's a willful and malicious act, whatever the nature, if we recognize it sooner and respond sooner, we can help to reduce the losses from whatever this anomalous event is. We must be recording anomalies over time, anomalies, events, and incidences. Anomaly is just something that's peculiar. An event is any particular action, and an incident is cause for concern, worth investigating, but we might rule it off as nothing more than an anomaly or an event. Now, the incident, if it is substantiated as something going bad, then we have to respond and somehow remediate or enforce our policy or correct what's failing, whatever the nature of the anomaly is. So we should be documenting over time, let's say on a month-by-month basis, how often this type of incident is occurring, so that we can evaluate the effectiveness of our controls. And we might even identify the absence, the void, the missing control that we need. Suddenly we realize we've been losing $1,000 a week when all we had to do was put in this $20 part, and suddenly we can fix that problem and not lose that money. So unless we're monitoring with metrics over time, we can't tell how well we're doing with our monitoring and detection and our controls that we have in place. In addition, when we detect some violation, we must enforce our policies in a consistent manner. Let's say Bobo does something bad and we punish him for his violation. And then later Lulu does the same thing and we don't punish Lulu in the same manner. The next thing you know, you're going to wind up with a lawsuit for discrimination, and it might be difficult to prove why you punished Bobo but you didn't punish Lulu in the same manner. Could it be anything other than discrimination? And you might just wind up losing this lawsuit just because you didn't consistently enforce your policies. Next, we're going to look at incident response. Now, incident response should be a well-planned process with identified response team members and a collection of resources available for those team members to use as needed during an incident. What we'll wind up doing is establishing in our policies and procedures a specific computer incident response procedure, and then we'll assign team members to execute those procedures. Now, we call this a computer incident response team. It may also be a computer emergency response team, and some enterprises actually add the computer security incident response team to it. So it might be CSERT or even with a CERT for emergency. Different names, but the same notion. You've detected some sort of anomaly in your collection of events. You've tried to rule it out as a false positive. You tried to find why it wasn't a serious occurrence, some sort of breach or violation. However, you can't rule it out. Suddenly we have an incident that warrants investigation. This is an escalation process. Again, our goal is to not waste money on security. So if we can recognize they're doing some repair work on that router, that's why that router is being shut down and restarted on a regular basis. That's not some sort of attack. It's not a breach. We know that they're working on that. If we can conclude that it is just maintenance, then it's just another event that we should document, but it's not a breach, not a violation. So our goal is to not escalate this any further if possible. If we can conclude it's not an incident, reach that conclusion. But if we can't rule it out, then we must escalate. And each time we escalate, it's going to cost us more money in our response. We should have a well-trained team with assigned roles and responsibilities, and they will have a collection of resources. These might be specialized computers with specialized forensic applications or other investigation-type tools, sniffers, protocol analyzers. We might even deal with things like voltmeters and cameras, things along these lines, to help identify what is going on so that we can properly assess and then provide a calibrated and appropriate level of response. I don't want to pull the plug on the production line unless I have to. But if we conclude that we are losing $1 million an hour on that production line, I'm going to pull the plug on that production line. If I'm losing my trade secrets because of some breach on some server, I'm going to pull the plug on the firewall or the router or that server and not let the bad guy continue to siphon off my value. Again, our goal is to not waste money with an investigation or a response until we conclude it is an appropriate response. And that's where it takes investigation. Picking up where we left off on our lessons in incident response, this slide depicts the procedure that we will follow. This is generalized. Your enterprise might tune this a little bit, but these are the major steps that we need to be paying attention to as we implement our incident response plan. Now, ongoing, we will continually be monitoring with the hopes of detecting anomalies. We'll have someone who's watching events occur all day, every day. And there are millions and millions of events that will occur across the enterprise IT systems. The goal will be for them to identify anomalies to these events. All of a sudden, our FTP traffic went from 10 megabytes a minute to 0 megabytes a minute. What just happened? Did the FTP server fail? Has it been denial of service? Power failure, perhaps? Their first goal will be to try to rule these anomalies out as non-events. That's a known problem, and we're trying to get it resolved. There's a team working on it right now. So they're going to try to rule these anomalies out as false positives. However, if they can't rule them out, they escalate to a higher level of investigation, and at some point we declare this is an incident, and it requires a very powerful team of experts to investigate and identify what's going on, and then hopefully quickly remediate the problem, because it might be that we are losing large amounts of data every minute that this persists. Our next phase then is triage, where we need to identify how significant is this event. Is it just on this server? Check the other servers. Is it just this location? Check the other locations. What's the nature of this? How do we recognize it? So we're starting to figure out the significance of this incident, and that's triage. This is a 3-tier prioritization of what portion of these losses do we address first. Next, we're going to investigate. This is where we're trying to identify what is going on. Is this malware? Is this an active willful exploit? Is this a misconfiguration? Is it a device that's just failing? And we need to figure out what is the active agent and what is being lost. So this is all gathering information. Our goal will be to contain it in the next phase. And in containment, our goal is to stop these losses, slow it down, and or stop it completely. Don't let it spread. Don't let it steal any more of our information. So containment is the next step. That's the goal of that first investigation phase. Once we feel we have figured it out and we now have it contained where it's not spreading and we're not losing any more information, our next goal is to analyze, is the containment successful? Have them check these things and see if they're seeing it over there. That's our first step in analyzing the containment. Did we do this correctly? The second part of this is, all right, now that we're comfortable that we've got it contained, now we're really looking at eradication. How do we get this thing removed from our systems? Now, parallel to this part of analysis, we might have the confidence level to start reallocating some of our skill set towards tracking and evidence collecting. Once we're comfortable we have stopped the losses and it's not spreading anymore, in addition to figuring out how to eradicate it, we're going to try to figure out who did this to us. How did they break in? What was the vulnerability? What was the missing security control? What skill set was missing? What piece of software? What piece of hardware was missing? How did this breach occur? And if we can, identify who did this so that we might actually prosecute this entity. It might not be an individual. Here's where we're starting to gather evidence in hopes of eventual prosecution. Now, after we've turned the tide on this guy, we've stopped the losses, and we're starting to figure out who the bad guy is, parallel to that, we're going to start to actually eradicate all the active agents and the damages. This eradication stage is an important stage, and only when we're completely certain that the system is safe should we ever attempt to return it back online. Now that I know what the vulnerability was that let the bad guy in, I'm going to block that thing. I'm going to fix it so that the bad guy can't just break in again 10 minutes after I put it back online. So I have to now improve the security posture of these compromised systems. My goal then is to return to a state of normal. The next phase of this is to take a look at the lessons we learned. What went right? What went wrong? What software did we need to help us with our response? What security control is missing that allowed for the breach? Do we have that vulnerability anywhere else? Do we need to shore up our security because of this new type of threat? So we're going to look at now the ways that we can make our response process more efficient. We can train our response team better. We can have the right resources on hand to help, number one, prevent the potential losses in the future, or number two, if we can't prevent it, be able to detect, respond, and recover more quickly so that we minimize our losses. So this would be the incident response process. Monitor and detect, then quantify how significant with triage, that's prioritizing what things do I fix first. I'll investigate to figure out what is the active agent, what is being lost. Then I'll try to contain the active agent and mitigate the losses. Then I'll analyze, did we successfully contain? How do we get this thing off of our systems? Then I'll turn the tides and I'll go after the bad guy, trying to figure out who he is, trying to figure out how he got in, and then figure out how I can protect my environment more strongly. I'll eradicate all traces of the active agent and the damages. I'll recover to a state of normal, and then I'll implement my lessons learned, my review, to improve my security posture overall. So collectively, these 9 items help to build the secure infrastructure. The framework for governance, risk management, the security program, data protection techniques, system and data management techniques, security awareness training, secure user provisioning, monitoring and enforcement, and having an appropriate incident response team. In this series of videos, we're going to be looking at how you would prepare to deploy to the cloud. This would be applications or data or both. So we're going to look at how you would start to anticipate this move into the cloud and be sure that you do it with the right preparation and planning and the right level of security. We're going to start with the requirement for some sort of framework for governance for the cloud services. In other words, in our written documentation that we use to manage our enterprise, we also will need to include new documentation as to how we will govern or manage our use of these cloud services. And typically where we need to establish this isn't so much on our internal private cloud. That's pretty well covered by our standard internal policies already in place. But because so many of us will be using these leased services to satisfy our needs, we need to define the rules on how we plan to govern these cloud service providers. So this is this framework for cloud governance. It has to be documented policies. It will eventually evolve into a written agreement between the enterprise and the cloud service provider. We have this framework for cloud governance, this foundation or structure on how we're going to manage those cloud service providers. Next, we have to start thinking about how we will use the cloud and the things that we need to put in place to ensure that our use of the cloud is prudent and secure and reasonable, and we've solved many of those problems as we migrate towards the cloud. Next, we're going to look then at specific security controls, things that we should implement, get our hands on in-house to help us manage and monitor our use of the cloud. And this would be increased use of data loss prevention systems, DLP, so that we can control what goes out to the cloud. We might use some sanitization type of filters that might remove certain keywords that we find sensitive. We might also look at new policies and procedures. And of course, as you see the next bullet down, security awareness training for the cloud users. All the things that help us secure that cloud environment and the use of that cloud environment. That's what that third bullet is for. And then, of course, once we get our heads on straight about what we're going to do, we actually have to teach our users this is the way we do it. And we have to teach them the technologies. We have to teach them the rules. We have to teach them the fundamentals of the secure and proper use of the cloud. Things that are authorized to be in the cloud, things you may not put up into the cloud, things along these lines. The last section in this area is going to be understanding who your cloud service provider is. Just because they send you a printed contract, an agreement that says, we promise we do this and we do that, you need some sort of due diligence, some sort of background knowledge and awareness of, yeah, I think these guys are actually capable of doing this. So that's our due diligence on these intended cloud service providers. Can that guy actually do what his contract says he's going to do? And even if he can do it, are we sure he's actually doing it? It probably costs him money to do it right. He might decide to go the cheap route, and if you're not looking too closely, he can probably get away with a whole lot of things that he agreed to that he's actually not providing. So we have to really understand who it is that we're dealing with, and that's the due diligence on the intended cloud service providers. In more detail, looking at the framework for governance for the cloud service providers, we need to manage those cloud service providers the same way we manage our internal workers. If we have rules on what must be encrypted while it's in storage internally, those same rules need to apply externally. If we have rules about users may not transmit this data under these conditions, then our cloud service provider must also know that they may also not transmit data in that particular fashion. All the rules that we apply to our internal workers, those same data controls and security controls that we have on our workers, they all have to be applied to the cloud service provider. Now, these would be substantiated in a service agreement with the cloud service provider. What we're talking about here is we're going to document in our policy structure, this is how we will manage the cloud service providers. We're going to write policies that we impose upon ourselves that say when we use these cloud services, this is how we're going to do it. Then, of course, is the written terms in the service agreement with that cloud service provider. Now, there's a whole section on this coming up in this series of videos on secure cloud use. First, the cloud service provider must agree to abide by all applicable laws and regulations. That means if some of the data we put up on the cloud is medical and subject to HIPAA compliance regulations, the cloud service provider must protect this information following those same HIPAA laws. If it's PCI data, they agree they will protect it following the PCI DSS. That's Payment Card Industry Data Security Standard. That is a regulation that might be imposed on the enterprise. We need to in turn impose those same rules and requirements on the cloud service provider. They have to agree to abide by all these laws and regulations, and we, of course, have to identify those different pieces of information appropriately so they understand this is HIPAA data, this data is not subject to any particular laws or regulations. Next, we need, again, as we said, security at least equal to the internal security structure of the enterprise. Everything we require of our workers, we require it of their workers. They must agree to it, and we have to have the ability to monitor that. The service provider must also guarantee compliance and then accept liability and penalties for any violation. In other words, if we push PCI data up into the cloud, and they've agreed that they will protect it in compliance with PCI, and then we find that they don't, and because they're not in compliance, the enterprise receives some sort of penalty from PCI. If that penalty comes to us, that our provider now is responsible for paying this penalty, and he agreed contractually to pay these penalties that he caused. Now, if, of course, we failed in some capacity internally, and we didn't label it correctly, or we didn't secure it correctly as it went up into the cloud, of course, that would be our fault and we'd have to accept those penalties. But if the blame falls on the cloud service provider, he accepts all liability and penalties for these violations. The law says that the enterprise is specifically responsible, and it's very possible that you won't be able to transfer that blame to the cloud service provider. However, we still want as strong a language in our agreement as possible to support that notion, and then we'll let the lawyers figure it out after that. Now, another area of establishing this framework for cloud governance is we have to know, and again, this is something we document in our policies on how we're going to govern those cloud service providers. We have to have the rights and ability to monitor, audit, inspect, challenge, test, verify all aspects of these cloud services. We can't just trust that the cloud service provider is going to do what he promised. We have to know that he's doing it. If we're not monitoring him and verifying that he is performing as agreed, then we are negligent. And if there is some breach or some failure of compliance, then we are liable for those losses because we weren't prudently managing that cloud service provider. So that becomes our fault then. So we have to have the right to be able to do these things. We also have to have it built into our policies and our procedures that we automatically do this. This is part of who we are all day, every day, with the protection of our valuable information assets. Continuing on with our lessons in preparing for cloud use, consider the confidentiality, integrity, and the availability of the data and the services that we're going to host in the cloud. We need to be sure that they are protected properly and what types of protection are going to be required and what controls are we going to need to satisfy those security goals. We need to verify with our cloud services providers exactly what level of availability our data and services will have. Then, of course, the area that we need to focus on the most, where we would need to implement proper controls, would be the protection of the confidentiality and the integrity. So we'll be looking at the need for these services, the security tools we might use to help us achieve that level of protection relative to those security goals. Another thing we'll look at is identifying the different users and the actual systems. These would be workstations and perhaps even servers that might be authorized to access the cloud resources. We might have controls, perhaps in our firewalls, for example, at the periphery of our private network, that these users may go to the cloud and anybody not on this list is not authorized to connect to those locations in the cloud. We might also have controls on those firewalls that say these systems are authorized to connect to systems within the cloud. However, if you're not on this list, you are not authorized to connect to resources in the cloud. Using typically firewall controls, we can implement these limitations, if you will, on the users and the systems based on our authorized list of users and systems that may access these cloud resources. Another aspect of this is we want to be very careful that we define what types of data and what types of applications might be approved or perhaps specifically denied for use in the cloud. Some of our information and processes might be a little too valuable to expose to that multi-tenant environment. We shouldn't ever exactly trust their complete sincerity and their ability to completely protect our assets the way they describe. Consider the types of cloud environment that we're moving into. If it's this private internal cloud, this has very low risk. This is the most trusted environment. We own it all, we manage it all, and we have our external controls that help us protect these assets from outsiders touching our stuff. However, if we do anything external, even the private external, that cloud service provider might promise us that we're going to be on a dedicated server and a dedicated storage area network on his end. Do we really know? And even if he says it's dedicated, that nobody else actually puts their stuff on our collection of hard disks, do we know that he has proper boundaries up? This is called siloing, where we're isolated, nobody else can get in. We need to be sure that that cloud service provider is actually effectively keeping us isolated from the other tenants that he's providing resources to. We're running across the same switches and routers. and other backbones that the cloud service provider has in his data center. So even if we're leasing a private dedicated collection of servers, we still have this concern about protection of our valuable information assets. Is that guy really doing what he says he's doing? So even if it's the private external cloud, we have some security risks. Now, as we move to community and public, where it's external and multi-tenant, we actually might be commingling our data on hard disk drives that perhaps even our competitors are accessing and storing their information on. And this might be just a little too much exposure. Now, once again, the cloud service provider understands these concerns. They aren't unique to any one company or entity or client. So the cloud service provider typically is very well aware and has pretty good controls. At the same time, do we really trust him? We have to reassure ourselves, and this is only done through proper monitoring and proper inspection, perhaps even on-site inspections and verification that all the controls that they promised are in place and being utilized, and that they are actually effective at protecting our valuable information assets. As we get using the public cloud services and the community services, now we really have this exposure, and we really want to be very, very careful about what we put in this cloud. Another aspect of our planning for cloud use will deal with what resources are we going to require, how much storage, what type of bandwidth are we going to require, processing power. Most of the time, the cloud services providers will give us what we call 5 nines uptime. And that says they're only allowed to have us offline for just a few minutes a year, and otherwise they're in violation of their contract. So we need to be sure that there is a statement about guaranteed uptime and availability, that's complete connectivity, that the disks are attached, that the networking infrastructure inside the cloud services provider's environment are complete and intact and functional. So that's a great deal of demand on our part, a great deal of commitment on the cloud service provider's part, and it has to be built into our service agreement that assures these standards for availability and these penalties if that availability is not provided. So if they go like 7 minutes of downtime in a year, you might have a clause that says they owe you $100,000 in refund on your fees for your cloud services. So there's a huge demand that they keep your stuff available. Generally, cloud services provide typically excellent availability. That's one of the things they're great about. It's typically the other areas that we're concerned with. However, we still can't ignore this one. Even though this is where they probably are the best availability, we still need to verify that they're doing what they promised and that there are penalties if they fail to do what they promised. Now, another area of concern that might present itself to an enterprise is if we have sensitive data that we need access to all the time, we might require that that information be stored in a specific geographic location. An angle on this is if we keep the information stored on, let's say, 3 different systems here in the Southeast United States, for example, that somewhat contains the exposure of that information, rather than I have that same data set on 15 or 30 servers across the country. While that might be great for availability, we greatly increase the potential for compromise. So we might want these guaranteed data locations. And there may be other performance metrics that you have specialized concerns for based on your specialized needs. So this is the beginning point of this list, but you may want to continue this list on as you recognize more and more about what your specific goals, objectives, and needs are for these cloud services. And then one last thing is whatever numbers you nail down here, realize those are probably numbers that are valid for today. What happens a year from now when your number of employees is increased by 50%, your number of workload is increased by 60 or 70%? You are going to need increased resources over time. So anticipate growth in your cloud use. Very often we don't plan on this correctly and we underestimate, and before we know it, our needs have grown so rapidly. So anticipate growth in your cloud use. Continuing with our lessons in preparing for cloud use, we're looking at the planning requirements. What should we be considering? What should we be ramping up for? What should we be anticipating as we begin to migrate into cloud services? So one of the things that we'll need to plan for is normalizing data that goes up into the cloud. Data normalization is, in some cases, a huge project where we need to standardize the formatting of the data so that any number of applications can reach into these data sets, retrieve data that matches perhaps some query. That data that it retrieves and pulls back is actually properly formatted so that the application can actually ingest it, if you will, and then process it properly. For example, if we pull a last name field and the application that we're going to process the data with can only swallow a 15-character last name, but there might be a data set in the cloud where a last name field might contain 20 characters, that particular record can't be migrated into the application. So we have to normalize the data so that all the data has a standard formatting so that whatever applications we're using to process that data can actually retrieve it and actually utilize it, that it doesn't violate any of the constraints that are placed on the various types of data that come back from the cloud. So we need to normalize the data, and once again, typically that's standard data formatting. We want to not store a piece of data more than once. In other words, if I have 10 different databases and Bobo, one of my customers, has his address in 4 of those databases, what I'm going to do is delete 3 of those address fields and simply install a pointer to the 4th field that actually does contain the data. This is called deduplication. I'm going to remove any duplicates of the information I store in the database. This way, if Bobo ever moves and I have to update his address, I only have to go to one location to update the address, and the other 3 locations on those other databases don't actually contain the data. They just contain a pointer to the one database that does actually hold the data. Another technique used in data normalization deals with the way information is presented. If I look at a database that has my customer list, I might have 1,000 customers in California, for example. And when I look at the state field for these addresses in this database for California, I'll see uppercase C, uppercase A. I'll see a lowercase c and a lowercase a. I'll see the word California written out with an uppercase C. I'll see the word California written out all in capitals. I might see all sorts of variations on how California, that one piece of information, might be represented. What I'll do in my data normalization processes is delete all of these California references and replace it with a standard, singular, monolithic type of reference, uppercase C, uppercase A. And that way, anytime I need to find my customers in California, I submit a query for uppercase C, uppercase A in the state field. I will get every record returned, and I don't have to worry about case sensitivity. I don't have to worry about misspelling, etc., etc. I'll get every record that is a California record. So that's yet another form of data normalization. And very often this is something we're going to do in-house as well. But one of the reasons we would migrate to the cloud is because our in-house data store is being outgrown. In other words, a huge amount of information, and we need to push it up to the cloud, for example. So as we reach this threshold, this might be a good time. If you're not already doing it, do it now. Generally, again, we're talking about a large data store, and I want this data to be as usable as possible, as consistent as possible, and I want to avoid violations of integrity and things along these lines. So this is data normalization. Now, the next aspect of planning for cloud use is anticipate the need to strongly authenticate your users in the cloud, and how then to prudently deploy authorization, again following the principle of least privilege. Now that we know who the guy is, how do we control what that guy has access to? And then finally, we need to be able to audit or keep track of what the guy is doing when he's working in the cloud. And these are called AAA services: authentication, authorization, and accountability capabilities. I'll need to understand what the different CSPs who might be trying to get my business, how do they solve these problems? Cloud service provider, how do you do this? And how do I know that it's going to satisfy my needs? I'll need to consider, how does the cloud provide these AAA services: authentication, authorization, and accountability? Another thing I'll do in my planning process is identify any special security concerns that I might have about my data sets or my processes, my intellectual property. Anywhere where I have high-value data, high-value intellectual property, high-value processes that I would consider highly confidential. These are potential exposure points. Another angle on exposure points is the different ways that people might be able to connect into my cloud resources. Identify any of these special security concerns that you may have where you are concerned that your information might be too accessible, that might lend itself to some sort of breach. And so any area that you can identify of heightened sensitivity, heightened concern, you should address these issues with the potential cloud service provider and see if they can convince you they've got all the right stuff. You make them prove these capabilities to you, and then maybe you can move forward with some sense of confidence that your information assets won't be compromised. Another angle that we'll need to prepare for in migrating towards the cloud is encryption key escrow. Anything you put in the cloud, you probably should secure it while it's in storage. And as you're transmitting information up to and down from the cloud, those network channels should be secured as well. Now that means that we've got an awful lot of encryption happening. And one thing I don't want to have happen is that some user encrypted something, put it up in the cloud, and then somehow lost the decryption key. So what this says is I, as a prudent IT administrator, I have to ensure that the enterprise can always gain access to their valuable information assets. Otherwise, I've allowed a breach of the availability of this valuable information asset. Whatever encryption keys they are using, the IT administrator must be able to decrypt that information. And one of the techniques I have to help ensure that I can decrypt any of this encrypted information up in the cloud is to escrow every encryption key that gets used in this encryption process. So as my users are storing stuff up in the cloud in an encrypted fashion, I need to have decryption keys somewhere at my availability so that if something happens to that user's keys, he reformats his hard drive, the laptop gets stolen, a smart card gets lost, something along these lines. If there are decryption keys, I need a copy. And that's my encryption key escrow. Now, this is a huge project all by itself, and it should be carefully considered and carefully addressed. This could be a whole new aspect of your cloud deployment that needs to be budgeted and planned for with new technologies. Or we could write a policy and a procedure that simplifies it all, that everybody puts their content in the same store, and I have a master key for that store. Finally, on this list, we're going to look at the need for security tools that we need to purchase the software, we need to train our users on, we need to get some skill sets, some experience using these tools before we start pushing data out into the cloud. We have to know that we can manage this stuff, that we can secure it properly, and monitor our activities properly before we start putting our data in that risky environment. Part of our planning for cloud use then is to identify these required security tools, get them in-house, get some people trained, and get some experience using them in-house before you start pushing data out into the cloud, and then we can use those tools out in the cloud. Microsoft has provided us a cloud security readiness tool, a summary of the numerous users using Microsoft's cloud services. They've completed a survey, and they discuss some of their concerns and how those concerns were resolved, et cetera, et cetera. So there's a nice report. We'll look at that. And then finally, we're going to look at a web application called the Cloud Security Readiness Tool itself, the Trends in Cloud Computing Cloud Security Readiness Tool. This is, as we said, a collection of responses to a survey relative to the use of cloud services. It's at Microsoft.com, and if you simply Google this name, you'll come right to this web page. So as we can see, we have some details about it, a summary of what this report is about. Data was compiled from 2012 to March of 2013, 27 different questions from different clients around the world. You can bring this document down and review it on just about any platform, and there might be some other related resources that you want to look at relative to cloud use from Microsoft. Now, the other website I wanted to point out quickly is the actual tool. So this is a web-based application that you can connect up to online. The URL is documented on the slide. It's also here on the display that we're looking at. And as you can see, there are a series of questions that you can answer that will help Microsoft steer you towards the right collection of services and perhaps security concerns. Here we would type in some company name, let's say ABC123 is the company name. The industry that best matches what we're trying to accomplish, I'm just going to grab something off the list, IT services. Where are we located? Let's just say we're here in the United States. We're going to look at the services or capabilities we're requiring. See here, line of business applications. Well, that's software as a service. Messaging and communications, again, software as a service. Business analytics, content creation. Now, content creation could be software as a service, could also be platform as a service. Here we have virtual desktop. That's platform as a service. Storage services, infrastructure as a service, as we described in the past. So let's say we want to do line of business applications. And total computers in our enterprise, let's say we've got a couple thousand. Microsoft recommends that we use platform as a service to satisfy these business needs that I've described in those preceding checkboxes. And they also recommend a standard collection of security controls. This is the ISO 27000 series, and this series talks about how do you secure your computing environment. If we had PCI concerns, you see I can shift to PCI DSS. If we had medical records, I could go to HIPAA, etc. And then we move forward from there. So we could click next and move into deeper and deeper types of analysis to help guide us to the proper Microsoft solutions. Continuing with our lessons on preparing for cloud use, we're going to start looking at security controls that we might implement within the corporate environment to help us protect the confidentiality, integrity, and availability of the valuable information assets, the data, and the processes that we deploy to the cloud. So one of the first things we're going to do when we start migrating towards the cloud is identify what type of data is appropriate to be placed in the cloud. And as you recall from earlier lessons, there are different types of cloud deployments. We have the private and internal cloud deployment where we own it, we manage it, so our data is protected there. However, we also have the very risky community and public clouds that are external, and these are joint tenancy where we have an increased opportunity for the bad guy to violate our security controls and access our information in violation of our policy and our objectives. So we might want to say, based on a data classification procedure, what classifications of data are authorized for the cloud and what classifications of data, the more highly valued assets, are not authorized for the cloud, for example. So we should place limits, and this would be by policy, and then of course we'd have to teach the users, based on this policy that you have to follow, these are the rules. This data type can go up and this data type cannot go up to the cloud. We then should identify technologies that we can deploy on the corporate network to help us implement those privileges, those limits. So again, we first start with policies and procedures. This is the documentation, the definition of what can go up and what shouldn't go up. Then we have to teach the users what these policies and procedures say. And then we have to monitor what the users are doing and enforce those policies. So this is our administrative angle on securing the information that moves up to the cloud and helps us control the protection of those assets. Another tool we have is our data loss prevention or rights management systems that might allow us to identify information assets, usually through certain keywords, perhaps in a header or a footer or in the metadata for the data files that we can filter on. So we have these systems at our exit points. They call these egress points of our network out to the public internet, in this case, towards the cloud. These systems monitor the information flow and look for these keywords. If any of these keywords are recognized in the information assets that are flowing towards the cloud, for example, we could have this data loss prevention system deny its export to the cloud. Then it would send an alert to some administrator, perhaps even to the guy who tried to send the data out, that this is not authorized for cloud use. Therefore, we would disallow the information flowing up to the cloud. So first we stop it, and then we alert so that people know about it, because it could be a training thing, it could be a policy violation. things along these lines. DLP is more for the character-based files like Word documents and spreadsheets, where digital rights management for audio and video types of information, maybe photographs as well. Now, another tool we'll use is called data sanitization. This would be implemented through some, perhaps, technologies, also could be implemented through manual manipulation of the information assets. So sanitization says we're going to remove information from the collection of data that's being sent to the internet or to the cloud, and we might sanitize the information we're pumping up to the cloud, perhaps if it has medical records, employee personally identifiable information, customer PII, things along these lines. So based on laws, the permissions of who's going to access this information, their level of authorization, the role in the enterprise, these are some of the guidelines or boundaries that we would establish to help us control the security of the information that goes up to the cloud. We'll remove information, specific details from the body of data that's going up to the cloud to try and protect ourselves and not violate these laws or violate our own policies relative to the information flowing up to the cloud. Now, another technique that we can use as we remove these details from the data that goes up to the cloud is, instead of placing this medical information, I can simply put a pointer, if you will, in the database, for example, that goes up to the cloud. So instead of the medical record, I put a pointer in that location where the record was. And then I store the medical record actually on my private network, so that when we submit a query up to the cloud, and this medical record might be one of the results set, the results set returns the pointer. That's the only thing we store in the cloud where we have a greater amount of risk. And that pointer then points to a location on the private network where I have less risk because I have greater control. So I might store the data internally on a database server, for example, but up on the cloud where I have a greater availability, greater access, perhaps even like telecommuters in different locations need to access the same database, I'll put this pointer in that data store, and the pointer then points to a local internal copy so that the actual sensitive data doesn't go up into the cloud. So this is called data tokenization, where I put a token in the database that points back to the actual real data, and I store that sensitive information in a more secure environment. Another security control that we want to implement, and this is something that you'll have to work with your cloud service provider on, and that is the secure destruction of unneeded data. Let's say, for example, I delete a Word document from my store in the cloud. When I delete a file on a hard drive on some storage unit, the data is actually not removed from the hard drive. The only thing that happens is they overwrite the first character of the file name in something like the table of contents. Typically, it's called something like the file allocation table or the master file table. These are two names for these table of contents that say this is the file name and this is where it's located and here are some of its attributes. So the file system manages this file allocation table. And when you delete the file, all you really do is overwrite the first character of the file name with a question mark, and all the other information remains intact. All the data is still actually magnetically stored on the hard drive itself. So the data didn't actually get removed from the hard disk. These are referred to as remnants. The data actually still stays on this hard drive until some other file write operation needs the location where these bits are stored that formed your old file, and then finally overwrites those bits that were your data. So at some point, those open blocks or clusters get overwritten by some new file that needed that space. And that's actually the only time when typically your data actually truly gets destroyed. Until that happens, that old file, the one that you deleted, as a remnant still can be recovered. So the information is still exposed to the bad guy being able to recover it. So when we delete data from the cloud, we should use a secure destruction procedure. Now, some of the security tools that you might buy, like PGP, for example, has a data shredder. And what the data shredder does is when you delete a file using the PGP's data shredder, is it first overwrites all the file bits with random bits, and as a result can't be reassembled to mean anything meaningful. So the first thing we do is we overwrite the entire file. Every single bit gets overwritten with just a random pattern of ones and zeros. And then we save that file, and then we delete the overwritten file. Now that's secure destruction. So in this case, the remnants that might remain on the hard drive really don't contain any valuable information. It's just random garbage bits. So that is secure destruction of files. Now there's another particular area of concern relative to secure destruction of unneeded data. Typically, a cloud is built on many servers, and these servers have access to their own data store, their own collection of hard disk drives. When you spawn a virtual machine, one of the servers in that cluster actually hosts your new virtual machine, the one you just spawned. But over time, to support load balancing across the cluster, your virtual machine might actually be migrated over to a separate piece of hardware to help offset the connectivity, the bandwidth load, the CPU load, or the RAM load. These are three primary concerns. And if any one of those are high where your virtual machine is running right now compared to the other nodes of the cluster, your virtual machine might be migrated to one of the other pieces of hardware, the other servers, the members of the cluster. It's invisible to the end user. It keeps performance way high. It keeps the system's load balanced. That's lovely for all those reasons. The downside is this. Guess what happened to the memory contents of your virtual machine on the first system? That data now becomes remnants on that first system and would be recoverable through many different recovery tools. So once again, the virtual machine that you spawned on server 1 that migrated to server 4, that virtual machine now has remnants on server 1, even though the live machine now is operating off of server 4. So the data that was in RAM now still exists in RAM until some other process needs it and it gets overwritten. So once again, as before, the first thing we should do as soon as that VM moves from server 1 over to server 4 in my example, the next thing we should do is overwrite all of the RAM on server 1 where that virtual machine was occupying. And then, and only after we overwrite every single bit with garbage bits, with random data, only after we do this full overwrite of the RAM that virtual machine was occupying do we release that RAM back to the operating system. So this is the secure destruction of the virtual machine as it migrates from one system to another. And this is where you might need to work with your cloud service provider. The file secure destruction that we described earlier, that's something that you teach your users how to do, and of course you have to provide them the technology. Some of them are free little applications. Other times you buy a security package that includes a secure shredder for your files. So this would be a matter of making the technology available to your users, adding it to their policies and procedures, and then teaching the users how to use it. The next piece would be, of course, you have to monitor that and enforce it. So these are some of the security controls as we are preparing for cloud use. And there are several other lessons that we're going to review in this series. In this lesson, we're going to continue our review of security controls as we prepare for cloud use. We're going to look next at what we call the Network Enterprise Connect Zone. This is a perimeter segment of your private network in the enterprise that is much like a DMZ, a demilitarized zone, only this Enterprise Connect Zone is dedicated to cloud connectivity. We would not put any valuable information assets in this Enterprise Connect Zone. We would only place whatever is required in order for our internal LAN users to be able to properly authenticate and be authorized to access the cloud. And also, if we have, let's say, telecommuters that might be all around the country and all around the globe that would use the internet to connect into our cloud, we might have them come into the Enterprise Connect Zone and authenticate properly. And only after we authenticate them on our Enterprise Connect Zone would we then allow them to connect into our cloud services. So we might, in this Enterprise Connect Zone, need a separate directory services environment like a domain controller as implemented in the Windows arena. The user accounts would be our telecommuters. that might be all over the planet. They use the internet to connect inbound to authenticate into our Active Directory, and then our Active Directory will help us authorize these users for access to our cloud services, whether they're internal or external thereafter. In this case, we would probably use a reverse proxy. Now, a reverse proxy is a type of a firewall that allows for inbound client connections into this Enterprise Connect zone, and it actually breaks the session between the client and the proxy server. Then the proxy server turns around and reaches into the Enterprise Connect zone and performs the authentication service or function on behalf of the client. So as far as Active Directory is concerned, all these telecommuting clients are coming from this one machine, the reverse proxy. The clients think that it's the reverse proxy that's doing all the authentication services. So the reverse proxy breaks the connection between the client and the Active Directory. This provides us another level of authentication and filtering and setting policies on this user is allowed to connect in on this day at that time, but not the other day on some other time, and et cetera, et cetera. So I've got 20 or 50 or 100 different controls that I can impose at that proxy server on each and every one of those users. Either I can build security groups and do it on a role-based type of function, or I can authorize discrete individuals. Perhaps I have a couple of heavyweights that need access all the time to anything, and so I will strongly authenticate those guys using the reverse proxy and Active Directory, and perhaps something like multi-factor authentication, and then authorize them to their highly privileged access levels. So I can use these tools within this Enterprise Connect zone to help secure the access using the AAA services, authentication, authorization, and accountability for client authentication services and getting them the appropriate access. So the Enterprise Connect zone is for our internal clients connecting up to the cloud. I can put these services in there for those connectivities. I'll put a proxy server in that case. That's a kind of a forward-looking proxy. This is the normal implementation where the clients are on the inside and the resources are on the outside. However, there are times where I have telecommuting clients on the outside and they need to connect in. In this case, I would use a reverse proxy to get them strongly authenticated, strongly isolated, and then properly authorized after authentication. And finally, I can also, in this Enterprise Connect zone, use some sort of device recognition. Perhaps I authorize, let's say, some smartphones that live in this category of the bring your own device, the BYOD type of hardware. I have some thin client, even on a smartphone, that can submit queries up into the cloud. In order to secure this, because many bad guys will use these third-party devices, these many different client platforms, they'll use some of the tools and vulnerabilities in that platform to help break into your information systems. And so what I can do is control which of these BYOD devices are allowed into my cloud services, and then I can control using different types of filters. I can put device recognition and control in this Enterprise Connect zone as well. Many of the services that we would build into our corporate network infrastructure as a perimeter network to help me secure connectivity into the cloud. An extension of this deals with this federated identity management and single sign-on. The goal is, I don't care what platform of device you're running as a client, I can get you connected, I can get you authenticated, I can get you properly authorized, and I can control your utility of these cloud services, and also I can track what it is you're doing. And the notion is you can come in any door, any connectivity path, whether you're on the private LAN, whether you're on my Wi-Fi, whether you're connecting in over a VPN, across the internet, etc. I can still get you authenticated. And no matter what device you're using, what platform you're running from the client side, I can still communicate properly with that, secure the connection properly, get you strongly authenticated, etc. This is the notion behind federated identity management and single sign-on. The last two bullets on this list are managed intrusion detection systems and managed intrusion prevention systems. These fall in the category of security as a service. When I say security as a service, this generally implies that I'm outsourcing this. I'm paying somebody to do this for me. And that's what makes it that managed type of thing. Typically, I'll manage my own internal IDS and IPS, and we don't exactly call that a managed IDS or IPS. It's just part of how we operate it on our internal LAN. Typically, when I add that first word managed, it implies that I'm outsourcing this and I have some third party running these systems for me to help me secure my cloud environment, my connectivity to the cloud environment, and try to keep the bad guys from doing bad things on my connections and on my systems. These are some other tools that I might consider for use as I prepare to move to the cloud. Continuing with our lessons on security controls for cloud use, we're going to now focus on recognizing the environment that you're moving into. We have the private internal, we have a private external, we have community internal and external, and we have public internal and external. Always remember that anytime you're in a multi-tenant environment, then those are largely the community and the public deployments. You very often are in multi-tenant cloud implementations. In other words, there are other cloud customers that are operating on the same computer systems with their data files stored on the same hard drives as your data files. This presents an exposure. These other tenants might not have your best interest at heart. As a matter of fact, they might actually be renting this space so that they can get next to you so they can steal your valuable information assets. So we have to consider that this is a hostile environment and we have to defend ourselves in this environment. Now, you'll work largely with your cloud service provider, and you need to ensure that they are providing effective siloing. Again, siloing means isolation, that you truly are not accessible to one of these other tenants, that they can't reach in and monitor your processes or gain access to your files or your other data stores. So we need a very effective siloing or isolation between these tenants. These servers then will also be running not just your virtual machines, but these other tenants' virtual machines as well, simultaneously. And we need to ensure that those tenants' virtual machines don't gain access to your virtual machines through some sort of virtual networking. There might be vulnerabilities and exposure points that haven't been identified yet. So you need to be sure that your cloud service provider is effectively providing this isolation, that they're monitoring, that they're identifying breaches, that they're figuring out how the breach occurred, that they're implementing correct remediation type of strategies and technologies to further ensure this proper isolation. The virtualization security is, as we were just describing, a whole nother level of vulnerability. We're running these virtual machines within a common application called the hypervisor. Suppose we have on this host system some vulnerabilities on its operating system. Well, if somebody can break into the host computer system, the actual hardware itself and the operating system on this host system, they might be able to break in through the hypervisor into the virtual machines. Or they might be able to compromise the hypervisor directly, and that's how they gain access to the system underneath it and the virtual machines above it. So we have to be sure that the cloud service provider is effectively hardening these aspects of the cloud hardware and infrastructure. That's the host systems. Typically, this would be a cluster of servers that join together as nodes of a cluster, and they share different virtual machines. They share a hypervisor, and the virtual machines can migrate from one member of the cluster to another member of the cluster. And again, we have to be sure that that is all properly hardened and secured, monitored, enforced, and maintained, etc. We spoke in a prior lesson about virtual machine migration security. Now, a virtual machine will spawn and it lives in RAM. In this cluster array of multiple hardware host computers that are sharing a hypervisor as the clustered application, and the virtual machines are running on top of the hypervisor, those virtual machines might migrate from a very busy server 1 to a not so busy server 3, for example. And so what this cluster will do with this clustered application called the hypervisor, the system will migrate the virtual machine from the very busy server 1 over to a less busy server 3 to load balance. And this is great for performance. It's a good thing that it does this, and it does it very efficiently. From the user's perspective, it's almost unnoticeable, and it's typically very reliable. So it's a very good process. other than when the machine is migrated off of server 1 over to server 3 in RAM, we have to be sure that the memory space that that virtual machine was occupying is first completely overwritten with garbage bits and then returned back to the operating system. Because if we don't first overwrite the memory location and then return the memory location, something called remnants might exist in RAM. The remnants are the virtual machine software, the application that was running inside the virtual machine, and the data that the application was running on inside that virtual machine. So all this might still exist in RAM on that true physical server 1 that we described. We have to be sure that that memory is overwritten first and then returned back to the operating system. We overwrite with garbage bits, and then we return the garbage bits and the memory location that all this garbage is stored in. We return that back to the operating system. That's virtual machine migration security. And then we also have to be concerned about these multiple VMs that are running on this common clustered application called the hypervisor. We have to be very certain that they are properly and effectively siloed, isolated from one another, unless, of course, I need them to see one another. So very often, I might need to spawn 20 virtual machines as platform as a service, for example, and then I need those 20 machines to be able to communicate across the virtual network with one another. Now, that's a fine thing, but that network connectivity should be secured, and that's fairly routine. But another area of security relative to these VMs is, what if, because of my multi-tenant situation, one of my competitors' virtual machine is running on the same piece of hardware as mine? And what if he can use that virtual network to connect his virtual machine to my virtual machine so that he can steal my data? So once again, we have to talk carefully and closely with the cloud service provider to ensure that they are actually doing all the right stuff relative to this virtualization security. Remember, this is a whole nother layer of security and vulnerability that we never really dealt with before, and now it's becoming a standard operating platform that we have to figure out, are we really secure there? Spend time talking to your cloud service provider. Be sure you understand how they provide these different levels of security relative to their virtualization processes. Now, another area of vulnerability, and perhaps even one of the biggest areas of vulnerability of all systems, is poorly written applications. Applications are typically written with about one line of faulty code that would allow for an exploit, a complete compromise of the application and the system, and perhaps even the networking environment that that application is running in. One line out of every 100 lines of code has a bug in it that allows for this compromise. So there is this need for secure coding. The software developers must be writing their code in a secure manner. They must be implementing secure coding. That's step one. After they finish their coding, and to the best of their abilities, the coding is secure to avoid buffer overflows and backdoors and other vulnerabilities, there should be a code review. This is some second party. He has to be a specially trained developer who is highly skilled in secure coding so that he can identify any vulnerabilities that the first developer introduced in his code. This second reviewer, he's trying to make sure it's not vulnerable. We have to target now just vulnerabilities and eliminate as many as we can identify. And then finally, after we feel that we've got the code securely written, then we target the application externally from a hacker's perspective and see if I can identify additional vulnerabilities. So now let's start to throw exploits at it. I'll try to figure out where it has weaknesses that I might be able to write exploit code and target that code. This is just application security, but because it's in the cloud, it makes it more important because now when the bad guy breaks into this application, he gets whatever's in your cloud, potentially. And so we have to be very careful about the secure coding of applications that your developers are writing for the cloud. To support that is an Open Web Application Security Project, OWASP. Now, this is a great movement relative to web application design and how to securely code and some of the well-known vulnerabilities that you can avoid adding into your code. If you read this book and this collection of pages, you'll learn how to not write sloppy and insecure code. So this OWASP project is a collection of resources for software developers how to write secure code. Now here is the OWASP homepage. A couple of important things we want to look at are some cheat sheets. This is for software developers. If you're doing web-based applications, this is largely about, and you have concerns about cross-site scripting attacks, here's how you prevent those cross-site scripting attacks. Cryptographic storage, how to encrypt stuff for storage in your web-based application. If you're using HTML5, if you're running Ruby on Rails, and all these other cheat sheets, known vulnerabilities, known mistakes that many application developers bump into and have implemented in the past, here's your guide on how to not do these things. The top 10 list. Right here is our definition. This is a list of the 10 most critical web application security risks. In other words, when you write your web-based application, these are the 10 most common mistakes that cause breaches or vulnerabilities. Another area of interest in this OWASP website is the development guide. This is basically how to write secure code. They're focusing on secure software engineering, the new top-level objective for this section. Once we write secure code, of course we have to test the code properly to identify any vulnerabilities. So parallel to this is also a testing guide for your web-based applications. So let's go back to the home page. We've got the application security tutorial series. Here again is for the web developers. Here's a series of videos that are easy to watch. While it's deep and heavy technical stuff, they try to make it simple and very straightforward. A collection of videos for training to take these complex topics and present them in an easy to understand way. So again, secure web-based application. This is the Open Web Application Security Project, or OWASP. Check this website out if you are developing web-based applications, and if you're simply managing this, be sure that your software development team is as much in compliance with these concepts and notions as possible. Picking up where we left off on our series on preparing for cloud use, we're looking at security controls. So let's look at security as a service. We have the opportunity to purchase security tools that we can implement, like an IT staff that has the time and the skill set to properly deploy and administer these security tools over time. So very often there's a high cost of doing it all yourself versus a lower cost if we outsource this cloud service security. They call this security as a service, SECaaS. The internal cloud security would be more like capital expenses. We're going to have to buy all these apps and pay for it all ourselves. It's more an operational expense if we outsource it. We pay a monthly fee, and it's a smaller fee, and we pay over time. So there are pros and cons to both, but consider which of these types of security controls you'll use. Now, very often you'll use a combination of the two. Some you'll do internally, where you have manpower and skill sets, and perhaps you already have some of the tools in place. And others are too expensive or too complex or too demanding from an administrative standpoint, and you have to outsource them. So you'll probably wind up with a combination of the two. We've already talked about identity and access management. This is the AAA services, the authentication, authorization, and accountability, and federated identity management, single sign-on. So we've already considered this. Ways to verify the claim of identity by users, and then how do we control those users now that we know who they are? How do we implement the proper privilege levels and restrictions on those users so they can get access to the stuff they need and they don't get any access to the stuff they don't need? We have very common web application needs and email needs. So I need to consider these web servers and the applications that the web servers run, and the email systems, and then the interaction. That's the sending of email, the receiving of email, and the clients accessing their email mailboxes. I'll need to consider all the security concerns related to those specific applications that are common on just about every enterprise. And very often, these are some of the things that we'll put up into the cloud, so we want to be sure that we have these properly secured. We need to look at our network security, overall, the connectivity. Remember, we talked about an enterprise connect zone, and we also talked about how we might deploy some sort of data loss prevention network monitoring system at these connection points from our private network that we know and love and trust, and those connection points outbound to the public internet that we consider it hostile, and we know that's where the bad guys live, and there's many, many bad guys out there that want to steal our information. We put these DLP systems at these egress points and try and control the flow of information up to the cloud. That's what the DLP systems will do. Again, we'll use our data classification process, and then we will properly label somewhere in the file, whether it's in a header or a footer or a watermark, or perhaps it's in the metadata for a file. We'll put some keywords that our DLP systems can filter on, and it can identify, hey, this file was outbound to the cloud. It's not allowed to go out to the cloud. So it'll not only stop it, but it'll also alert someone that this information was flowing and this sender tried to send it out. So now we go talk to that user to figure out what's going on and remediate the problem. We'll consider the proper types of encryption. We'll have encryption for data in storage. We'll have encryption for data in transit. So those are two types of crypto that we'll need to implement. And remember, with encryption, we also need a secure key escrow, some repository of all the decryption keys for all the information that we've got encrypted up on the cloud. We'll also need to look at host-based and network-based IDS and IPS, and very often we might pay someone to do this. This again would be outsourcing these specific services so that we can detect attacks inbound on our cloud and perhaps even inbound in our internal network. And we might actually have these systems, once they detect, they respond and prevent the violation, and that would be the IPS. So host-based systems will monitor processes and activities on a single box, and a network-based IDS IPS will monitor packets flowing across the network. We'll consider using both of these tools as we migrate towards the cloud and expose ourselves to more risk and hostility. Now, this next bullet down, security information and event management systems. They've been around for a handful of years, maybe 10 years or so. However, they are evolving to a state where they are better and better and better all the time. They actually use mechanisms that fall in the category of artificial intelligence to correlate all the logs and run them through this SIM system. This SIM system will actually parse all of these logs. These logs are typically ASCII characters, ABCs and 1, 2, 3s. These SIM systems can identify what type of device sent that type of log event and will be able to read that record, identify source and destination, event time, the nature of the event, whether it was some sort of potentially risky event, whether it was a breach type of event, some reconfiguration, etc., etc. And using its artificial algorithms and its correlation algorithms, it can identify low and slow attacks. It can identify widespread attacks and identify all sorts of anomalies, misconfigurations, and other peculiarities that we might want to pay attention to. The high-powered environments will run these SIM systems. These are one of your best tools. Very complex, requires typically a dedicated staff. It's not for the startup company. This is more for a very mature company that's got the financial resources and the skill sets in-house to run these systems. And then finally, we want to look at an overall security assessment for the enterprise. This would be a complete physical inspection, an inspection of your policies and procedures, an inspection of your technologies, the implementation, the deployment. Are they located in the right locations? Are they effective? Are they actually being utilized? Or are users simply bypassing them because they slow them down, or there's some problem with it that it never did work right, etc.? If we have this vision from a security assessment, we can identify where the risks and the threats are, and then we might be able to implement appropriate countermeasures that will effectively control those vulnerabilities. Continuing on with our look at security controls for cloud use, here we're kind of taking a high-level summary review of what we're trying to accomplish for security as we approach using the cloud. We'll be implementing administrative controls, physical controls, and technical controls. As you might recall, administrative controls are policies and procedures, documentation that we have in place that say this is how you have to behave. And in this case especially and specifically relative to the use of these cloud services and the way you send data and access data and the way you deploy applications and other platforms, etc. in the cloud. These are the policies and the rules on how we're going to do it. Then we have to have physical control for our in-house environment. If we don't have proper physical controls for our internal environment, the break-in and the breach will be in our location and not at the cloud. We also have to be concerned about the physical environment at the cloud location as well. In most cases, these are professional cloud service providers. They understand their liability is high if there's some sort of physical breach where somebody breaks in and steals a series of servers or a SAN, for example, storage area network with large amounts of data store. So they very often have very good physical security. However, you, doing your due diligence, should verify what their physical security posture is and how well they truly protect those physical assets. And then finally, we have the technical controls. These are the software controls, the DLP filters that catch based on code words, the SIM systems, the encryption, the permissions, the AAA services, authentication, authorization, and accountability features that provide our logging and our proper authentication for the users. Those are all your technical controls. We need to protect our data at rest. That's in storage when it's sitting on a hard drive or in memory. And then we also have to protect it while it's in transit, while it's going from our LAN to the cloud, from the cloud down to the LAN, and then between different virtual machines in the cloud. And then finally, we have to protect our data as it's being processed. Now, that's when it's in RAM and actually being processed through a CPU and then spit back out into RAM. We need to be very careful about the bad guys perhaps breaking into these active processes and perhaps stealing our data. And as I already said, we need to protect it in transit on the corporate LAN, like flowing between systems on our LAN, between the LAN and the cloud, and that's from our corporate enterprise network up to the cloud. And then finally, as it flows from one virtual machine to another within the cloud. One rule might be that we encrypt all data before we send it up to the cloud. We need to consider whether that's the proper thing to do. However, we want to be sure that we encrypt it after we get a look at it with our DLP systems. Because if you encrypt it at the client machine that's actually sending the data out to the cloud, then we have the problem that the DLP systems can't filter. It can't parse the file and identify those keywords that it is basing its filters on. So we have to encrypt the data after it gets filtered by the DLP systems and then before it goes to the public network. The way we will encrypt is by using either a virtual private network, the secure sockets layer, but secure sockets layer, SSL, has several vulnerable versions prior to the latest. The latest version of SSL is 3.1, and SSL version 3.1 equals TLS, Transport Layer Security, the new standard on where we all should be running when it comes to a secure channel to allow information to flow from point A to point B. So either a VPN, a high version of SSL, ideally 3.1, or the new version of TLS is version 1.2. So those would be your latest and greatest encrypted channels. Now, we also need to be sure that we have appropriate logging and monitoring going on. Logging is the recording of events, and that's a lovely thing, but if nobody's looking at it, it doesn't do you any good until after the breach has occurred. And that's what logging is historically used for. But today we're a lot more proactive, and we are actually going to be performing as close to real-time monitoring of those logs as possible. So that's our routine logging and monitoring. Now we'll also run an audit trail. The difference between monitoring and auditing is monitoring is that constant ongoing looking at what's happening. It's that steady state, just keeping an eye on things. But auditing is a little more specific, a little more targeted, because we want to keep a closer eye on our highly privileged users. And these would be users that have a great deal of access, perhaps administrative control where they could reconfigure things and bypass security controls, or perhaps a highly privileged user that has access to the very sensitive data, the crown jewels, for example. And so these would be two examples of people that we would probably want to audit. We want a closer look at these guys and what they're doing because of the exposure we have based on their level of privileges. All the monitoring and auditing are about detection. If we're not looking at this stuff, if we're not catching what's going on, we're wasting our time. We're wasting all our efforts for security. So we've got all these tools. We're spitting out all these logs. I've got auditing turned on. I'm focused on the right guys that have the high level of privilege. But if we're not noticing when that alarm bell rings and responding when that alarm bell rings, we're wasting our effort. We need to be able to identify when the bad thing happens and stop it as quickly as possible to minimize our losses. So the logging, the monitoring, and the auditing, those are the precursors to the real goal, the detection and the response. In order to ensure that we have effectively deployed the right tools, we will maintain metrics over time. We have to be doing this, otherwise we might be negligent. So in order for us to know that we're doing the right things, we actually have to be monitoring and auditing so that we can detect and respond. And we have to keep track of this over time to prove this is the way we behave. We're not negligent. And this way, if a mistake is made, it was an accident. It wasn't negligence. It's not an ongoing thing. So we have to be able to prove that we're doing the right things all the time. And then finally, because we've gotten all these controls, all these rules in place, all these technologies in place, we need to be sure that all of our end users understand everything they're supposed to do. What is their responsibility in this collection of security for our internal use and the cloud use of our information assets? So we have to teach them this is how you are expected to behave. And we have to do it at every new hire before they touch any information assets. We have to do it on an annual basis as an ongoing reminder of these are the rules, and actually each year you'll update your training materials so that you've got the new technologies and new policies and things like that. Then they'll need supplemental security awareness training. In addition to the basic training that everybody gets, 25% of our employees need additional and specialized security awareness training on how to use the multi-factor authentication token, for example, how to sign into the VPN server, things along these lines. So they need this supplemental training that goes along with their more highly privileged access requirements. And then if somebody violates policies, we might need to implement remedial security awareness training, even as a minor punishment. But obviously, if they violated the policy, it's because they forgot what they were taught in the last training. You have to retrain them again. So those are the three major categories. We do it annually, supplemental, and remedial as necessary. Picking up where we left off on preparing for cloud use, one of the stages is to really understand who your cloud service provider is. What you need to do is perform your due diligence. Make sure that the cloud service provider can actually do the things that he promises. Now, not only do you have to know that your cloud service provider is able to perform these things, we also need to verify that any companies that provide the cloud service provider services, they also have to be able to satisfy these objectives. If you put your data in the cloud service provider is responsible for that. But what about the providers that provide him services? They also need to be able to support all the claims, all the guarantees, all the promises that the cloud service provider offers. So you need to not just perform due diligence on the cloud service provider, but the providers of service to the cloud service provider. So all that said, what are the things we need to understand about this cloud service provider and the providers to him? First, are they able to satisfy all of our specific objectives and requirements that we have plowed through and we've documented in our agreement? We're going to have this agreement in place. It's going to list different details on very specific targets and objectives and requirements that we have relative to protecting the confidentiality, integrity, and availability of our valuable information services. Another detail that you want to verify that the cloud service provider can perform are some of the extra software services that you might need, such as the Security Assertion Markup Language, SAML. This is for web-based applications for single sign-on. So you authenticate once in the cloud, if you will, through a web authentication service, and that web authentication service will be using SAML to essentially give you an access token that now is usable at other web-based applications in this same arena of applications. So that's what SAML does. OpenID is a similar technology, Again, it's designed for single sign-ons. Your users can sign on once to the cloud services and be identified and authenticated, and that authentication then carries forward to an array of applications that they may gain access to in the cloud. And then finally, to support that authentication service, we might need something like X.500, which is directory services. This is a function or a service that you can either build yourself for your access to the cloud, or you might actually use a directory service provided by your cloud service provider. For example, Microsoft's Azure comes with the possibility of you adding an Active Directory component, which is X.500 compliant directory services, to your cloud services agreement, the services that they're providing to you. If you have needs for these authentication and single sign-on technologies, be sure that the CSP can provide these services. Does the cloud service provider claim any special compliance certifications? And if they do, how often are they audited? How did the audit come out? Are they fully accredited or certified as being in compliance? If they weren't certified, what were the gaps that were identified that make them not be in compliance? And if there were gaps in their compliance, did they remediate? How did they remediate? Is the problem solved? And are they aggressively pursuing the solution? These are some areas that you want to pay attention to. Now, some examples of some of the certifications that might be important to you are the SaaS 70. SaaS is Statement on Auditing Standards, and this is the statement number 70, and the latest version is the Type 2, a very aggressive, full-blown audit of the operations that gets this SaaS 70 certification. Another certification that might be critical is the ISO 27000 series, which is Information Security Management. It's a whole series. If you need to perform a risk management, here's how you do it. If you need to secure your servers, here's how you do it. So this 27000 series addresses these information security management objectives. There's a certification for that as well. Now there's COBIT, that's Control Objectives for IT and related assets. The Sherwood Applied Business Security Architecture, that is another security certification. So COBIT and SABSA are similar, maybe mildly competing approaches to solving the same problem. How do you secure your information assets? And then finally, if any of your data is subject to any of the laws or regulations, such as Sarbanes-Oxley, the Gramm-Leach-Bliley Act, the Healthcare Information Portability and Accountability Act, and the Payment Card Industry Data Security Standard. If you are subject to any of these specialized concerns, or you require ISO 27000 series certification, you need to actually verify that your cloud service provider actually has that certification. Another angle of due diligence on the cloud service provider is a review of their history. How have you been doing? Are you good at this, or are you just fraught with regular breaches and security incidents? And then, after those, what were the remedial actions that the cloud service provider took to help ensure that these types of violations and breaches don't ever occur again? If they have high-end CISO type executives or IT type executives that are willing to put their name on the line and their company, someone you might actually reach out to and verify, did you really have a great experience with this cloud service provider? You want to verify these references. So pursue references and then talk to those people. And then finally, if possible, go do an on-site inspection. Go visit those facilities. Get a tour. Have the guy explain all the physical security controls and the policies that they have in place and the way they train their people and the technologies that they employ and things along these lines. You need to step out of the box and find another way to verify that all these claims are actually true. In this section, we're going to look at how to develop the Cloud Services Agreement. The Cloud Services Agreement will contain a collection of different types of topics. Everything from we have to have our ducks in a row internally, that's our framework for governance. In our policies, we'll have statements that declare we will manage our third-party service providers as rigidly as we manage our internal employees, and they need to be bound by the same requirements and objectives. What are the services we're trying to get from the cloud service provider? They need to provide commitments and guarantees, and there needs to be penalties for violation of these guarantees. We need to also ensure that the cloud service provider is prudently managing their service providers, the other companies that provide them services. So this is the CSP's service providers. We need to ensure that the cloud service provider is prudently managing their environment, because if they're not prudently managing their environment, they aren't protecting us properly. They can't make their guarantees, and we're either going to suffer a breach or some other failure that's going to cost us money. And if they aren't prudently managed, they'll go out of business and there's nobody left to claim any penalties from. So we need to ensure that they're going to stay in business forever. And that's where the business continuity planning and disaster recovery planning come into play. This helps to ensure that that prudently managed business will be here over time. And I don't have to worry about them evaporating on me and all of a sudden all my data and all my intellectual property and the infrastructure that I've relied upon suddenly goes away and I don't get access to it anymore. So I need to be sure they're around. I'm counting on these guys heavily. I need to know they're going to stay around, and that's what those things will help me with. We also need to ensure that we have access to monitor the cloud service provider, their administrative people, and the activities that those people take and the services that they're providing. I'm going to get a bill each month. I want to be able to verify that I'm actually getting the services and consuming the services that I'm being charged for. So we need to be able to monitor the CSP. Also, part of this agreement needs to include that any breach or incident has to be quickly detected and then quickly responded to. In addition, we need notification of this if it affects our data, because we might need to notify others. So if my data has gotten breached on your systems, you better tell me promptly. And I need to be part of the remediation process. So that's what this bullet is about, that the subscriber needs notification and participation in the response and remediation processes if there is any sort of breach. And then finally, we're not here to provide any sort of special legal advice. These are some of the topics that your agreement with the cloud service provider need to include. Any agreements, any contractual obligations that you enter into with any other entity should all be reviewed by your company's legal department, and only after they approve it should you then move forward with that agreement. However, these are some of the topics that you would want to build into that agreement, again, based on your special situations, your special needs, and your particular security posture for your enterprise. Now, first, we're going to need an internal framework of governance that includes statements that define how we as an enterprise will manage our third-party service providers. And those third-party service providers include cloud service providers. So that has to be part of our corporate culture. It has to be built into our framework of governance. Now, in that collection of documents, we should also include specifics on how we're going to require those third parties operate. What specific objectives do we have for them to be in compliance with what we need? So this will all be part of our internal policy structure. And then we need to identify in this agreement the specific services that we need. We need to identify who owns the stuff, that they won't share our stuff. We'll always be able to get access to our stuff, that they guarantee they will comply with all of our requirements and all the applicable laws and regulations, and that if there is any violation or incident or breach, that they'll notify us, and there will be penalties for these violations of these guarantees. Relative to the breach and incident detection, that they need to notify us, and we need to participate in the response and remediation. They need to prudently manage themselves, and there needs to be prudent monitoring and auditing from us, monitoring them so that we can maintain metrics and that they will provide us ongoing standard reports on our consumption. So these are, again, some of the core components of the agreement. The first area that we'll want to talk about is what services are we looking for from the cloud service provider. We'll talk about the services, the service levels, the availability, any specifically required redundancy. Now, they'll be highly redundant. That's one of the things they typically do very well. However, we may have special requirements and objectives that we may need to build into our contract with them. And then special details on recoverability of that information or the services that might have gone offline. Are we looking for software as a service, platform as a service, infrastructure as a service, security as a service, federated identity management, or any of the other services that we've described? how much processing power, data storage, bandwidth on the connectivity, how much of that will we require? And again, always anticipate you're going to underestimate, and you should pad this a fair amount. You need to also anticipate growth. If you need 10 gigabits today, you'll probably need 20 gigabits by 2 months from now or 3 months from now. So anticipate this growth. We also have to specify who's going to be performing the hardware and the software maintenance. Hardware maintenance would be, noticing when hardware is starting to fail, get it replaced, upgrading the hardware at the appropriate times, and then software maintenance deals with updates and patching. As far as uptime, companies will typically offer something like 5 nines uptime. That's 99.999% uptime. And that boils down to they can only be offline 5 minutes and 15 seconds a year. Anything more than that, and they're in violation of this particular required service level. We may also require specialized hardware redundancy, data redundancy. I need it in 16 different locations so that if the East Coast goes down, the West Coast still has access to the data, things along these lines. You'll need redundancy on connectivity. Well, if your ISP fails for the day, you need a second ISP providing you internet connectivity that isn't dependent on that first ISP. You might have special requirements for power redundancy and co-location. Now, these very often are satisfied in your due diligence, your interrogation of the cloud service provider prior to moving towards the agreement here. But you want to be sure it's documented, that they will see to it that this is maintained over the life of your relationship. When it comes to recovery of data, we have a recovery point objective. That is, how old is our data? When was the last backup, if you will? When is the last copy that, if this copy goes away, how old is the copy you're going to replace it with? That's the recovery point objective, and it defines how much data you might be able to lose. In other words, if you're doing a backup once a day, you could lose 24 hours worth of data. Is that acceptable? You need to figure that out and define this recovery point objective. Where is this recovery data stored? How is it protected? Et cetera, et cetera. And then finally, if we do have to recover data, how quickly can you get it back online? That's the recovery time objective. Let's say the data might be 4 hours old and it takes them 2 hours to get it back online. That says you have lost 4 hours of data and 2 hours of new business. That's an awful lot of business you've lost track of. Is that acceptable? If not, you need to squeeze the RPO and the RTO smaller and smaller and smaller so that you might lose 4 transactions over the last 9 seconds, and that's it. So we need to look at these recovery components. And then finally, you might have specific requirements as to where is the actual data physically stored. You might decide that this is so sensitive and it's only ever needed in the Northeast United States, that it's only stored on their data servers in their data centers in the Northeast, and it's not distributed to their other data centers across the country or around the globe. And you might just require that we always have it available here, but don't put it anywhere else. Or, yes, I also want it someplace else, but always I need 4 copies here, just in case 1 copy goes south. Continuing with our lessons on how to develop the cloud services agreement, the next topic we're going to look at is the confidentiality and non-disclosure clause, the ownership clause, and the guaranteed access clause. So let's look at these a little more closely. First, we need to have the cloud service provider agree that they will protect and not share our data or other intellectual property with anyone else. And they are obligated to protect it to the best of their ability and following the standards that we're going to define in other sections of the agreement. We also need to include the notion of penalties for violation or inappropriate disclosure of this intellectual property or other data. We also need to ensure that the cloud service provider agrees that the client will retain full ownership of all of its data and intellectual property, that it transmits to or from the cloud, stores in the cloud, or processes within the cloud, that the cloud service provider nor anyone else ever has any rights of ownership no matter what. Even if, for example, we don't pay our bill, they don't own our data. They may not claim our data as their asset. And finally, that the cloud service provider guarantees us access to our data and intellectual property, and it will not hold any data or intellectual property hostage. Now, that's a critical concern. This is one of the fears that most users of cloud services has, is that if they get into some disagreement with the cloud service provider over time, any sort of dispute or squabble that causes a little disharmony in the relationship, the cloud service must guarantee that no matter what, even if we owe them money, they don't hold our data or intellectual property hostage, that they always provide that access as long as the agreement is in force. And the agreement will also state things like, if we're late, here's a penalty, but you can't hold our data hostage. We need the cloud service provider to guarantee that they will abide by all applicable laws and regulations, including but not limited to the big ones that I might have listed here, and then there are others. But if you are subject to any specific additional laws and regulations, you might want to say include that in this not limited to list. And that might include state and international laws, e-discovery and forensic analysis laws, like if there's a subpoena or a warrant for information. And then you might also have specific contractual obligations with perhaps some of your clients whose information you have in the cloud. And so you want to be sure that all these get tucked into this cloud services agreement, that the CSP will comply with all these rules and laws and regulations. We also want a general statement that their security will equal or exceed this statement of standard. And typically, these requirements are the same that we have internally. So if you kind of mirror your internal security requirements and objectives and place that into the cloud services agreement as requirements imposed upon them that they agree to, then you'll know that they must at least equal. And of course, if they want to exceed that from a security standpoint, that's even better. But they must at least do what we do to protect our information assets. We also need the cloud service provider to manage all of their service providers with this same collection of terms and objectives and requirements, completely abiding by all applicable laws and regulations and additional contractual obligations, additional state laws that might apply to us or international laws that might apply to us. All that has to go downstream to the service providers of the cloud service provider. And if any of these laws or agreements are broken, then the cloud service provider must tell on himself. He has to notify us. And in notifying us, he recognizes he is obligated to penalties for violations. And those penalties also need to be identified within the contract. You can't just say, you agree you'll do this, and they say yes, and you don't say what the penalty is for violation. There must be a declaration of penalties for violations. Let your lawyers do the detailed wording of how that plays out, because they're the ones that have to defend it in court. We also need them to guarantee that they are providing the proper data protection to protect the confidentiality, integrity, and availability of our valuable information assets using the appropriate types of controls, administrative, physical, and technical. These controls are designed to prevent breaches, deter, delay, detect, assess, respond, recover, and compensate. The nature of the controls that are implemented should do these things, that the cloud service provider will provide appropriately strong authentication, authorization, and auditing or accountability services. Those are the AAA services that my users will utilize in order to be prudently and securely privileged for access to the valuable information assets and the services that we're requesting in the cloud. That the cloud service provider guarantees they'll provide multiple layers of security. There needs to be many, many layers of security controls put into place, again, to protect the C, the I, and the A, and those controls will be administrative, technical, and physical in nature. Management must be monitoring to detect and then must enforce the policies and procedures and other controls properly. In addition, the CSP must also guarantee us that their users are also well trained to detect and enforce potential breaches within the cloud environment, the physical environment, and the computing environment. Continuing with our lesson on developing the cloud services agreement, we're looking at compliance guarantees, and we're taking a closer look at some of the specific types of guarantees that the cloud service provider might need to provide you to satisfy your security objectives. You're going to want to include in your agreement specific data protection controls for your data at rest, and this would include types of encrypted volumes. You might have file encryption technologies, and we need to ensure that if you're in a multi-tenant environment, that the cloud service provider is effectively siloing you or isolating you from any of the other tenants, that there is no way that they can come through the hypervisor or perhaps build a virtual networking component between their virtual machines and your virtual machines that might expose your valuable information assets. So that's data at rest and the technologies you might use to protect the data at rest. Another concern is data in transit, and this is data as it flows across the wires or perhaps between virtual machines on virtual wires. And in these cases, we use typically either a VPN, that's a virtual private network, that typically is from one trusted endpoint to another known and trusted endpoint. That's where VPNs come into play. Or if we have an anonymous side, and very often this may not be the case, but it's something you'll want to consider, especially since you're using web-based applications very often in the cloud. You might want to establish a secure sockets layer or the new and improved transport layer security encrypted channel. So these VPN and TLS technologies are to protect data in transit as it flows across true physical wires or even virtual connections, virtual wires between virtual machines. And we want to protect this information as it flows into, out of, and within the cloud. Finally, we need to protect the data while it's being processed, and this is where the cloud service provider has to assure you, has to guarantee you that he is providing strong security for the host systems. These would be the cluster servers, the actual computers that are assembled together and grouped into what we call a cluster, and they become nodes of a cluster that share a common clustered application. In this case, the clustered application is the hypervisor. And on top of that hypervisor platform, you will execute your virtual machines where your applications for software as a service, your platforms for platform as a service, and even it establishes the infrastructure for infrastructure as a service, that the cloud service provider is properly and prudently securing these host systems. On the strong end of this, you may actually even require that the cloud service provider provides you dedicated host systems. Now, this would be where you would have something akin to a private cloud, but it's external, where you are leasing full dedicated systems, not shared with anybody else. You have these 4 servers in their rack in these 23 locations. This is where your private cloud operates on their servers, in their rack rooms, in their data centers. And then, of course, they'll apply all the redundancy and fault tolerance and synchronization and duplication, things along these lines. The strong end of this is you pay for dedicated host systems that are not shared with anybody else, and you can reduce your attack surface by doing this. And then finally, we need to be sure that the cloud service provider is securely erasing the residual footprint, the storage locations where the virtual machines lived in RAM prior to being migrated to another member of the cloud. And again, this is done for typically performance and load balancing. So we need to protect data at rest, data in transit, and data while it's being processed. We also need to provide data fault tolerance and data redundancy. Now, this implies that we're going to be performing a backup. Backups are performed on a schedule. They're a batch job. And one of the issues with these backups and the scheduling of these backups for data redundancy is you only back up, perhaps it's every 24 hours. Well, what that says is if you only do backups every 24 hours, you could lose up to 24 hours worth of data. Is that acceptable? And if it is, that's great. You have a very comfortable RPO, recovery point objective. It says your data isn't all that critical. 1 day's worth of data is not that significant to you that you can afford to lose those transactions. So when it comes to these backups, you need to be sure that your backup is firing off as often as you need it to satisfy this recovery point objective. Suppose we said the maximum amount of data I want to lose is 2 hours. This means you have to perform a backup every 2 hours. That's your recovery point objective. The second part of this is the recovery time objective, the RTO. So that says, looking forward from the loss event, when the bad thing happens and your data goes away, how long will it take you to restore that data backup and move forward? In other words, start taking transactions once again, because that too is considered downtime where you are losing transactions. So you need to recover this data online in a certain amount of time. That's your recovery time objective. So between these two, looking backward, how old is the data, RPO, and looking forward, the recovery time objective, these two will identify how much actual data you've lost and downtime you experienced due to this single loss event. Now, the two ways we perform backups are typically through either tape vaulting, which means we're backing up to tape. It's been done historically because it's inexpensive. Tape backups are one of the least reliable forms of data redundancy. I can't tell you how many times I've gone to a tape backup and for any number of reasons, I can't restore or mount the data. I prefer to do what we call electronic vaulting, which is backing up, only my destination isn't a tape drive. My destination is some large hard drive. So backing up to hard drive is another type of backup. That's called electronic vaulting. And in my mind, that is substantially more reliable than tape vaulting. Those are your primary types of backups. And then one other critical concern about backups is, while you might be performing these backups every 4 hours on schedule and everything's looking great, keeping the most current stuff available and then pushing the older stuff further and further out to optimize your storage space, if you aren't testing them on a regular basis, and then mounting that data to actually ensure that you can submit new transactions to the database and send queries to the database and get legitimate results back. If you aren't practice restoring and mounting the data set to test it and validate that your backups are effective, you're probably wasting your time. You have to be performing these practice restores and mounting of the data to validate your backups are accurate. All this is part of your data fault tolerance and redundancy. In this lesson, we're going to continue our look at different types of data fault tolerance and redundancy that we want to build into our cloud services agreements for our cloud services provider to be sure these things are going to be provided on a consistent basis. We're going to look at different types of redundant arrays of independent disks. These are called RAID arrays, and they are a series of hard disk drives aggregated together, and they perform various services or various increased capabilities. Like, for example, a RAID level 0 is disk striping. Striping is really all about performance. Striping is your best performing collection of disks in a RAID array. That's a RAID level 0. Now, RAID level 1 is disk mirroring. This is where we take two disks of approximately the same size and we mirror them. In other words, we tell the file system, whenever you write to this disk number 1 over here, also write that same data to this disk number 2. At the time you're finished, both disks hold exactly the same data. That's called disk mirroring. And this is a standard for fault tolerance and data redundancy. And then we also have some other real-time features such as transaction journaling. Now, this is where we've got a transaction database that we're living upon, and we've got an application that's accessing this database. And every time we submit a transaction to this database, I journal a copy. That means I make a second copy of it and I send it over to a second copy of the database. Once again, the goal is to keep these two copies of the database exactly the same in real time. So every time I commit a transaction to database 1, I send a second copy called the journal copy over to the database number 2. And now these two databases are kept in sync in real time. And if the first one fails, I can simply mount the second one. And if the second one fails, then because I wasn't living on it, I wasn't actually committing transactions to it directly, I simply repair it, and then I resync it with database number 1 and fire off the real-time journaling once again. Disk shadowing is another form of this real-time duplication for data redundancy. And this is where not only do I have redundant disk drives that are holding the redundant data, those disk drives actually live in two separate computers. In other words, when I commit a file or a transaction to the database on server 1, I journal or shadow that transaction or file to the other server, server 2. that might be in the same data center or actually might be across the country in a co-located manner. Now I have 2 copies in real time. The disks are redundant. The computers, the servers that support those disks are redundant, and I might even put them in separate physical locations just in case the power fails in this data center. I still have the other copy that I can mount within a few seconds and go approximately real time back to live data without losing any transactions. So these are some of your better solutions. These are real-time solutions. The warning is, if something starts corrupting your database or your mirror, if it's a virus or something that's affecting it, it's going to affect both of them simultaneously. Both will be gone. So this means not only do you have to perform mirroring or disk shadowing, for example, for the real-time synchronization and backup, you also need a periodic backup, the standard backup that we were talking about that's a batch job that might be 2 hours old or 24 hours old that you can roll back to before the corruption or the virus infection took place. So you need to do these in parallel. You need to be performing real-time synchronization in many cases. And parallel to that, you also need to be doing the batch jobs, the backups that we described in an earlier lesson. Now, another way that we have redundancy and fault tolerance for our data is if we put our data in multiple physical locations. In other words, I have a copy of the database here in Oshkosh, and I also have a second copy of this same database over in Schenectady. That way, if a fire strikes here or an earthquake strikes and destroys this data center, I'm still alive on the other data center's copy of the data. So co-location of your data is an excellent solution. We may need to specify guaranteed locations of data and also guaranteed locations where my data will never be placed. In other words, keep it here, don't ever put it there. And so we might have these special concerns that we want to include in the cloud services agreement. Then we require our cloud service provider to comply and guarantee that this will never happen. And then finally, we want to be sure that our data, as it gets transferred from Oshkosh to Schenectady, doesn't get corrupted, that it remains portable. And we also need it to be interoperable. Now, this deals with data normalization and perhaps sanitization. Data normalization makes the data easily exchanged from one application to another application. The application can go to just about any source of data, and the formatting of the data will not cause a problem with the application's ability to utilize that information. So we need the data to be moved around easily and quickly without any sort of destruction or hindrance to our using the data for good cause. And also, that information must be formatted in such a standardized way that I can use it in just about any application, and the information can still be inputted correctly and be processed correctly. No matter what the formatting is, it'll be automatically somehow reformatted into something that the application can tolerate. Continuing with our lessons in developing the cloud services agreement, we're building the list of details that we expect the cloud services provider to guarantee us, the things that we're saying we need you to give us. In earlier lessons, we were talking about data redundancy and fault tolerance. In this lesson, we're going to look at system fault tolerance and redundancy. So how would we get system fault tolerance and redundancy? The easiest way that we can get our servers to be fault tolerant and redundant is to build what we call a cluster array. And a cluster array is several servers that are sort of joined together as members of a cluster. They then share a clustered application. Now that clustered application in our case is probably going to be a hypervisor. So we'll run a hypervisor on all three, and then we point those 3 different instances of this hypervisor to recognize there are 2 other members of this cluster, and you guys all need to share information. As you can see in this diagram, there is a heartbeat network above these servers in the diagram, and that's a private network that these 3 systems will use to communicate amongst themselves. First, to notify the other members that they are alive and functioning and all is well. And second, they will also commute the state of every connection that they are currently supporting. This would include all the details of that session, so that if any one of the 3 in this diagram servers were to fail, the other two servers would recognize the absence of the heartbeat from that server and will have just a second or two ago recorded the session information from that server, and then those two servers would very quickly distribute the load amongst themselves and pick up those sessions with the existing clients from the now down server. So this is system fault tolerance and redundancy. One or more of these systems can fail, and yet the system overall, the application or the service that application is providing, remains intact, and all the sessions that were utilizing the services, even on the failed server, are automatically transferred to the other servers in the cluster and continued on with very little obvious problem to the client that's actually using the service. He is able then to continue on with his session. So this is the clustered services that helps to provide system fault tolerance and redundancy. And of course, we are running then for the cloud services, in most cases, a virtual machine that lives on that clustered hypervisor. So we now have these virtual machines that live on this clustered array, and that makes these virtual machines also very fault tolerant. Now, we do need to be concerned about those virtual machines migrating across from one server to another. Let's imagine in this case, server 1 has 4 VMs running, and server 2 has 4, and server 3 has 4. Well, suppose one or more of the virtual machines on server 1 has a very high workload and has very high demand on resources. We might see that server 1 push one or more of the other virtual machines off of server 1 onto servers 2 and 3 to perform this load balancing. So this is VM migration across these various hosts that are running in this clustered array of the hypervisor. And this is for fault tolerance and high performance, and also supports the redundancy of these systems. Earlier, we talked about RAID arrays and redundant disk controllers. That's the disk mirroring and disk shadowing. And these are fault-tolerant disk arrays. And if we added a second disk controller, or perhaps even third disk controller, we make even the disk controller more fault-tolerant by having redundant disk controllers. To improve system fault tolerance and redundancy, we might also have secondary AC power. Now, one approach is for the data center to first connect up to its standard electrical supply from the power company on the standard electrical power grid. But parallel to that, go to a different power station, power grid, and pull a second pair of wires from that second power grid into the data center. Now, there's an upfront cost with this. As you pull those wires, of course, the power company is going to charge you a fair amount of money to get those wires pulled to your building. But after that upfront charge, there's not a whole lot of additional incremental cost. Your data center is only going to require a fixed amount of power. And so you're going to run on that standard first power grid's electricity, and you're not going to require any from the second power grid. Now, if that first power grid goes down, you immediately switch over to the second power grid, and you still are alive with electrical power. And that's one of your best solutions for redundant power. In addition to that, you might also want to buy generators that use fuel like propane or diesel fuel or perhaps even gasoline to keep these motors running, and the motors drive generators, and the generators produce the electricity. So you might actually purchase these generators and then have to keep a supply of fuel available for them to keep them running. We're imposing this upon the cloud service provider. We're going to require they have redundant power, that they have generators, and that they also run uninterruptible power supplies at the server level. So in this rack of servers, if the electricity fails, then the battery backup, the UPS, uninterruptible power supply, keeps the systems alive and stable until the generator kicks in or until you switch over to the second power grid and get electricity from them. So you might have 2 or even 3 of these redundant power supply technologies in place in your data center. You might require them of your cloud service provider. And then, of course, we might require that not only do you have the cluster array here in Oshkosh, you have a second cluster array over in Schenectady, and that's the co-location, and you're going to be running the same hypervisors and backups of the same virtual machines and the same failover capabilities. So system co-location is another great solution for system fault tolerance and redundancy. These would be some of the items that you might want to add into your cloud services agreement so that your cloud services provider has these built in as guarantees, and there will be penalties if he's not providing these particular features and functions to support your high availability and other aspects of security. As we continue with our lessons on developing the cloud services agreement, we're looking at compliance guarantees that we're going to tuck into this agreement to make our cloud services provider ensure that these services will be provided. We might not need all of these, but these are some of the things that you're going to want to consider. How important is this to you? Is it worthy of putting into the agreement? Now, in addition to data fault tolerance and redundancy and system fault tolerance and redundancy, another aspect of this is you need to provide connectivity fault tolerance and redundancy, or at least consider this in your agreement. Here we're talking about multiple high-speed connections into this cloud service. In other words, you from your corporate perspective need multiple connections to the internet, and the cloud service provider also needs multiple connections into the internet. Now, these need to be very high-speed connections, so you might wind up paying a premium to your carrier for this high-speed connectivity, because if you don't, you might find that the performance delays are so bad that it's not acceptable, that you can't actually maintain productivity. So be sure that you have multiple connections, both from the corporate side and from the cloud side. In the agreement, of course, it's the cloud side you're interested in. You'll want to have these redundant connections on your corporate side separate from this agreement. In addition to this, you want to ensure that inside the cloud environment that they're using some sort of redundant routing array. And this is typically called mesh routing, where there are multiple paths between any two routers, so that if any one router fails, I've got 2 or maybe 3 other ways to get from point A to point B across this routed environment. We may also need to have system application and data co-located. Now, this again is connectivity, fault tolerance, and redundancy. This says that if the ISP for this data center fails and we can't connect this data center to the internet, I've got another data center in another location that is still connected to the internet, and we can get to our applications and data at that other location. So this is connectivity, fault tolerance, and redundancy. A reverse proxy will support redundant clients. These are clients that are telecommuting perhaps across the internet around the globe, and they are connecting into perhaps your network. This now would be the way that our many clients can get connected into this one cloud location. So we might require that they provide this reverse proxy in multiple locations. And this would be to support many inbound clients at each location. And then again, as we said, the co-location for the multiple copies. In case this location fails, we have this reverse proxy that supports discrete clients from across the internet into the cloud environment. We also need to support some form probably of federated identity management. I might have many different types of systems and authentication mechanisms, and I need some overarching technique so that no matter what authentication mechanism this particular client used, his authentication is understood and accepted by other authentication-based systems. So this is federated identity management. Your authentication systems are on different platforms and using different technologies, yet somehow there's some overarching way that they all communicate. They understand the authentication that the other guy provided. We know who that guy is. We trust who that guy is because the other system authenticated him. We also can now use that access token to give him access to the resources he is authorized for. Federated identity management. And one of the goals of that federated identity management is to support the notion of single sign-on. Come in any authentication system, and we can use that authentication token from that one system on these other different types of authentication systems. Some of the techniques that are currently being used, of course, are the X.500 directory services and SAML, the security assertion markup language, OpenID, and OpenAuth or OAuth. So these are some single sign-on technologies that we might require our cloud services provider to guarantee that these will always be available, that he's providing them, and we need him to give us these services. None of these are absolute requirements. It's up to you to define which are requirements. These are just food for thought, things you might want to impose on your cloud services provider and have them documented in the agreement that he guarantees he'll provide these services, along with penalties for violation if he doesn't provide these services. Let's look at a collection of other types of things we might want to add into this agreement. We might need some specialized encryption standards that meet some accepted recommendations, for example, like those from NIST. Or we might have our own encryption standards that we need the cloud service provider to agree to and always implement, that it's something we're imposing upon him to implement rather than something we're going to do from our client side. If we're in a multi-tenant environment, we need that cloud services provider to properly isolate us from other tenants. If we're living on the same server systems and the same disk drives as other tenants in this cloud environment, they might find some way to break into our systems and steal our intellectual property and information assets like our data. We have to avoid the commingling of our data with their data. Make sure they are completely siloed and isolated from one another. We need the cloud service provider to assure us that he will appropriately harden the host server systems. Now, these are the clustered servers that we saw in earlier lessons that are running a clustered hypervisor application. The cloud services provider is very often responsible for these host systems. He has to be properly maintaining them, securing them, hardening them in all the proper ways, following manufacturers' recommended best practices, recognized perhaps even internationally. Not only does he have to secure the host systems, that's the operating system, he also has to properly secure the hypervisor. This is the application that is clustered and living on that host system. Now, that hypervisor, of course, is where we spawn the virtual machines on top of that. Very often, the cloud services provider is responsible for these components, and we need to ensure that that cloud services provider is properly hardening those systems. If we are acquiring virtual machines from the client, in other words, we're using platform as a service or software as a service, in this case, the cloud services provider is providing us virtual machines. Well, if those virtual machines, which is running an operating system like Windows or Linux, if those operating systems aren't properly hardened, those virtual machines might be the vulnerability. So I need the cloud services provider to guarantee me that he is properly hardening these virtual machine systems, these guest systems on the clustered host systems, that he's providing all the appropriate patching, the firmware, operating system, and application patching and updates on a very regular basis. As a matter of fact, most laws and regulations will require that any security-related updates are implemented 100% within 7 days. So it's critical that this become part of the cloud services agreement and that the provider guarantees appropriate patching, all within appropriate laws and regulations. We also need to have that cloud services provider assure us that they are prudently protecting the facilities, the hardware systems, anything that goes into supporting and maintaining and keeping these cloud services alive and available. That should also be one of the things we consider to tuck into our cloud services agreement. As we continue with our lessons on developing the cloud services agreement, let's continue to look at our compliance guarantees from the cloud services provider. These are topics that you might want to add into this cloud services agreement. Configuration management is something we might want to impose on our cloud services provider, because if they aren't prudently maintaining and managing the configuration of the cloud infrastructure, they might be the source of the breach. In other words, they are introducing vulnerabilities if they're not properly managing the configuration of their firewalls and their routers and intrusion detection systems and servers and other things along these lines. They should guarantee us that they are properly managing the configuration of these systems. Now, what this says is, first, that they have full documentation on what systems they're running and how those systems are configured. And second, they are performing audits periodically to verify that today that system is truly configured the way our standard document says it is configured. So their configuration documents should match the reality of that system's settings today. And this deals with the auditing component of configuration management. Now, when a change is required in the configuration of a system, it should go through an appropriate change control procedure. In other words, somebody fills out a form. That form says, this is a change request, this is what I want to change, this is why I want to change it, the security ramifications of the change, this is what I think it'll cost, this is a collection of new vulnerabilities that we might bump into, but this is how I'm going to defend us from those new vulnerabilities, etc., etc. And then it goes through an approval process with a truckload of documentation, and eventually it should get approved, assuming it's a viable change, and the change should be made. And then, of course, the change control procedure should update the documentation for that device. First, we'll verify that change was implemented correctly, and then we'll document the new configuration documentation for that device as part of the change control process. And that's kind of a subset or a close partner of the configuration management process. Now, in addition to configuration management and change control, we should have the cloud services provider routinely perform vulnerability scans and assessment and security scans and assessments to identify any security risks that might exist and identify any vulnerabilities. Now, this would include physical vulnerabilities and physical security. How easy is it to break into the building? Can a good social engineer convince a secretary to give him access to the wiring closet where he could plug in some sort of monitoring device that's going to steal the data? Things along these lines. So that would be a physical component. Then we'll also have a technical component where we're looking for security risks and vulnerabilities relative to the networking infrastructure. So this would be a penetration testing team targets the cloud service provider's environment without breaking things, of course. We want the pen testing team to identify vulnerabilities that exist in this environment. You can hire the pen testing team, or there are some automated tools that you could have them utilize, but we might build in the requirement for the cloud services provider to perform this vulnerability assessment and security assessment, perhaps quarterly, perhaps annually. And it also might be part of the legal and regulatory compliance component that we described in earlier lessons. We need to be sure that we have these areas at least considered, if not actually tucked into this cloud services agreement, that our cloud services provider will do these things. These next couple bullets deal with the notification and the penalties that go along with breaches of this agreement. Writing an agreement that says, I promise I'll do this if you promise you'll do that, that's a fine thing. But unless there are penalties built into the agreement, there's actually no mechanism for enforcement. There's no way to reclaim some loss for your breaches that the cloud service provider causes. First, we need in the agreement that as soon as there is some sort of incident or breach that affects my data, that the CSP, the cloud service provider, will notify me that I must be kept immediately aware of any sort of violation or breach or incident relative to my data, and that I am going to be an active part of the recovery and remediation procedures that follow, that put my data and systems back online, and then the remediation deals with how to defend myself from these things happening again. So I need to be part of that process. The next step is dealing with the actual penalties. There may be financial penalties we might impose on the CSP for violations. This would be if he promises me that 5 nines uptime that gives him 5 minutes and 15 seconds a year of downtime. And if he goes over that, he cuts my monthly fees by 25%. And that's for violating his 5 nines uptime guarantee. So you need to build these penalties into the cloud services agreement. And then finally, you also might need to include regulatory fines that might be imposed upon you for violations that they actually transfer to him. Your company will probably have to pay that fine. However, we then in the agreement say that if this violation was because the cloud services provider didn't perform as they promised, they will reimburse us for that fine. Also, we want to transfer as much of the liability, the obligations, onto the CSP if there are any breaches of these laws or regulations, if there's any criminal components, that they are also as liable as we are, and perhaps this might motivate them to really try very hard to not violate any of these laws or regulations, that they will meet their stated contractual guarantees that they've made about the services that they'll provide. Continuing with our review of the process of developing a cloud services agreement, we're now looking at more detail on the breach and incident detection, notification, response, and remediation plans that we, the client, will require of the cloud services provider, so that the CSP is now obligated to support these functions and satisfy these requirements. The first requirement says that the CSP must continuously log information relative to the infrastructure in the cloud and the activities of not just my users, but actually the cloud service provider's administrative staff, that the administrative staff will also monitor and audit the logs. That includes logging of the network activities as well as logging of the physical access that might be provided to the data center. The cloud service provider must continuously do these things. And then, in their monitoring and auditing procedures, they need to be able to quickly identify any sorts of incidences, any sorts of anomalies or breaches that might occur. These would be things like failures of devices, file or file system corruption, virus or other malware, willful breaches, accidental breaches, perhaps someone accidentally disposes of a hard disk that hasn't been properly wiped, and there might be an exposure of some personally identifiable information or some medical records. Then, of course, if the cloud service provider faces some sort of disaster like a tornado strike or an earthquake or a flood or a fire, something along these lines, that they immediately detect this and implement some sort of incident response plan. This incident response plan is part of the prudent management of the CSP. We, the corporation that is going to employ this service provider, will also have our incident response plan, but we now are requiring that the CSP also has a prudent plan that addresses these types of incidences and failures, and that they have a procedure to follow. They have resources that might be required to respond to that type of failure or breach or disaster. So that's another component that we might require in our cloud services agreement. Now, if any sort of incident like this occurs, we might also want to require that the CSP quickly notify us, the client, of this type of incident or breach. Anytime it affects any of our information assets, our intellectual property, or perhaps even the providing of the services that they've agreed to, if they are unable to provide that service at the standard that we've specified earlier in the agreement, then they need to notify us. Also, if there is some sort of incident that requires some sort of recovery and repair, we need to be part of that response and remediation process. In other words, while the CSP is actively pursuing a solution to contain the losses, to remove any sort of malware or eliminate any sort of corruption in the file system, whatever they're doing in response to move towards a recovery to a state of normal, we need to be participating in that. We need to be notified immediately when it begins, and we need to be a participant in the active response and remediation of this type of breach. Let's look at another requirement that we're going to tuck into this cloud services agreement, and that is we require that the CSP prudently manage their business. Our goal here is to help the CSP guarantee us that they will not go out of business. If they go out of business and they're holding all of our valuable information assets, our valuable information assets might be lost because there's no one who's going to be responsible for these losses anymore. The business is gone. There's nobody to pay the penalty. So we might lose access to our information assets and things along these lines. We require that the CSP establish the framework for governance so that they can prudently manage their environment. They must perform a risk assessment and perform risk management to help to ensure that the business will continue even if there is some sort of breach or disaster. First, you have to identify these risks, and you have to manage them to the best of your ability. First, with preventive controls to try and avoid the disaster or the disruption. And second, you need recovery strategies to bring the business back online at full capacity in case you can't avoid the disaster or the incident or the breach. So we will further require of the CSP a business continuity plan and a disaster recovery plan. To perform proper due diligence would need to validate that these plans look to be complete and effective. A lot of enterprises will simply write some generic BCP or DRP and check the box off. Yet in reality, they could never actually survive a disaster using these plans. They aren't effective enough. So we have the obligation to try to ensure that the plans that a cloud service provider implements or has in place will actually support the company in the face of a disaster. As we said before, part of the prudent management is that the service provider identify the breaches, notify us immediately, and let us participate in the response and remediation processes. The prudent management also includes an incident response plan, a notification plan, who to call in case of some sort of breach, and in what order of priority. There may also be a listing of the type of information you provide to that entity that you're calling. For example, if the disaster we're dealing with is a fire, the notification plan way up on the top of the list should be call the fire department. In addition, of course, you'll contact the CEO and the chairman of the board, and you'll also contact the clients that this fire might affect. This call should have detailed information, names and phone numbers, as well as after-hours phone numbers, and might also include what type of information we provide to those entities that we're calling. Now, the prudent management of the cloud service provider would also include security awareness training for all of their employees, and also would require the ongoing monitoring and auditing of information so that the CSP can identify violations and breaches and then could enforce those rules properly. Continuing on with our lessons on how to develop the cloud services agreement, the final aspect that you probably want to consider for inclusion in this agreement is the client's ability to monitor and audit the cloud service provider and to perform inspections, to have that cloud service provider maintain metrics on their performance and then provide reports to the client on those metrics and their activities. Once again, our goal here is for us, the client, to be able to monitor the activities and the processes that are occurring up in the cloud. So we're going to monitor our own employees as they access the cloud, but this is our ability to monitor the administrative staff of the cloud services provider, monitor their actions as custodians of these systems that are providing the resources that we're paying for. We might need to identify when they're performing maintenance, when systems are down. This might be part of their guaranteed uptime. We're going to keep a tally on that so that we can validate that they haven't exceeded their limits on the downtime for a year. So we need real-time access to these activities of the administrative staff. We need to be able to then audit these specifically. In other words, target these guys. We also might want to have the right built into the agreement to inspect the facility because the physical security of the environment could be essential. It could have an impact on the ongoing uptime for the cloud services provider. If we were to visit the facility and what we recognize is that the generators out back haven't been tested for months, they look like they're failing. As a matter of fact, there's a part missing off of this one. We might have serious concerns about the CSP's ability to satisfy the agreement, and we might invoke some sort of response to protect ourselves. We might want to verify that the CSP is prudently managing their own environment, and this would be a review of their policies, their security awareness training, their disaster recovery plan, things along these lines. So we should have the ability to review these documents of the CSP to validate our trust in them, the fact that we're putting a lot of our resources in their hands. We're investing a lot of capital in the development of our use of their cloud services, and we don't want to be experiencing losses because of their inability to satisfy the contractual agreements. We also need to be able to audit any violations, and if there are violations of these policies and procedures, how did the CSP enforce their policy? What remediation did they take? How did they detect it? How quickly did they detect it? How serious was the infraction or the violation? And how did they enforce this? What sort of remediation did they apply? So there are a lot of areas where we want to be able to identify what they're doing, because what they're doing severely can impact our ability to use these services and keep our services secure. We also should require that the cloud services provider reports to us periodically a metrics of the different types of events and incidences that would affect our confidentiality, integrity, and availability of our valuable information assets, especially if it's something as serious as a breach where information is exposed and we might now have to report back to HIPAA or to PCI of some sort of breach. We also want metrics of administrative activities, any sort of system or procedural changes. What type of configuration changes are you making to the infrastructure for the cloud environment? Does it affect the security or the availability of our information assets? Metrics of policy violations, metrics of uptime, and metrics of how much of these services are we actually consuming. So these are many of the things that you will want to consider including in your cloud services agreement. As we said earlier, that this is just an overview of selected issues that you might want to consider, and it is not legal advice. All contracts and agreements should be developed and reviewed and approved by the legal department for your enterprise. In this lesson, we're going to look at how to stay secure while you're using the cloud. Now, we've prepared our infrastructure, we've made plans for the cloud use, we understand what it's going to take, some of the tools we're going to need, some of the processes we need to implement. We then actually develop the cloud services agreement, the details in our contract with the cloud service provider. Now that we've gotten the agreement in place and it's all firmed up and it's got all the right details, let's look at what should we do to help stay secure with our use of the cloud services. These are the primary topics we're going to be looking at in this section. We're going to look at the cautious implementation of cloud services. We're going to move into the cloud cautiously. We're going to perform on-site inspections. We're going to perform auditing, and we might even do some testing to validate that the cloud service provider is performing as he agreed to in the contract, and that it is an appropriate level of activity and protection and maintenance that keeps our information assets confidential, with high integrity, and available at the prescribed levels. We're going to implement and use remote monitoring tools of our cloud services. Now, this would include our monitoring of our own employees and the monitoring of the administrators that are maintaining our cloud infrastructure, as they are perhaps maintaining the host operating systems, the hardware that's supporting our cluster array, things along these lines. So we need to make sure we understand what they are doing that might impact the C, the I, or the A of our valuable information assets. Also, part of that monitoring is going to be a review of the metrics. In the agreement, it's likely that we included the requirement that the cloud service provider report to us on perhaps a weekly basis on all sorts of metrics about incidences, violations, breaches, maintenance, downtime, all these details. So we're going to record these metrics and keep an eye on them to identify trends that indicate that there's some sort of failure happening here. This control isn't effective enough, they aren't enforcing their policies correctly, etc. We're going to implement our own incident response policies and programs, and we're going to participate with the cloud service provider relative to incident response in cloud services. So they need to report to us anytime there's any sort of breach, and then we work with them during the containment phase, the eradication phase, and eventually the recovery phase where we move back to a state of normal operations. We'll also implement some sort of key escrow, because we're going to be using a lot of encryption as we push stuff up into the cloud. We, as the IT administrators, have to ensure management that we can recover 100% of our valuable information assets. And as our cloud users encrypt content and push it up into the cloud, we need to be able to recover that content even if that client loses those encryption and decryption keys. We have to maintain a key escrow so that we can recover that stuff, because it's not actually the employee's information, it's the company's information, and we have the obligation to management to be able to recover all that. We need to monitor all the details of the agreement, and any place where we identify some sort of violation of this agreement, we need to enforce. We need to contact our legal department, identify what we believe to be some sort of breach or violation of this agreement, and then let the legal department move forward with some sort of remediation with the cloud services provider. We will be monitoring our own users and their use of the cloud, and we need to detect any violations, and then internally we need to enforce our own policies on our own employees. Let's look at the cautious implementation of cloud services. What does that mean? Earlier, we talked about securing the infrastructure as part of our core protection of our information assets. If we aren't protecting it internally properly, then we certainly can't extend our use into the cloud and expect that to be secure as well. So we secured the infrastructure, and part of that was a procedure to classify our data, classification. Now, this included proper assignment of value, a proper labeling of the proper classification, and then the implementation of protective measures at the appropriate level based on that classification. So we've done this already in the securing the infrastructure phase, so this should be a component already in place. During the preparing for cloud use phase, we identified data and applications that were acceptable for use in the cloud, and others that might not be acceptable for use in the cloud. Now what we're going to do is implement the data loss prevention technologies that help us not push stuff up to the cloud that's not authorized for the cloud, to identify when someone pushes it up and then first stop the upload and then alert us that someone has violated our policies and procedures, and that's where we would then take remedial action. So now it's time to implement that protection of pushing data up into the cloud that might not be acceptable for the cloud use. As we slowly migrate into the cloud, one of the rules of thumb is we will reduce risk by moving the least sensitive data into the cloud first. If we have confidential data that's of lower value and priority, and then we have internal only data that's of higher value, let's move that confidential data into the cloud first. And let's live on that for a while so that we can develop appropriate skills, appropriate procedures, verify that what we're doing is effective, that we're able to properly manage this type of information up in the cloud. And only as we start to get comfortable with our activities and our processes in the cloud should we migrate more sensitive information. So by moving into the cloud in this least value first and higher value last, then we will give ourselves the opportunity to learn the proper techniques, to verify we're doing the right things, to make adjustments as necessary and make improvements as necessary so that we can comply with our own policies and appropriately protect these valuable information assets. In this lesson, we're continuing with our look at how to stay secure in the cloud. One of the pieces that we might want to be able to implement, especially if it's part of our agreement and we've negotiated with the cloud service provider, is that we might want to perform on-site inspections and perform auditing and perhaps even testing of the physical environment that is the host for our valuable information assets. In our agreement, we may have included our ability to inspect the physical environment and be sure that this environment is properly and prudently maintained. Now, our goal here is simply to maintain due diligence and due care for our use in the cloud and verify that even if our cloud services provider satisfied our concerns years ago when we moved into the cloud, we should periodically go review this environment and be sure that it is being properly maintained. If the management of the cloud services provider isn't prudently maintaining this physical environment, we can't rest assured that our valuable information assets are being properly protected. Another component of staying secure in the cloud is our ongoing remote monitoring of the cloud services. Once again, this should be built into our contractual agreement with the cloud services provider, what we want to verify is that all the things we've included in our agreement as far as the services that we're requiring and paying for are being supplied, and that the proper maintenance also specified in our cloud services agreement is also being performed, that we're actually getting all the services that we required in our contract. We also need to verify that users are following the policy. Now, this is kind of an internal thing here. However, we also want to verify that the cloud services administrative staff is performing following their policies. Their policies become an extension of our policies, because if we're subject to HIPAA law, our contract with the cloud services provider includes all the requirements of HIPAA law. We need to monitor our own internal employees as well as the administrative staff and their activities as they support and maintain the cloud services infrastructure. We need to be sure that the security controls are in place and are effective. So here we might need to periodically monitor and perhaps even test various components internally, such as our data loss prevention systems. We might want to willfully, as a test, try to push out something that the DLP system should catch. We might want to put a sniffer on the wire between us and our cloud services to verify that the information that's flowing up to the cloud is properly encrypted. So we need to validate that our internal controls and the controls we've specified in the infrastructure itself are in place and are effective, and that only our users are authorized to access our sensitive data. However, from time to time, the CSP administrative staff may need to maintain a database or move a database, make a copy of it, for example. If they are accessing our valuable information assets in a manner that could lead to exposure, we need to validate that it is part of their policies and procedures, that they are actually performing their duties as specified in their policies and within our contract. We also should be getting reports back from the cloud service provider that tell us about all sorts of details relative to our use of the cloud. These should be logged over time so we have ongoing metrics and we can identify trends. And if they're bad trends, then we can take remedial action. Now we might need to implement a new security control or make an adjustment to a procedure, or we validate that some user or set of users aren't following policy. We need these ongoing metrics to verify the effectiveness of our control. Then that would include policies, that would include our physical controls, and that would include our technical controls. So some of the metrics we need to monitor will be our usage and our costs for that usage of these cloud services. And we need to know what we are currently consuming and what we've consumed historically so that we can properly forecast and perhaps budget and make adjustments as necessary as we grow deeper and deeper into the cloud and require more and more services. We might also identify access of our valuable information assets by user. In other words, this is sort of an auditing function that tracks each user and how much time they are accessing cloud resources, the date that they are accessing it, what resource they accessed, and also how much information did they access. Because if we see some user that has been active in the cloud for 30 hours in the past 7 days, and they were uploading or downloading a terabyte of information, there might be something happening here that we need to know about. It might be some sort of breach. It might be some exfiltration. If it's a download from the cloud, it might be somebody is improperly storing content on our systems. So anytime we see any high numbers on the amount of time that a user is accessing the cloud services and the volume of data, either up or down, these could be red flags to some sort of incident or perhaps breach. Now, we also should be maintaining metrics on security issues. Things like a user trying to access a database that he shouldn't be accessing, a user trying to access files that he's not authorized to access. So any access denied, especially repeatedly from the same user, this is a red flag. This is an indication of somebody's poking around and trying to do something they're not authorized to do. Other security issues would be failed logins, some infrastructure like a firewall that might have failed on the cloud infrastructure, things along these lines. Anytime this type of stuff occurs, and I expect the cloud service provider needs to provide me this in a weekly or monthly report. This is all detailed in the cloud services agreement, and I need to get these back from them. Review these reports and then take remedial action any place I see trends that don't look healthy. I also need metrics on outages. We need to keep track of this on an ongoing basis to validate that the cloud service provider is actually providing us the required uptime as stated in our contractual agreement. And then, of course, anytime the CSP has any sort of events that might affect our valuable information assets, we need metrics on these. We need to know when they happen, how often they happen, the nature of the incident. We need to know when systems are going down for planned maintenance. We need to know when there are configuration changes for systems, etc. All these details should be part of this ongoing report that we get that would contain these metrics as we've described. As we continue our review of how to stay secure in the cloud, we have to look at another component, incident response. This is when the CSP identifies some sort of incident, some sort of breach. They need to immediately notify us as they are implementing their response procedures. And once again, this should be part of our agreement with the cloud services provider, because not only do we need to be notified anytime an incident or a breach occurs, we need to participate in the containment activities, the eradication activities, and the recovery activities that will bring our services back to a state of normal. Containment activities are about stabilizing the environment and minimizing losses. We first will want to be able to participate with the CSP and their incident response team on how we contain whatever the nature of this breach is. How do we stop these losses? The next piece is, how do we stop this process from existing on our system? So this is eradication. The eradication process is one of the more delicate processes. A lot of people will delete an executable and think they've eliminated the virus, for example. Very often, a sophisticated piece of malware will implant itself in numerous places, and it will actually enable itself to reinfect and reactivate the payload. Just by doing a cursory eradication of any sort of malware, we are putting at great risk the rest of our valuable information assets if we return this system back to production. If we decide that there's malicious software in a system, we need to be 100% certain that there is no remnants, no residue, no other copy of this malicious software on the box, that it is truly clean before we return it back to normal use. Very often, we will reach the conclusion that it is safer to perhaps re-image it from a known good image and then bring it back online with restoring of applications and data. That's the only way we can get a known good system. That eradication process could be one of the most important things that we do, and the validation that these eradication activities are actually effective. And then the recovery activities, the goal here is to get us back to a normal state of operations. And this is where we would get as many systems as we needed back online, our data restored, and we return to a state of normal where we have declared that the incident is now over and things are moving forward as they should under normal operations. Now we're going to do a lessons learned, an incident review, where we look at what went right and what went wrong. What failure did we have that allowed this breach to occur? What vulnerability existed that needed a countermeasure that we didn't have in place? How can we prevent it from occurring again? If it does happen again, what can we do to minimize the losses? We'll be looking for those changes and improvements and see if we can implement some of these controls to try and mitigate and avoid these losses. We're going to look at key escrow. Now, we've discussed this a time or two. We've identified the need for it in our planning phase. Here's where we should implement this key escrow and be sure that it's being used properly. Once again, IT department has a responsibility to management to be able to recover 100% of any and all data. If our users are required to encrypt content as it goes up to the cloud, that means there are encryption keys that are required in order to decrypt that information and make it useful to us again. So if the user who pushed this stuff up to the cloud after encrypting it loses his decryption keys, we might have just lost that information. And that's the company's valuable information asset, and it's my job to ensure I can recover it. So I need a copy of every decryption key that we utilize. This is our key escrow. This is a very valuable repository, because if a bad guy could break into this key escrow, he could steal all of our encrypted information. All this stuff we're protecting up on the cloud, he now could be potentially accessing it and compromising the confidentiality, the integrity, and or the availability of those valuable information assets. This key escrow must be very strongly secured. We might even secure it in such a manner that it takes multiple people simultaneously to agree, and these would be our highly authorized people. Several of them are required to come together and recover any keys. It's too much authority for any one individual to be able to recover these decryption keys individually. 3 people come together and collectively now are able to access the vault that the keys are in. And this way we help to reduce the possibility that one bad guy can go into this vault and steal all the keys and then go compromise all the data. In this lesson, in Staying Secure in the Cloud, we're going to look at the enforcement of the contractual agreement that we have with the cloud services provider. We can't simply sign this document and tuck it away in a folder and never look at it again and just assume that the cloud service provider is actually performing at the contractually agreed upon levels, that they're performing all the details appropriately. We have to know the agreement. It has to be readily accessible to us so that we can validate that the cloud service provider is actually doing everything that they've said they were going to do. If there are any violations, they need to be aggressively addressed. If we don't address these, in essence, we are negligent in our prudent management of our service provider, and this could lead to huge losses if there's any sort of litigation due to some sort of breach. If we don't aggressively enforce our agreement with the cloud services provider, we assume a greater liability and a greater risk for greater losses. So we really must pursue this. Now, if there is a violation, one of the things we should do is notify the legal department, work with the legal department. If the cloud service provider hasn't been able to satisfy our concerns and our objectives, of course, the first thing we'll do is we'll call up the CSP and we'll say, hey, get that thing online, or whatever the deal is. But if we aren't getting satisfaction through this first level of remediation, then of course it's time to get the legal department involved, and that's where they would perhaps start some sort of legal activity. If we're not comfortable that the cloud service provider can satisfy the contract or is willing to satisfy the contract, we might consider moving to a different cloud service provider. Of course, that's a whole lot of work, it's a whole lot of cost, but at the same time, it's probably less cost than what the losses might be if this cloud service provider is going to mess things up and cause a billion-dollar breach. So we might need to consider identifying a new cloud service provider, interrogating them properly, appropriately, reviewing a new service agreement with them. Perhaps it's an opportunity to refine our service agreement. Some things weren't working the way we hoped they would with the agreement, so perhaps we can refine the agreement and tune it up. It might be an opportunity to get a better agreement with a new cloud services provider. So it's a painful move, but at the same time, if you aren't getting satisfaction, if you're not getting compliance, then you probably can't trust this CSP, and it's not safe to leave your valuable information assets with this CSP. Moving forward, we're going to look next at monitoring our cloud users and then enforcing our policy on our own internal employees. Our users should all have been through a security awareness training course, and that security awareness training course includes several different agreements. One of them is an acceptable use policy, and that acceptable use policy should be a summary outline of all the specific compliance requirements that we impose upon them. We will, in our acceptable use policy, identify the top 10 or 15 specifics on how they are authorized to use cloud services, and then specifically where they are not authorized or procedures that would not be allowed. So this acceptable use policy is our first sort of guideline, if you will, on what the requirements are for our users. And we will compare their activities to this acceptable use policy. If we're not monitoring those user activities in the cloud, Once again, we're negligent. If we don't know what they're doing, we can't enforce. And if we can't enforce our policies, then we're negligent. So we first must monitor their activities in the cloud. Again, some of the things we'll be looking for are who's in the cloud the most based on time and who is accessing the most amount of data. So the volume of information that is accessed is another item. And if we identify the high numbers here, who is accessing for the longest amount of time and the greatest amount of data, these are very often the ones that we really need to keep a close eye on, because this might already be an indication of a breach. And if we do identify that it is normal activity for this user, that's a good thing, but it also means that there's the potential that this user has a great deal of access, and because of that great deal of access, there's the potential that that could lead to an easy breach. Whether it's a mistake or whether it's willful activity, these are the ones we really have to keep a close eye on. If we only implement partial or inconsistent enforcement of our policies, then there's a potential that this becomes some sort of discrimination. Now, if we are monitoring our employees and our job is to enforce policy, we have to implement sanctions. These are penalties, if you will, that we have to impose on the people that violate our policies. Now, the penalties might be nothing more than they get yelled at by the boss and they have to go resit remedial security awareness training because obviously they didn't learn it the first time. So we might find some ways that we punish these employees, and that could range all the way up to termination. Another way that we can remediate this breach or violation is by implementing some new security control or controls. They come to us out of the categories of administrative controls. These are policies and procedures. They come out of the physical controls like locked doors, security guards monitoring badges on the way in and things like that. And it could also be technical controls like a new DLP system or another IaaS mounted on some egress point of our corporate network. We might implement some sort of remediation anytime we identify a violation. In this lesson, we're going to wrap up our series on cloud services and security. As a course review, let's look at what we concluded cloud services are. They are software as a service, platform as a service, and infrastructure as a service. That's the foundational components of the cloud services. It could include federated identity management. It also could include security as a service, managed intrusion prevention systems, things along these lines. We looked at the different deployment models, private, community, and public, and we also looked at the implementation of these cloud services both internally and externally, and then looked at a combination of these services. Who would manage the infrastructure and who would be responsible for purchasing the hardware. Next, we looked at how to secure the infrastructure. This is your internal corporate network. The notion here is, if your internal network isn't secure, you can't migrate into the cloud securely. Your breaches will occur at your internal network, and your extension of services that you put up into the cloud, there might be even more secure in the cloud until you pull them down, and then you have a breach at your internal infrastructure. So we have to first prudently secure the infrastructure of the enterprise before we could move forward and occupy cloud services with our valuable information assets and expect them to remain secure. Next, we looked at how would we prepare our internal environment as we anticipate moving into the use of cloud services. And they included some things as identifying the types of services that we're going to need, recognizing the strengths and minuses, the costs, the security risks associated with the different cloud implementations, things along these lines. This would include policies that help us manage our processes in the cloud, the way we govern the third-party service providers. This is preparing for cloud use. We haven't moved into the cloud yet, but we might need to purchase new security controls. As we anticipate moving into the cloud, we'll need these controls in place before we actually need to turn these security tools on our data assets in the cloud. Then we need to look at how to develop a prudent cloud services agreement. And this is something that you, of course, will work closely with your local legal department. There are just a slew of details that you need to get tucked into this agreement. including the level of service, the guaranteed uptime, the way that the cloud service provider will ensure that they remain in business, and this would be their disaster recovery plan, business continuity plan, incident response planning, risk assessment and risk management practices. This is part of developing the cloud services agreement. So we assume now at this point that we have a secure infrastructure, that our preparations are appropriate. We've got all the right pieces in place. We've got our users trained on how to use the cloud. We have the users trained on the security tools that we're going to be implementing and how to utilize them and what it means when we classify our data, things like that. We're now ready to start migrating into the cloud, and we need to do this securely. The first phase, as we saw, is to cautiously move into the cloud by implementing our least valuable data assets and processes in the cloud first. And then only as we gain skill and experience and develop a certain comfort that we're prudently using these cloud services, we have them managed properly, that our people aren't violating our policies, we have this under control, now we can start to increase the value of the data assets that go into the cloud and the processes that go into the cloud. So we're going to move more deeply into the cloud with more of our valuable information assets. We're then, of course, going to monitor closely all the details of the agreement and the way the cloud service provider is managing their end of the deal, that they're maintaining the systems properly, that we're getting the proper uptime, that we're monitoring the metrics on our usage. This now is how to stay secure in the cloud. And that's where we complete the course. Thank you for your time and attention.